So good morning, everyone. I'd like to thank you all for coming today. My name's Cecilia Solhoff. I am an outreach coordinator and press spokesperson in the Wireless Bureau here at the FCC. We're going to go over some logistics and housekeeping stuff in a little while, but in order to get us kicked off on the right foot today, we have some remarks from Chairman Wheeler.
I was worried about you. Let's see, who is the chairman this week? Cecilia, thank you. I think it's Cecilia. Welcome, everybody. Glad you're here. Thank you very much for coming. This is the second workshop. I'm just looking at the lineup of all-stars that we've got here, thanks to the folks in the Bureau. This is the second workshop that we have had on this topic. The bad news is that the workshops have been 4 years apart, and this is an issue that is more important than that. But it's an issue that is about to become even more important, and that's why this is very timely today. I think we can all stipulate that the infrastructure of the 21st century is wireless. And it's something that we have come to take for granted, including the antennas. And, you know, there's a lot of focus in this agency and in the industry on spectrum. But the reality is that antenna siting is equal in importance to and the way of mitigating the tightness that exists in spectrum, since they aren't making it anymore. So the focus that you all are going to have on siting of antennas is crucial to where we're going in the 21st century. And it's going to be made even more crucial and more challenging as a result of 5G. So let's start with making no mistake about what we've talked about in this room with the Commission frequently. And that is that 5G is a national priority. The rest of the world has organized to deny the United States the kind of leadership in 5G that we have experienced in 4G. An experience that produced hundreds of thousands of jobs, innovation, and economic growth essential to this country. There are three components to leadership of this nation in 5G. One is spectrum and the flexible use of spectrum. Two are the antennas that distribute to that spectrum. And three is the backhaul that links those spectrum, those antennas. Now, we are already dealing with items 1 and 3. We will, at the July meeting of the Commission, identify the spectrum to be used for 5G and the principle of flexible use of that spectrum so that carriers can innovate and evolve. We have already begun, at the last meeting, a proceeding on backhaul to make sure that the connectivity of the increased number of antennas that are going to be necessary for 5G is also assured. Those of you in this room were responsible for priority number 2. And that is, as we move to new frequencies, higher frequencies that require smaller, that serve smaller areas and require more antennas, how do we site them? I mean, siting has always been a challenge. We have monumental respect for the realities that you all face in your jobs every day. And adding to that now is the fact that if we can site 5G, we can be the world leaders in 5G. So, we probably also ought to explain and focus on on just what 5G is and why it's important. Sure, it's 100 times faster. Sure, it has millisecond latency. But it's more than that. And we collectively need to do 2 things. One, we need to internalize the fact of what 5G really represents. And 2, we then have to make sure that we're telling that story. Because 5G isn't just speed and low latency. 5G is the technology that allows everything to disappear except antennas. I mean, stop and think about it. In the physical world, we went from the desktop where the phone and the computer used to sit, and now they're out in the cloud. And that's what 5G is all about. It's about connecting things that you never stop to think are connected, but what are essential to our lives. So when things disappear in terms of the interface that they have with consumers, it makes all the more important that the distribution to that disappearance be available. Everything goes into the cloud with minimal physical involvement except the antennas that allow everything to disappear. And that's the challenge that we have to face here today, is how are we going to build out that infrastructure that allows us to continue our leadership as a nation, to continue services to our consumers that they don't even stop to think are happening because they have all disappeared. We'll do things on our end. As I said, we've got the Spectrum decision in July. We have just begun the business data services proceeding for backhaul. The 2011 pole attachment order streamlined DAS on poles. We've got an upcoming public notice that I'm sure John will tell you more about that's going to go out that talks about eliminating review by the federal government where there's no material impact. We'll do our best to do things at our end. We're interested in hearing from you about what you think we ought else to be doing. But if I go back to where I began, and then I'll shut up, this is a three-legged stool. Spectrum, siting, and the connection of the sites are indisputable in terms of whether this country will be the world leader in the next generation of how the 21st century connects. And it's in the context of how do we attack that second challenge that we're really grateful that you're here today. We really look forward to the dialogue and discussion that will come forth, because we really have a collective challenge. Thank you very much. Cecilia, back to you.
Thank you, Chairman Wheeler. I got it right that time. Next, we'll have some remarks from the Wireless Bureau Chief here at the FCC, John Wilkins.
Thanks, Cecilia. And let me just extend a welcome to everyone here on behalf of the Wireless Bureau and the whole Commission. So thank you for joining us for NEPA and the Wireless Telecommunication Bureau's joint workshop on distributed antenna systems and small cell technologies. Workshops like this one that bring together representatives from local government, industry, the public, federal stakeholders like those of us who are here every day. It's incredibly important. It allows us to share experiences and also help foster the understanding that's going to be important to work through these issues going forward. Now, so as you heard from my boss, Chairman Wheeler, this is a very important topic for us. He doesn't just say that to all of you. He says it to us every day. Behind the scenes too, how important the 5G priority is. And I think the three-legged stool analogy he described is exactly how we're going to attack things. And importantly, for a three-legged stool, all three of those legs are equally important, because if one of them isn't there, the stool's not going to stand up. And so, spectrum policy gets a lot of the kind of day-to-day attention. If this was a kind of a football game, the spectrum policy is it's the downfield passing game, and you talk about millimeter wave spectrum a few times. It sounds very interesting, and it is, and it's critical. But infrastructure and the topics we're going to talk about today, it's the offensive line. If we do not have good solutions to the many challenges that are very real in this space, doesn't matter if we get the spectrum policy right, doesn't matter if we get the backhaul issues right. So it is absolutely as critical to us here as the other parts of the stool. So today's workshop, we're going to just talk a lot about the power, the impact, the issues associated with DAS and small cells. We'll talk about case studies where communities, infrastructure providers, and carriers already have worked together in different ways to meet some of the demand we're already seeing for just greater and greater deployment and use of wireless data. We'll hear about how San Francisco dealt with data demands at the Super Bowl, how Philadelphia handled the extraordinary demands associated with last year's papal visit, how Boston has encouraged cutting-edge deployment, and also, though, trying to manage the unique character and historic, core that Boston has. One other thing just to really emphasize, and the chairman touched on it, the small facilities like we're talking about here, they really are fundamentally different than the whole first generation of communications towers that really have defined the landscape for the last 20 years. Smaller, easier to conceal, much easier to install on an existing structure, much smaller propagation sizes, and all that does add up to a lot of opportunities, a lot more creative ways to deploy, access to many more points that you could put up infrastructure, indoor deployment, especially to deal with those very, very dense deployment scenarios where today's networks are increasingly congested. So lots of opportunities, but boy, those opportunities bring big challenges too, two big areas. First, it's just different, right? I mean, all of the just day-to-day coordination, operational activities, and all those new use cases are just different issues. And unlike traditional towers, we don't have years and years of experience in just how to work through those issues. And also the higher volumes, right? The flip side of those much smaller cells is just a lot more of them to cover all the demand out there in the country. And, right, if you had to be honest, the public sector is actually not great at sort of exponential changes in volume in quick time frames. And that's, in the essence, what we're trying to do. How do we create coordination processes to allow not thousands or hundreds of thousands of antennas to be deployed, but millions and tens of millions? So just a few numbers from some of the filings and information we're receiving. Some analysts predict more than 37 small cells deployed by the end of next year, 16 million DAS nodes by the end of 2018. Some studies already say that small cell DAS overall capacity will exceed that of traditional macro cell capacity within the next 2 years. So are those right? I don't know, but the trend of just much higher volumes, and going back to the chairman's main point, patience is not a virtue in this space, right? We don't want to spend the next 5 years figuring out how to do this, because by that point, we probably will have already missed the opportunity the chairman described, which is for the U.S. to be the world leader in 5G. So this leg of the stool is absolutely a critical leg. Just with that, I'll thank you again for being here, for the participation. Thanks, by the way, to the Wireless Bureau, Chad Breckenridge, all the staff work that we did to organize this, because it's a very important session, and look forward to listening to a lot of it. Thank you.
Thank you, John. And now with our concluding final remarks, we have Jody Miller, who is the president of NEPA.
Good morning. My name is Jody Miller, and I'm the president of the National Association of Telecommunications Officers and Advisors, NEPA. NEPA is a national nonprofit membership organization that promotes local government interests in communications and services and serves as a resource for local officials as they seek to promote communications infrastructure development. NEPA is proud to co-host today's workshop, and I would like to thank the Commission and Chairman Wheeler for supporting today's event, and we applaud the Wireless Telecommunications Bureau, and especially Don Johnson and Greg Vadas for the hard work they have put into planning this workshop. No one is more supportive of increased wireless infrastructure deployment than local governments. We know that providers are under increasing pressure to provide better and faster and cheaper mobile services to their customers, because those customers are our residents and our businesses. And these services are the heart and soul of our public safety operations as well. In the rush to provide these services, we must not lose sight that deployment must be done in a manner that recognizes local rights-of-way authority and protects public health and safety. For the past several years, NEPA has been working with industry and the FCC to better educate local officials and the public on new wireless services and the technologies, equipment, and installation practices that go with them. In fact, as the chairman mentioned, in 2012, NEPA and the FCC held a joint workshop on siting practices much like the one we are having today. We have prepared materials, held webinars, and spoken at numerous conferences, including industry events, in the past few years to assist our member communities in better understanding and implementing various FCC siting rules. Has everything gone smoothly? Of course not. There have been a few bumps along the way, but for the most part, local governments and industry have been working in a cooperative manner to bring the unbelievable promise of advanced wireless communications to all Americans. We have found that the more we talk and listen to one another, the better the outcome for everyone. And so we look forward to continuing that dialogue today and moving forward with further efforts. Thank you.
So now I get to go over the logistics and housekeeping stuff. So we do have copies of the agenda and a program with the speaker bios on the back table. Also on the back table, we have some note cards and pens. Parts of the workshop today are interactive, so you can ask questions. If you're sitting here in the audience, you can ask questions by getting a note card and a pen and writing your question down on the note card. We have some FCC staff, Irene in the back, Sharif, I think, is here somewhere, myself, Sharif's here, myself. Just raise your hand if you want a note card or if you have written a question down and you want us to get it from you, and we'll get it to the FCC staff. And given time constraints and the number of questions we receive, we'll try to get to as many as we possibly can. Like I said, we are live streaming this. For those who are watching it live, you can send an email to livequestions, livequestions, at fcc.gov with your questions as well. Please include your name and the company that you're affiliated with the questions here in the room and the ones that you email in. Because we are live streaming it, we want to remind any of the speakers and panelists and our moderators, as you're talking, please speak directly into the microphones. I know a lot of times we're going to have some robust conversations going on. If you turn your head like this, you can't hear what's going on, so it won't be picked up here in the room, it won't go on the live feed, and it won't go on the video recording. So now, before we get started with Jeff and our legal overview, we will have a few opening remarks from Commissioner Mike O'Reilly.
Well, thank you all. And looks like you all brought some wonderful weather to D.C. It's just been great weather we've had. So I want to thank you all for coming to the Commission today to talk about very important issue, distributed antenna systems and small cell infrastructure siting. This is a topic that has been a priority of mine. In fact, there may be some of the Commission who prefer that I not push so hard. But then again, what would be fun in that? Sometimes the job of a commissioner is to methodically move the ball forward. In other cases, such as this, we need to push for an up-tempo, high-caliber outcome given the importance of the issue. Most everyone in this room understands the importance and benefits of DAS and small cell technologies. Generally, Americans now seek access to communication services everywhere and at any time. To meet these demands, small cells will be needed to be ubiquitous, especially in high-density areas, to promote spectrum reuse and to meet the demands for these wireless services. We no longer live in a world, particularly in the urban markets, where network deployments can be based on macro towers alone. To be clear, macro tower reform remains important too, but I want to focus today's comments on small cell systems. Despite the obvious need, the deployment of small cell technology has been somewhat slower than projected. In my meetings with industry participants, many have stated that the lack of progress is because of infrastructure siting challenges. This is why it is so important for the Commission to finish up the process to further exclude small cell and DAS systems from certain regulatory burdens before the upcoming fall. But this process alone is unlikely to fix all problems. I continue to hear legitimate complaints about localities placing hurdles in front of small cell deployments. Issues range from permitting problems and excessive fees to forced tolling agreements and de facto moratoria. Citing approvals, and rights-of-way, which are especially important for small cell systems, appear to be particularly problematic. Such cases are worthy of the Commission considering using its preemption authority. These trends are equally troubling as we move towards the next generation, or 5G services, that tout high speed, capacity, and latency, goals that can only be achieved through the densification of networks. And the use of high-band spectrum will only exacerbate the problem of insufficient siting. Millimeter waves only go so far, so small cells will be needed to be deployed expeditiously and in a cost-effective manner to realize the promise of 5G. The unwelcome alternative would be for companies to build an excessive number of macro towers. Previously, I have highlighted the example of Destin, Florida, where a company relied on a permit to build 2 small cell poles on a right-of-way, only to have the locality change its mind and require that the small cell facilities be taken down. Even worse, reasonable siting alternatives were rejected, and it was decided that no small cell towers should be placed on a city rights-of-way. That's simply outrageous. These are services that Americans in their very communities expect and want, and they only be acquired by building the networks. I am pleased that NETOA's involvement in today's workshop. This association and others are critical in ensuring that their memberships do not commit the deeds that earn the bad actor moniker. Commissioners tend to hear more about bad and less about the good, so I apologize for spending so much of my time so far on the negative. I'm pleased that today's panels will also focus on the case studies that have worked and that could help provide industry, localities, and the Commission with ideas of how we can facilitate future developments and deployments. It is important to remember that infrastructure siting not only affects the placement of access points, but is also needed for entities looking to provide backhaul solutions. Panelists hopefully will discuss how the Commission can facilitate extending backhaul to DAS, DAS, and small cell systems. But while we're talking about backhaul, this past month the Commission voted on an order and further notice in the long-pending special access proceeding, or business data services to some. We heard the argument at the open meeting that one justification for the item is to ensure that there is sufficient backhaul to support the coming demand for 5G wireless services. Taking the Commission's proposal to its logical conclusion, however, the best way to maximize backhaul would be to give it away for free. Even if it's not exactly free, why would providers pursue an aggressive broadband deployment strategy if they knew that the reward would be efforts to restrict how they price and how they market their services? It doesn't make any sense. The best way to incentivize providers to build backhaul is to remove barriers to deployment, not add unsubstantiated new burdens. Well, I will not be able to spend the entire day watching the panelists today. I will catch most of it upstairs on TV, and that I don't, I will catch on video. So I want to thank you for your brief moments of listening to my presentation, and hope you have a wonderful program in the day ahead. Thank you so very much.
Thank you, Commissioner O'Reilly. So as you might have seen from the agenda, we're jumping around a little bit. So now we're going to get started with Jeff Steinberg. Jeff is going to give us a brief legal background. And today's workshop, we're going to be discussing DAS and small cell technologies and solutions. And we want to focus on the best practices based on real-world deployment context. So to get us started, Jeff Steinberg is the Deputy Chief in the Competition and Infrastructure Policy Division in the Wireless Bureau here at the FCC.
All right, welcome everybody, and thank you, Cecilia. I'm certainly going to add my words of welcome to this event. We had a great workshop 4 years ago. It's been an awfully long time. An awful lot has happened in the world, so there's plenty to talk about. I think it's been too long, but I know we have a great lineup on today. And your focus today, as Cecilia said, is going to be on the technologies, on how what you can all do, those of you from the industry and those from municipal governments, to work together to make the DAS build-out for 5G work in the best possible manner. But I am going to begin with, just sort of a brief overview of federal legal background, if I can get the slides up. Let me just see which is the next. Good. Okay. So I'm going to cover three things pretty quickly. First, the statutory provisions, the federal statutory provisions that underlie, that are relevant to local siting and DAS deployment. Then I will talk a bit about the infrastructure report and order that the FCC handed down in October of 2014. And finally, just a little bit, although the focus today is on municipal siting regulation, just a little bit on federal review under the National Environmental Policy Act and the National Historic Preservation Act. I hope that after I'm done, I will have a few minutes to take some questions. As a reminder, there are the note cards and pens over by the table, and we've got our folks around willing to take them. And for those on the web, live questions at fcc.gov. So, we move in here. There are basically two federal statutory provisions that are relevant here. One is Section 332C7 of the Communications Act, which was added in 1996 as part of the Telecom Act. Probably most of you are familiar with Section 332C7. At its core, what it does is it preserves state and local authority over the siting of personal wireless service facilities. The big ones, of course, are the towers and that are for the macro facilities, but it also applies to collocations of antennas. It preserves the state and local authority, but imposes certain restrictions on how that authority can be exercised. One, the state or local siting authority may not unreasonably discriminate among providers of functionally equivalent service. It may not regulate the siting in a manner that prohibits or has the effect of prohibiting the provision of service. Decisions must be made within a reasonable time. A denial of an application must be in writing, and it must be supported by substantial evidence in a written record. And finally, the siting authority may not regulate based on the environmental effects of radio frequency emissions to the extent that those emissions comply with the FCC's rules. It also provides that if there is a dispute over the application of that provision, disputes go to court, not to the FCC, with the exception of regulation based upon RF emissions, which can be brought to the FCC. There's a wealth of case law out there on the implementation of Section 332C7. I'm not going to talk about that, but I do want to just emphasize a couple of things. One is that it does apply to DAS and small cell facilities, provided those facilities are used for personal wireless services. Personal wireless is defined as including commercial mobile radio services, as well as unlicensed telecommunication services and certain fixed wireless services that could be used as a substitute for the local wireline exchange. So as long as the DAS is used for any of these things, those facilities are covered. The Commission clarified that in the 2014 infrastructure order. The second thing from the shot clock ruling in 2009 is the FCC defined a presumptively reasonable time as 90 days for collocations or 150 days if the facility involves constructing a new structure. If the local or state government, if it has siting authority, does not act within that presumptively reasonable time, then the applicant can bring them to court, and in court, then the government would have the opportunity to prove that under the unique circumstances of the case, that time was in fact reasonable. Okay, the other provision is Section 6409A, added in 2012 to the Act, and I've just got the text of it right here. A state or local government may not deny and shall approve any eligible facility's request for a modification of an existing wireless tower or base station that does not substantially change the physical dimensions of such tower or base station. And an eligible facility's request is defined in the statute to include the co-location, removal, or replacement of transmission equipment. In the Infrastructure Report and Order, October 2014, the FCC, among other things, one of the major parts of that order was that we adopted rules to implement and to enforce Section 6409A. And those rules are codified at Title 47, Section 1.40001 of the Code of Federal Regulations. The FCC's decision also was affirmed last year by the Fourth Circuit U.S. Court of Appeals in Montgomery County v. FCC. So what I'll do now for just a few minutes is talk in a little bit of detail about what the Infrastructure Report and Order held regarding Section 6409A. It's a pretty complex decision, so to really understand it, go directly to the rules, go to the Report and Order, but I will go into a bit of detail, not spend too long, because I'm sure most of you are pretty familiar with it already. So the first set of questions we addressed was, what does 6409A apply to? It applies to facilities that are used for any commission-authorized service using radio waves, basically. So that's, we interpreted wireless very broadly in that context to include things like broadband, to include authorized unlicensed services, and so forth. It applies the kind of facilities that are covered by it, what you can co-locate under that provision, are the antennas and also any other equipment associated with and necessary to the operation of the antennas. Specifically held, I'll highlight a couple of things. That includes DAS. It also includes power supply and backup power. What can you co-locate it on, subject to this provision? The statute talks about an existing wireless tower or base station and does not define those terms. So that was left to the FCC to define in light of what makes sense and what Congress apparently intended. We held that it includes any structure that was built for the sole or primary purpose of supporting antennas. That would be a tower, regardless of whether it actually has any antennas on it or not at the time of the application. And it also includes any structure that at the time of the application houses base station equipment. And that we held was the meaning of existing base station. One caveat on that, the tower or base station must have been approved pursuant to any state or local approval process applicable to it. So somebody cannot just put up a tower without going through the regulatory process and then say, oh, it's here, now you have to approve antennas on it. So the next major part of the order was defining substantial change in physical dimensions. And there's a lot of ins and outs here, but the major summary of what the FCC said that meant, co-location is a substantial change in physical dimensions and therefore outside of Section 6409A if it increases the height of the structure by more than 10% or 10 feet, whichever is greater. However, for a tower, if the tower is not located in rights-of-way, that becomes 10% or 20 feet, whichever is greater. Second type of substantial change of physical dimensions, if the installation will protrude more than 20 feet beyond the existing structure for most towers, or if it protrudes more than 6 feet if it's a tower that's in the right-of-way or a base station. Third, there's a substantial change in physical dimensions if the installation will involve more than the standard number of equipment cabinets, up to 4 equipment cabinets. And finally, anything involving excavation or deployment outside of the current site is considered a substantial change in physical dimensions. Some guidance on the review process to be followed and the timelines for applications that come under Section 6409A. First, the Commission clarified that a local authority does have the authority to review the application in order to determine whether Section 6409A applies. There were some arguments that said, must approve and shall not deny means you can't even look at it. And we said, no, that's not what it means. You have to at least determine that the provision applies. Corollary to that, the citing authority may require documentation that is relevant to determining whether 6409A applies. However, the flip side of that cannot require documentation that is not relevant to that determination. We established a 60-day time limit for the review. That may be told within the first 30 days if upon notice that the application was incomplete. Fairly complex set of provisions around tolling and how to administer the time, which I won't go into. After the 60 days pass, if the citing authority has not acted, then the application is deemed granted upon the applicants notifying the citing authority that it is in fact deemed granted. If there are any disputes, they are to be resolved in court, not before the FCC. Just a couple of other holdings from that order that stand out. Building codes and non-discretionary structural and safety codes remain applicable. A literal reading of the statute, must approve and may not deny, could be read to say, got to approve something that doesn't comply with basic structural safety. I think everybody agreed that that's not what Congress meant. And finally, does not apply to a municipality acting in its proprietary capacity. If you don't want more antennas on City Hall, that's your prerogative. I'm going to just really very quickly spend a minute or two on the federal regulation, national environmental policy, and focusing on collocations. And this whole area, again, I could talk all day about. In fact, we will have a workshop all day tomorrow about it. But just a little bit for context, because there may be some questions. The NEPA, the National Environmental Policy Act, requires federal agencies to consider the environmental effects of their major federal actions. That includes antennas or towers going up pursuant to an FCC license. So NEPA applies to collocations. However, federal agencies have the authority to conclude that certain activities, actions that are unlikely to have substantial environmental effects are ordinarily categorically excluded. The FCC, under our own rules, has excluded from NEPA, has generally excluded collocations of antennas from NEPA review, with a couple of carve-outs. One is the National Historic Preservation Review process, which is part of what's sometimes referred to as the NEPA umbrella. And then the other thing is that they do have to be considered for complying with guidelines for exposure to RF emissions. Also in the 2014 order, we excluded the construction of poles and similar structures in designated communications and utility rights-of-way, provided they meet certain conditions. Essentially, the reasoning, if there's a bunch of poles already there, we don't require environmental review for putting up more poles of the same kind. The National Historic Preservation Act, in some ways, is a parallel subject to statute to NEPA for historic preservation, requires federal agencies to consider effects on historic properties of their federal undertakings, which is the term of art under NHPA that is the equivalent of major federal actions under NEPA. We have, pursuant to a nationwide co-location agreement, most of our co-locations of FCC communications facilities are also excluded from NHPA review. There are some exceptions. The major exceptions, not all of them, are if there's a co-location on a non-tower structure that's over, a structure other than a tower that's over 45 years old, it does need to go through NHPA review. Also, if an antenna is being put on a historic property or in a historic district or near a historic district. In the infrastructure R&O, in 2014, the Commission adopted some limited further exclusions for co-locations of small facilities, specifically if they're on structures that are over 45 years old. They may nonetheless be excluded if they meet certain size and other conditions. And finally, the Commission in that order committed to develop some further exclusions through a program alternative under the Advisory Council on Historic Preservation's rules. You don't need to worry about exactly what that is. So where are we on this program alternative? The FCC sought public comment in July 2015 on several paths that we might pursue for further exclusions. We've considered those comments. We are in the very final stages of developing a proposed amendment to the co-location agreement. We expect that we will seek comment on that proposal within the next few weeks. As part of that public comment process, we do intend to reach out to local governments through your national organizations. And finally, consistent with the Commission's commitment, we expect to complete the process no later than October 2016. I emphasize that no later than. Our target is actually to significantly beat that deadline. With that, if there's time and there are any questions, I may be able to take just a couple of them. All right, question here from Krista Cuccaro of Knoxville wants to know if my PowerPoint presentation will be available online. Yes, all of the presentations will be available online through the FCC's events website, and I think Cecilia can give further detail on that. All right, thank you very much, and we may take a short break? Yeah. Okay.
So if everybody could take their seats, we'll get started in just a minute. Okay, so we're going to go ahead and get started now with our first panel. The first panel today is going to be DAS and Small Cell Overview, Business and Technology. Again, for those of us who might be just joining, if you're in the room and you would like to ask a question, please get one of the note cards, raise your hand. You can get one of the note cards and pens, and you write your question down, and we'll collect it from you. If you're watching online, please send an email to livequestions, livequestions, @fcc.gov. Please include your name and the company you're affiliated with all of the questions. And as you think of questions, because we have a lot of information to cover today, so please submit them as soon as you think of them so that we don't run out of time. So the first panel today, we will have two moderators. The first moderator is Jody Miller, who we've already met. Jody is the president of NEPA, and Saurabh Chhabra, who is an engineer in the Wireless Bureau here at the FCC.
Thank you, Cecilia. Good morning, everyone. My name is Saurabh Chhabra, and I'm an engineer at the Wireless Bureau's Competition, Infrastructure, and Policy Division, CIPD for short. Jody Miller and I will be the moderators for the first panel dealing with DAS, Small Cell Overview, Business and Technology. I want to remind everyone that you'll have an opportunity to ask questions towards the end of this panel. If you're in the room, please write your questions on the note cards. Pens and note cards are available. And give your questions. You can raise your hand, and someone will come collect those questions. If you're joining us through the web, you can email us your questions as well. And that email is livequestions@fcc.gov. After each panelist is done with their presentation, Jody and I might ask one or two questions if we have enough time. We have a time clock right here, which will give a 1-minute warning. And if there are other questions, we're going to hold those until every panel has made the presentation. So we'll have an opportunity to ask as many questions as we can within the allotted time.
All right, thank you. I guess it's my privilege to give a brief introduction of the panelists and then our first speaker will be Alan, but I will go down the line and introduce all of you now. Our first speaker will be Alan Dixon, Senior Account Executive with H&M Networks. Then we have Mike Hughes, Director of Engineering, Crown Castle DAS, LLC. Then we have Troy Suddeth, Director of Engineering for Corning Optical Communications. Next in line, Art King, Director of Enterprise Services for Spider Cloud Wireless, LLC. And down at the end of the table, last but not least, Joe Pedziweiter, Head of Small Cell Architecture with Nokia United States. And with that, I'd like to have Alan Dixon start with our first presentation.
Excellent. Thank you. Sarb, Jody, thank you for the introduction, and thanks to the FCC and Chairman Wheeler for hosting today's event. The mobile revolution, as we know it, really kind of kicked into gear when Motorola introduced the first truly portable cellular phone. It was called the Motorola Brick. It was just under 2 pounds. It had about a 30-minute talk time, and it took about 10 hours to recharge. It would fit in your jacket pocket, but if you turned suddenly, the antenna would knock your glasses off. But it drove people wild. I mean, there was a waiting list of thousands within months of its introduction, and that kicked off a race that we're running today, a race toward handling technology innovations and an insatiable demand for wireless service. Wireless service providers and their partners take up this race every single day. Campaigns like AT&T's More Bars and More Places and Verizon Wireless's Can You Hear Me Now highlight the need for and the commitment to expanding and improving commercial cellular coverage. It's important to note that the wireless providers and the industry, when we started out on this journey, the goal was to provide a wireless bridge, a way of establishing communications as you left a building and went to another building. The idea was that it would be a small number of brief voice phone calls because it was 90 cents a minute. You couldn't say much more than, I'll call you when I get there. Yes, I'll pick up milk. Those were the kind of exchanges that you expected to have. And they were going to be made by people in cars or on buses or walking down the street at a height of 4 to 6 feet off the ground. But that initial vision faded very, very quickly because the service exploded in popularity and technology made it a lot more capable. The wireless services networks had to make massive changes to accommodate the explosive growth of connections on the network. So today they connect billions of devices, smartphones, tablets, laptops, and they exchange primarily data. But they still have to maintain that voice connectivity, so they can't give that portion up outdoors. But now primarily we're seeing an increasingly emphasis on indoor coverage. So if we look at Cisco's Visual Networking Index, this is from February of this year, it tells us that mobile data traffic in North America had grown 55% just in the period from 2014 to 2015. In that same period, over 500 million devices and connections were added to the network. This growth is not expected to change. It's supposed to continue unabated through 2020, and traffic will grow in the North American sector only from 357,000 terabits per month to 3.2 billion terabits per month. So that's a huge leap. But in addition to the things that we carry on our person, the smartphones, the tablets, the laptops, we're seeing new technologies that are enabling what we now call the Internet of Things. Some people call it the Internet of Everything. And the list of IoT-enabled scenarios is both extensive and impressive. Late last year, Gartner projected that by 2020, 21 billion devices would be connected to the Internet. Juniper Networks had earlier estimated that it would be 38 billion. And on Cisco's website, if you go there today, it'll tell you that they expect 50 billion devices to be connected by 2020. Some of these are going to be very simple sensors. Some of them are going to be a lot more complex and a lot more capable. But the one common thing is they're all going to need to connect to that network. To handle that growth, cellular networks have transitioned from analog to digital and through multiple generations of technology to what we're calling 4G today. Each one of those transitions has been with the goal of improving network capacity and extending coverage. But it comes with additional complexity because we've added frequency bands, we've changed signaling protocols, we've got new devices. To meet the simultaneously increasing demands of both people and devices, network coverage has to be extended and capacity has to be increased. Extending network coverage is not simple, but if you're going to extend coverage while increasing capacity simultaneously, you've raised the degree of difficulty by an order of magnitude. To provide more accessible and more ubiquitous networks, carriers have three primary tools: the macro network, distributed antenna systems, what we call DAS, and most recently, small cells. I think we could all recognize the macro. It's that network of poles and antennas and base stations that we're most familiar with as we drive down the road or as we walk down the street. The macro gives the biggest bang to the carrier. It gives them the biggest bang for their buck because it can extend coverage and capacity in all directions over a greater distance because it takes advantage of height and a higher RF power out. Distributed antenna systems, on the other hand, offer the carriers a way to provide targeted coverage because they'll hook an RF source into a site and then through a network of cables and antennas, they'll spread that coverage to where it needs to go. So it's a way of delivering things to areas where either the macro can't fill in or is poorly enabled to fill in for a lot of different reasons. It could be geography, it could be siting, it could be a lot of different things. But it's used DAS is used both indoors and outdoors to fill in areas where the macro can't reach. DAS systems are unique in their ability to support multiple carriers over that same physical infrastructure. Small cell, on the other hand, is a relatively new term, and it's really kind of loosely defined as not a base station. So the base station is what sits at the bottom of that macro tower and provides that RF capacity for that particular carrier. A small cell is just not a base station. So it could be what we call a micro, it could be a pico, it could be a femto, but it's a way of delivering RF coverage. Until the advent of the small cell, base stations were the only way that the carriers had to add capacity to the network. But small cells reduce that cost of delivering RF because they are smaller, they have lower power RF out, and they don't go as high on poles. They take advantage more of street furniture. They enable us to match the capacity in that area to the need, so you don't have to overbuild the network every single time that you try to do something. For our purposes, a small cell is just a small base station. There are two key differences when you compare DAS and small cell. First, the DAS is a network of antennas that is connected to a single RF source or sources. It can be multiple carriers, so it can have multiple sources. But it all goes over one network, and it's distributed over those antennas. On the other hand, a small cell network is a series of distributed radio sources. So you're not distributing antennas, you're actually distributing the RF, and you're connecting those small cells back into the network. The second reason is that small cell technology today is carrier specific. So if you want to provide coverage or capacity for carrier X, you need a small cell from carrier X. If you now want to add carrier Y, you need a small cell from carrier Y. So if you then want to add something else, you can. But a properly designed DAS installation is what we call neutral host capable. It's able to support multiple carriers simultaneously. They both represent different ways of accomplishing the same goal. And the goal is to lower the cost of delivering RF so that we can extend coverage and we can add capacity to meet these requirements. It's important to not see them then in an either-or context. We like to pick winners and we like to pick losers. But in reality, that's not what's happening with the macro, with DAS, and with small cell. They're all tools in a toolbox, and they fit according to what you're trying to accomplish. Small cells are good for delivering carrier-specific signals to an area of interest. DAS is good for delivering multiple carrier signals into a medium or to a large area. As the complexity of the installation goes up, think DAS. As the complexity of the installation goes down, think small cell. We'll spend the rest of the panel looking at the way commercial network operators are using these tools, macro, DAS, and small cell, to meet the twin challenges of extending coverage and adding capacity.
Thank you, Alan. I like that you mentioned that these are all tools in a toolbox. So let's see, with the integration of DAS small cell into heterogeneous networks, how do the different technologies fit into different use cases? I know you mentioned complexity and...
Yeah, so when it comes down to it is you have to look at the problem that you're trying to solve. So rather than pick the tool and then make it fit the problem, you pick the problem so that you can fit the tool. If you've got a small, medium-sized business and you've signed a contract with a specific carrier, you're probably not going to put a DAS installation into a 35 or 40,000 square foot facility. You would use, in that case, a small cell, assuming that you didn't have good coverage from the macro. On the other hand, if you look at some of the classic use cases for DAS, we're talking about places like shopping malls. We're talking places like football stadiums, basketball arenas. And the difference in those environments is that you can't control who comes in there. You can't hang a big sign that says, "Welcome Carrier A customers." You have to accommodate the needs of all those different people who are going to be in the stadium. And DAS does a good job, it does a better job today of being able to support those needs by being able to bank the sources in a particular location and then deliver that coverage to the areas where it's needed.
Okay. Thank you. Also, how do you see DAS in small cell uses evolving? And are service providers and venue owners generally deploying one or the other or both to improve coverage and capacity?
That's a good question. Today, small cell is pretty much the domain of the carriers. So the carriers decide where a small cell is going to be deployed and how it's going to be used. There's no ownership case in the enterprise right now for them that I'm aware of for them to own the small cell. The small cells belong to the carriers. On the other hand, the DAS is something that the enterprise can deploy today. So they can go out and they can spend the money, they can put the infrastructure in. They still need carrier participation. The carrier controls the RF source, so without the carrier it doesn't move forward. But it's something that the two parties can engage in cooperatively. So the enterprise can say, "I'm going to build the infrastructure," and the carrier says, "I will plug into your infrastructure so that we can deliver service to your area."
Okay. And are there use cases where, let's say we're talking about large venues and we're talking multiple carriers would want to be there, would people or the provider choose to put up a DAS solution there or consider even small cells?
A lot goes. There are a lot of moving parts when it comes in. So when you're and if you're in the enterprise and you want to make this decision of how to get coverage, there are a lot of different ways that you can go. You can approach the carrier directly, and the carrier will respond by saying, "Yes, I'm interested in helping you with this, and this is the technology that we're going to use." The other option is that you can engage a third-party provider, somebody who works in the telecom service and has your interest and has a way of dealing with the carriers, and they can bring the funding to that to make that happen, so that the burden of paying for everything doesn't fall on the carrier completely, doesn't fall on the enterprise completely. There's a way to create that bridge. So there are different business models for how you should approach things. My recommendation is that if you're in that kind of scenario and you're looking for ways out, throw a pretty broad net. Put an RFP out. Consult with somebody to help write an RFP to tell specifically what services that you need to provide, and then kind of wait and see who engages. There are a lot of different folks out there who are willing to help right now.
Okay. Sounds great. Thank you. Jody?
All right. Thank you very much. And with that, we'll go on to our next speaker, Mike Hughes, Director of Engineering, Crown Castle.
Oh, that's me. Let me get the slide. All right. Okay, great. Well, good morning, everyone. I'm Mike Hughes with Crown Castle. We are the leading provider of shared wireless infrastructure in the United States. We actually cover the full complement of HetNet solutions, Alan referred to as tools, starting with macro cells. We have over 40,000 towers. Then there's outdoor small cells, and we have over 20,000 of those deployed. We have thousands of them in development, and they are all connected by our fiber optic cable plant. And then we also provide neutral host systems indoor, and we typically focus on the higher capacity venues, the stadiums, the arenas, or real high volume buildings. So what I'm going to do this morning, I'm going to spend some time talking about heterogeneous networks, basically what they are and why we need them. And then I'm going to spend some time discussing outdoor small cells. Now, small cell means a lot of different things to a lot of different people, so I'll be very specific about specific with my definition of a small cell. Okay? All right. So, what are het nets? I think most people know what they are by now. There's really no mystery. There's lots of het net forums out there, and actually Alan hosts one of them. But, you know, here's what we're up against. I mean, looking out 5 years, wireless data traffic is expected to increase by 5 to 10 times. And regardless of the number, there's just not enough new spectrum out there to handle it, to take it on. And as for new technology, well, there's not much more we can squeeze at a new technology in terms of bits per hertz. So what carriers are going to have to do, and what they're doing, is really densify their network by reusing the spectrum and the technology that they have today. And it's not going to happen by just deploying more macro cells. They're going to have to get very surgical and precise and deploy small cells as an underlay to their macro network. And that's basically what a het net is. It's a combination of macro cells along with outdoor small cells and indoor small cells, or usually DAS networks. And they work best when you deploy them right on top of the traffic hotspots. And it's not so much the obvious traffic hotspots like a stadium or arena. Actually, most of those places have systems deployed today. It's really the other hotspots that aren't so obvious, but they generate a lot of traffic day in and day out. They actually generate heavy amounts of traffic in areas that may have a radius of 50 to 200 meters, and they cover multiple buildings. They could be residential, retail, industrial, professional. The fact is these hotspots they're simply all over the place. And this is where outdoor small cells make an ideal solution, because they are targeted solutions, but they also can cover enough ground to cover the traffic that's there. And they also cover from the outside in, which is also a pretty economical way to provide coverage. All right. So with that said, let me talk about small cells and give some specifics about how we define small cells at Crown Castle. Now, first, it's the type of radio equipment deployed on the small cell really doesn't matter. It's not even listed in our definition. So what I mean by that, whether it's a fiber DAS repeater, whether it's a remote radio unit, whether it's a pico cell, doesn't matter. There's really two key characteristics that make small cells effective, and they're pretty simple. It's slightly less power and a much lower rad center compared to a regular macro cell. Now, this is what, as I said, makes them so effective. Now, when it comes to slightly less power, what I mean by that, this is the amount of power coming out of the amplifier. And I say slightly less is because, well, small cells are typically deployed for capacity. They're deployed in areas that already have good coverage. So you're going to need some power to overcome the existing signals that are out there. Plus, you also want to cover inside buildings. So you need some power to actually penetrate the buildings. So that's why slightly less power. The other key characteristic is a low rad center, right? This is how high the antenna is off the ground. Now, typically we like them within 30 meters, and the reason this is important is because this puts the antennas really at or below clutter. Now, what clutter is basically your buildings or the height of your trees. And there's really no better way to contain your coverage than the use of clutter. So what I mean by that is when it comes to small cells, you really just want to cover what you want to cover, which is a traffic hotspot. After that, you want it to roll off very, very quickly so it doesn't interfere with the rest of the network. And that's where the height basically comes in. You cover what you need to cover, and then it disappears very, very fast. Now, what we find the most effective way to deploy small cells, especially if you're going to do it with any scale, is by leveraging right-of-way infrastructure. So when I say right-of-way, you'd want to think of utility poles or street lights, et cetera. And one of the reasons that it makes it so effective is the abundance of infrastructure that's already out there. So it makes siting options really virtually limitless. And this is important because with small cells, you have to deploy them right within the traffic hotspot. If it's 500 feet away or 1,000 feet away, it's really not going to do you any good. So chances are, with right-of-way infrastructure, there's something that's already there. Now, the more important thing about using the right-of-way infrastructure is this is the same infrastructure that we use to connect all those small cells with dark fiber. And what this does, this provides the backhaul required. So small cells, they need quite a bit of bandwidth, and there's really, dark fiber provides you virtually unlimited bandwidth. There is a limit, but it's virtually unlimited, which is a great way to future-proof your system. So that's really the profile of a small cell. It's slightly less power, it's a lower rad center, and you need to deploy it right on top of the traffic hotspot. Now, from a HETNET perspective, carriers are still going to need to build some macros. They're still going to need to build a number of indoor solutions. They're still going to need spectrum. They're still going to need whatever technology improvements that we can get. But small cells, outdoor small cells, provide a very effective and efficient solution. I think really we'll be able to do most of the heavy lifting the carriers need to densify their networks. So I'm going to flip through the next couple slides. I've got some pretty pictures of installations. But what I want to get to now is a conceptual view of what I mean by a small cell underlay to a macro network. And in the picture here, this is conceptually what it looks like, but really this is how we do it in real life too. We're showing a picture of a sector's coverage area, a macro sector's coverage area. That's that blue triangle that you see. And then what we also show is some traffic hotspots, areas that are generating an inordinate amount of traffic. Those are the right spots. So really what we're doing for the carriers is we're deploying small cells right on top of those hotspots, just like you could see in the picture. And effectively what that does is really multiply the capacity that was there before. So typically you had one sector's worth of capacity covering this area. Once you drop in the additional small cells, here we've actually gone from one sector's worth of capacity, adding 2 small cells gets you to 3. You've actually tripled your capacity in the area. So I would leave it at that, and now I'm going to turn it over to Troy unless we have any additional questions. 45 seconds?
Yeah, 45 seconds.
Okay, we'll go on with Troy, and then we'll get you later with some questions.
Great.
How does that sound?
Thank you.
Good morning. My name is Troy Suddeth. I'm with Corning Optical Communications, the wireless division. Here we go. So Corning Optical Communications really evolved out of the Corning creating low-loss fiber in 1970. Their DAS expertise came with the acquisition of Mobile Access in 2010, who's been doing DAS systems since 1998. These DAS systems, we've got probably over 6,000, I think this was the count last year, over 6,000 of our systems have been deployed throughout the world. Everything ranging from neutral host, as Alan talked about, to single carrier, everything from large public venues like stadiums, airports. We've got the House of Reps as an example that have our systems deployed. Down to, again, a single carrier enterprise that just needs 1 or 2 bands of coverage. And that's traditionally, the large majority of that has been our traditional hybrid fiber solution. In a DAS, you've got fiber going to a remote, and then you've got coax distributing to antennas to provide the coverage. Corning evolved their vision to focus on a flexible architecture that would provide a multitude of solutions. And so, the idea of that architecture is to bring fiber to the edge of the network, closer to the user, where the density of data is really being driven. The idea being that, we can provide a wireless and wired backbone to provide RF and IP services. And leveraging fiber, it's a wire it once kind of infrastructure. As Mike mentioned, fiber is essentially, unlimited bandwidth and future-proof. So the culmination of that was the Corning Optical Network Evolution Platform, or Corning One. This is a all-fiber optical network that provides not only cellular DAS but also data and other networking capabilities. So if you look at the architecture on the left side, you see something similar to kind of what a DAS looks like. You've got at the bottom in the MDF in the head end room, you've got RF in from the signal sources that you're being provided, whether that be one or multiple carriers. That RF electrical energy is turned to RF optical energy. It's sent vertically to the closet. In the closet, we transition from just fiber optic to cabling that is both fiber and copper, so that it can provide, and we inject power so it can provide power to the edge device, the access unit at the edge, which is essentially a 7-band remote that can provide the cellular frequencies. We also can provide the capability of providing gigabit Ethernet at the edge. So you can have Ethernet ports along with your cellular at the edge of the network. What makes this platform somewhat unique is that the cabling infrastructure to support this is essentially a universal transport solution. So you can do advanced networking applications like providing not only cellular in a distributed DAS type of environment, but provide LAN IP connectivity, wireless LAN, very synergistic with passive optical LAN, really IP ports and IP connectivity that can provide access for multiple applications, and even provide the ability to do small cell. One of the benefits of this platform is that you have one-to-one connectivity with the remote access unit at the edge. So if you have a signal source like a small cell that has a limited amount of capacity that it can support, you can actually direct that capacity to particular areas in the venue. Maybe there's a carrier X that's deployed DAS for the entire venue, and maybe another carrier says, the bottom floors are a shopping center or a mall or something like that, and I just want to deploy small cells in that area, and I can direct coverage to those areas. And then from a capacity perspective, again, this is fiber. It's unlimited bandwidth to the edge. Some of the advancements of the platform continues to evolve. We've got a head end now that can do RF and optical if in the middle in the same chassis. We've expanded to do traditional hybrid fiber coax on the same head end platform. So if you need more coverage, or if you need to cover a parking lot or a large area adjacent to maybe an area being covered by the smaller remote access unit, we've got the mid-power remote. We're going to have a high-power remote that's going to be able to be used for outdoor coverage. We've got a campus connectivity where we're looking at where we're providing up to 3 sectors of coverage to a remote building up to 15 miles away, and 10 gigabits of Ethernet backhaul on one fiber. So for us, that infrastructure being there provides that upgradability in the future. And there's some advanced capabilities on the platform itself, like listening mode and spectrum monitoring, which are important to people providing small cells, because they need that to as these small cells evolve and become self-optimizing, that type of information helps them optimize itself as it's deployed. So when you look at what converged, why converged, or what converged infrastructure, one of the things to look at is that and Alan and Mike both mentioned it, capacity, the amount of data usage being driven out there by mobile devices is just insatiable. Capacity is becoming and has been a continuous problem for the carriers to try and keep up with. LTE is the technology of choice from a commercial carrier perspective, and they're putting everything on it. It started with data, it started with video, and now they're putting voice on that. So LTE is becoming, it's a very bandwidth intensive protocol, and it's requiring them to get more spectrum and more ways to be able to deliver that data. So we see new bands coming out all the time. 600 megahertz is going to be auctioned off very soon. AWS-3, which was auctioned and awarded, I think, early last year, is going to be deployed at the end of this year. WCS band, and you know, they're already doing 5G trials, so very dense network requirements. We also see Wi-Fi cellular in the in-building too, offload. And so this is when the enterprise starts to get engaged now, because their infrastructure is now being utilized for essentially the carriers trying to offload data. And this is especially going to become true when we talk about voice over Wi-Fi, because you know, while it's nice that some carriers have a solution that can work in your basement, carriers are looking forward to carrier-grade type of voice over Wi-Fi service using LTEU and LAA and LWA. Which is going to require, ironically, also a small cell and that transport back to be able to handle the mobility and handle and make that type of voice over Wi-Fi carrier grade. And small cells, as we've talked about, that's a tremendously valuable tool. The capability of small cells are growing. They're becoming more intelligent. You know, a carrier can decide to augment coverage in an existing venue on just one band and one technology, or they can do a multitude. And with the fiber backbone platform, you can direct again where you want that coverage to be and that capacity to be deployed. So cellular systems can just be, as it says, a one-trick pony in a venue. I just do that, and that can take up a lot of resources, but that's all it does. We're starting to see a transition of enterprise-funded and interest in enterprise-funded DASs. They need to have the mobility, the coverage for their partners, for their users, for their employees, but they also need to provide data in a wired environment for their LAN, for their enterprise. And so, as we see enterprises interested, they want to maximize their investment. So, a fiber infrastructure really helps them with a future proof. I mean, you talk to any CIO and ask them when their next cabling upgrade is going to be. It's going to be in 2 years. They're going to do it for a particular platform, and they're going to do another one a year after that. A fiber backbone allows them to have a future-proof kind of infrastructure, and if you designed in a way that it can handle advanced networking, then it's truly beneficial. And really, the idea is that, you know, data is becoming the fourth utility in a venue, right? You've got water, you've got electricity, you've got HVAC, and it's becoming imperative in a lot of these enterprise buildings that data is that fourth utility that's a requirement. From a fiber perspective, you know, tactically, when we're dealing with fiber, it's obviously the more fiber you can have, the better you are from a design perspective. It's easier to design because it's essentially lossless, particularly in a building. Corning has worked very hard to provide some things to make deploying fiber easier, pre-connectorized solutions, plug and play, easier mechanical connections to make, fiber that you can staple, not that we recommend that, fiber that you can staple and without loss, you can wrap around a nail. I mean, this is fiber that didn't exist before. You put, you know, a slight bend on fiber, you lose a lot of the power through it. And fiber can consolidate several things onto a smaller, you know, physical cable, so it's a space savings. It's virtually limitless from a bandwidth perspective, so it provides, you can put other spectrum, and, you know, from a future-proof perspective, you can provide, you know, access to one device that provides a lot of bandwidth, or an app or an appliance that can provide multiple connections to lower bandwidth applications, but a variety of them, which is going to be essential when we're talking about 5G, as one of the aspects for Internet of Things and one of the things that it has to provide. Just one quick note on this slide, and I'll be done, is that we've talked about this a lot, but we did an all-fiber infrastructure at a college stadium in Texas, Texas A&M Kyle Field. And what's unique about this is the infrastructure that drives 50-plus sectors of DAS, a variety actually between the different carriers, is the same infrastructure and the same cabling that's providing point of sale, all the Wi-Fi, IPTV, the scoreboard, and all these building automation systems in there. And they've still got 3,000 fibers left that they can deploy, I don't know what, at the edge of the network for the future. So they've truly future-proofed the stadium. So with that, I've gone over my time. I will turn it over to Art. Thank you.
Thank you. Okay, here we go.
They're queuing it up.
There we go. I'm going to talk about indoor. So we built technology that's to build cellular signal indoors. We've been around since 2008, and we shipped commercially first in 2011. So it took about 3 years to actually bake the technology and make it real. So first of all, I wanted to define enterprise, and it's not in the upper right corner there. I wanted to really talk about the people that are kind of forgotten because the economics of the buildings don't make sense for the operator to participate in the building. So you have plenty of locations where the customer is not large enough or the building isn't right, such that you can't get any service improvements. But you have IT staff that are making decisions for the majority of the people in the building. On the small cell forum, there's release information on the smart enterprise release that just came out, and we participate in the forum. And we also participate in the Multi-Fire Alliance, which is a next move to kind of make single spectrum radios multi-operator. So from the perspective of the total addressable market, what we did was we looked at the Department of Energy numbers as far as the amount of buildings that are available. And we saw that DAS, the economics work for the large pieces of real estate, which comprise about 10% of the market. But below that, you have a huge amount of buildings, 435,000 buildings, that are not economical to serve unless the customer is so powerful that the operator will do it to quiet them down, or they have a large enough checkbook that they'll just do it because they want to do it. So there's a whole group of people out here that small cells address that can't be touched by the economics of present systems. So before SpiderCloud, I ran the global network, the architecture and mobility for a company called Nike. They make shoes. We had 40 buildings on our campus that ranged from 150,000 square feet to one outlier at 500,000 square feet. So we had lots of buildings and not any kind of underground capacity such that we couldn't make the business case work for any kind of signal improvement. So why enterprise small cells? We built our technology from the ground up with the approach that we were going to build on top of the enterprise stack. So if any of you are kind of familiar with Wi-Fi technology and how it fits into the enterprise LAN ecosystem, imagine that the Wi-Fi radios are pulled out and you put cellular radios in. So essentially you have a cell tower in the palm of your hand, but it connects over standard enterprise Ethernet IP back to the mobile core. So the RF source is right there. So what you have is in maybe 10,000 square feet is you have a whole 30 megahertz of spectrum. So what Verizon is doing when they're deploying our systems is 10,000 square feet, 30 megahertz of spectrum, and so you have a lot of spectral reuse inside the buildings. It's really efficient as far as capacity. And with 80% of the usage indoors, it's obviously a big problem. We're seeing macro offload effects. So as we deploy buildings, what we're seeing on the outdoor networks of drops of like 45% as far as attached users. And more importantly, the amount of downlink that they're using only decreased by 16%. So that means that the people that were left on the outdoor network that didn't move indoors onto the small cell network, they're getting better performance outdoors. So it's really causing the operator community to think about holistic RF planning, not indoors and outdoors, but holistic planning, where you say, I've got 3 enterprise hotspots there along the I-5, and my outdoor network is designed to support the 50 or 60,000 cars that pass that in the morning. Why don't I just, instead of spending $1 million on the towers, spend a couple $100,000 on some small cell systems to move the hotspots off the macro network? And to your point about wireless as utility, yeah, that's absolutely where it's going. A CTO of an operator said, you enterprise guys are causing my problems. You're doing energy efficient glass. You're putting 35 dB of loss out there. That's for non-engineers, that's a 1,000 to 1 loss. So your signal's cut by 1,000 when it travels through the glass. So he was saying, in what building does the water company provide the plumbing and the faucets inside the building? In what building does the electric company provide the cables and the electric outlets? So as we move to this model of the companies being more responsible for the interior of the buildings, it's both landlords and enterprises that occupy the buildings that can see a lot more of the funding kind of shift into their hands. So we build indoor small cell systems. The box in the middle there is a services node. It supports a cloud of radios attached in the building, and they're attached to a standard power over Ethernet backbone, usually a VLAN that's carved off from a security perspective so it doesn't mingle with corporate traffic. But essentially, from a construction perspective, the enterprise has already constructed the vertical infrastructure for you. We build 3G, LTE dual band radios, and we build LTE, LTE radios, including carrier aggregation and that kind of stuff. And we've got LTE-U product going into testing with Verizon this year, and we're working with the Multi-Fire Alliance to potentially, get to multi-operator small cells. So 75% of our land deployments, the customer is providing the transport infrastructure. What's important about this is it changes the economics of deployment. It makes it easier to deploy, and the IT people, they're more than happy to contribute it because their business customers are yelling at them to make cellular better. So everyone's got skin in the game to make it better, and the operators tend to not have the investment pool to handle small customers. I was a fairly small customer. I only spent like $1.2 million a month, but it wasn't enough to get anyone's attention about fixing a problem. And in the core where you have space issues, to be able to occupy 1 U of rack space in the telecom closet, it's got some compelling space and consumption features in an enterprise environment where space is at a premium. And then finally, just food for thought here. This is what we built with Cisco. So Cisco OEMs our platform, and we built a cellular module that plugs into the back of a Cisco AP. So if you're an operator, imagine that your customer walks around the building, drops radios off the ceiling, plugs in the cellular model, hangs them back up on the ceiling, and commissions the system over their internet backhaul because they've got enough overhead in their internet backhaul. You could have very much a $0 infrastructure cost inside the building, and in your OpEx, because you're using internet, you don't increase your OpEx for your business, and you don't increase the OpEx for the operator community. Within the operator community, as I understand it, the number 2 cost of the operation is backhaul to connect cell sites to the core. It's a huge cost. So anything where the backhaul can be offloaded to the customer, it's a great win for the bottom line. And so we're looking at delivering more capacity. As this switches over to where the enterprise can buy the technology, it's going to change the game because there's quite a few system integrators out there that are anxious to do this. The most successful SIs that we see are guys that have Wi-Fi crews and DAS crews. We're kind of seeing this creation of like a labor sandwich where you have DAS people doing the design, the radio layout, bill of materials. They do things like figure out what macro dominance needs to be, all the complex cellular stuff. The Wi-Fi crews go in and put everything, hang all the equipment, pull the cables, put it in the racks. And then the DAS team comes back in at the end of the process, commissions the system and turns it up and brings it online and does all the necessary site walks and that type of stuff. So it's, any of the blended labor that we're seeing in the SI community is starting to make a lot of this stuff more possible. And the Wi-Fi economics are actually the most compelling part of it. And there are case studies and some other things on the back end of this that are in the download of the file. Here we go, Joseph. Yeah.
Thanks, folks. So my name's Joe Pezziwater, and I'm from Nokia. The first thing everybody needs to do is to amend my bio to include the debugging of that brick phone that Ellen showed early on. So thanks for bringing back those fond memories, Ellen. So, but why don't we kind of get going? So we want to kind of give you a small cell perspective from Nokia in this particular regard. So we heard some of the use cases. The reality, what we're actually seeing from a Nokia perspective, especially from a worldwide, we have tons of use cases that we're actually using small cells. So highly diverse, indoor, outdoor, on street poles within particular stadiums, all the way to residential. Each one of these have their own unique challenges with it, and I'll kind of go into a little bit more details, but just realize that small cell does bring in this agility that allows us to be a little bit more focused and broaden the particular use cases that we could actually target small cells for. So I heard a stadium example, and here's a recent one. There was the China Formula One race that actually took place, and there's a few interesting things that we should note. This was a very dense deployment. There was 95 small cells actually placed within the particular stadium. They were about 30 to 50 feet apart, so a very, very dense deployment. What we actually saw, I was hearing a terabyte discussion, well, within the particular 3 days, we actually had about approaching 3 terabyte worth of traffic. A thing to note was we also did the same show last year, and there was a 3x improvement in the amount of data that was actually being provided. A little bit interesting here, what was done was, some of the interference issues that we actually talked about, we actually separated the macro from the small cell. So we actually avoided some of those interference issues. And as part of that, let the small cell carry the bulk of the particular load. And in this particular case with that traffic, on the last day, 55% of the traffic was all carried within the particular small cell. Now, the user density is also really intriguing, and it really makes us think about what the small cell needs to be. But if we take a look at what we were doing in this particular case, 81% of the particular traffic on the last day was actually provided by the small cells in itself. While there was macros in place, the majority of the load of the users were 81%. And how many users? We had one particular small cell have 376 active users. This means that they were actively doing something in regards to a particular application. This doesn't mean they're idle. This means that they were actually accessing the internet or such. Now, while we have this, it's still not good enough, so that we need to take a look at this a little bit more from a system perspective. I hear a lot of words about coverage and capacity. When we at Nokia talk about small cells, we focus on user experience. So it's all how can we continue to improve the user experience. In this particular case, there needed to be a change to the architecture, similar to what you were actually saying, some level of taking a cluster of small cells, doing some form of aggregation into a particular controller. By doing that, we're even able to offer more. So now that we have concentrated all the particular traffic, we were able to take that particular traffic and inject it into a mobile edge computing environment. So now at the edge within the particular stadium, we're not only providing the capacity needs, we're actually driving up the experience by enhancing the experience through, let's say, virtual reality. There are even some content-based caching that could be done, so the feed streams are a lot quicker in that particular regard. So a very good use case for us to explore. I think I've heard this. It seems pretty well understood from an FCC, but when we look at this, and the word holistic is used a lot, and I'll use it again, it really, in the context of small cells, there is a need for us to go ahead and address this from a holistic approach. One part to be cognizant of in the context of small cell. Because the majority of the function resides in the small cell, the required interface from the small cell is just an IP interconnect. Okay, so it's a little bit more delay tolerant. So we could actually sustain delays of, let's say, up to 5 to 10 milliseconds along the particular link, which now kind of brings in the ability to, let's say, use wireless backhaul as an option to go ahead and address, let's say, a small cell that might be on a pole. The RF design needs to be taken into account. When we go in indoor, what we're actually seeing is almost a move more towards what we would call intuitive planning. So instead of actually doing complex planning from an RF perspective, you almost use a set of rules of thumb that says, given this particular environment, we need one small cell here and there. Why? Just because of the scaling aspects and trying to go ahead and maintain the cost. Deployment operations also key. The whole area of stealth in the context of small cells and in the context of anything, in the context of DAS, is really important. How do we go ahead and hide the particular antennas? I was told once by a municipality, whatever you do, don't show the antennas, because that'll actually trigger questions. So we always have to be involved saying, how do we go ahead and portray ourselves and our particular products, not to make them blend into the particular background. So a few areas that I want to talk about was the user experience. Once again, back to this user experience, that when we take a look at what's happening in small cells, the same user experience that's happening in the macro, operators and users are expecting not only us to meet that, but beat that particular experience within the small cell. So when we take a look and some of the breakdown, if you look at some of the constructs that are used to go ahead and drive up, let's say, peak data rate, the spectrum, the modulation rate, the MIMO, which is the number of antennas that you need to use, and the user density continues to grow in the very near term. So there's a need for us to go ahead and drive towards more spectrum, higher level of QAM rates, all the advancements in MIMO technology, and even higher counts. What this is driving towards is this particular small cell. Sometimes you might think about the little residential femto that sits within your home. These particular stress that we're seeing from a technology are pretty significant. So what we're seeing, the particular small cells, and there's a picture of an indoor and an outdoor unit, that the particular small cells now need to be multi-band. Okay, they go beyond one band, sometimes approaching three bands of support. The number of spectrum that you have to support within the box is going above 60 megahertz. There's an increased need for processing power to go ahead and handle all the particular number of users. And by the way, as mentioned before, no give on size and weight. It still needs to maintain a very small size. So while it's a challenge, there's technologies out there, and these are actually being addressed by the industry. So I just want to touch a little bit about, how can we get some more spectrums? And I heard mention of this a little bit earlier about LAA and LWA. So these are a few ways in which small cells is now actually extending into the unlicensed spectrum. And in this particular case, there's a few technologies called license assist, access assist, and LT Wi-Fi aggregation that actually leverage the unlicensed, but it still maintains a particular anchor in a license. So you still have to work with an MNO who has a licensed spectrum. And then what this does is a supplemental download, as an example, using unlicensed. Now, on the very right is work that's taking place in referred to as multi-fire. Now, this is purely standalone. So in this particular case, there's no need to have a licensed counterpart. And so it's still operating in that unlicensed band. All these solutions support coexistence with the existing services there, such as Wi-Fi. But in the context of multi-fire, it's looking for new neutral hosting options that can actually be done. And then finally, is a good example of what we're seeing in the context of shared spectrum. So the citizen band radio service, which, by the way, I'm not sure if it's timely. I heard that the rules and order were just released yesterday in regards to the particular spectrum, but a very good example of how small cell can now even extend more towards greater frequency use. So here on the right, there's products that are being developed for the CBRS band, and they'll actually be used, we project, by both existing operators but also new entrances within that particular area. And if you know the way the shared spectrum work, there's an incumbent, as an example, with the CBRS band. It's radar. So you use it, radar comes in, you have to get off of it. But there's a whole framework that's being defined within the Wireless Innovation Forum that are taking the FCC rules and then instantiating the required architecture to ensure we have that performance. So we got to check on performance, we got to check on framework, and from an FCC perspective, we have a check on that particular spectrum. But our feeling is once all this is in place, the ability for the FCC to now go ahead and extend to the other spectrum is something that should be considered. So in that, let me just leave with thank you, and here we go.
Thank you, Joe.
Let's give our panel a round of applause before we head into questions. Thanks. We do have a few questions here, and this first one is not directed at any one person, so I'll ask it and we'll see who wants to start. Is there a, quote, generation gap between local and state decision makers and their communities in terms of the need for cell and broadband coverage? Do local and state agencies underestimate the demand for these services? I guess in your experience with the companies that you are directing, I definitely have an answer for that. But I guess should we start on this end, Alan, and just go down?
Sure. So I think it's an interesting question. I don't think that there's necessarily a generation gap. I think that the folks who are providing the broadband coverage, either from a wireless perspective or the city fathers or however you want to call it, I think they understand that their constituents, their citizens, their everybody, they want this coverage. I think the balancing act is trying to deliver it to them in a way that is acceptable to them. I mean, that was one of the things that Joe brought up was the need for stealth concealment, because my daddy used to say everybody likes progress, nobody likes change. And this is kind of what you've got, is that I want ubiquitous wireless access so that my devices work everywhere, but I don't want an antenna in my front yard. I don't want to be able to see things. So I think it's a function of trying to deliver the package in a way that they're willing to accept it. And so it's not a gap. It's just it's complex. Anybody else?
Even from a facility owner perspective, we do a lot of installations where the radios are up in the plenum so that no one has to see them, just because of building aesthetics.
I would say that we did have some experience just in the context of a trial with a particular municipality, and they were very welcoming for us to do something within their particular town center. But right away they were very concerned about how am I serving all of my residents. So when we actually brought up the fact that, well, we could bring in one carrier, they said, no, we need to go ahead and find solutions that all my residents are able to address.
The only thing that I would add is I think people need to understand there's a balance in cost, right? So everybody would like a stealth solution, but it costs money, which can be prohibitive. So it's not only on the equipment side, but even an understanding on the acquisition rights and the cost just to put something on a pole or on a building. There needs to be an appreciation for that as well. So I think when it all balances out, hopefully, you'll see more and more small cells deployed.
Great, thank you. Anyone else? Troy, did you want to add anything?
No, I think, though, I wouldn't call it a gap, but there's a continuing education about what's needed to be able to provide this. Oh, I can provide coverage. I can provide service. And to Joe's point, the carrier needs to get involved. To Mike's point, it needs to be sometimes stealth, and there's limited places that we can put it, and there's a real cost to that. So it's not a gap, but it's a continuing education of what they're asking for to explain that.
Great, thank you. Got a couple of other questions. You want to do the next one?
Sure. Okay, here's a question. We got a note card, but no name on it. Mike mentioned placement within rows and gave example of light poles. This person says, my understanding is that current NHPA exemptions do not cover light poles, lampposts, so I would think this creates an additional challenge citing on these, even though there is an abundance of these types of structures in densely populated areas. Is FCC considering expanding utility structures exemption to cover these? And then the second part of this question is, what is the price difference to providers per gigabit of data to customers using macro versus DAS versus small cell? So anyone would like to take a shot at it?
I can clarify as far as the infrastructure, the right-of-way infrastructure. It's not all owned by the utilities. I mean, some of it is specific jurisdictions, specific municipalities, and the key is to work out an agreement with them, right? So to answer what the FCC can do about that, I'm not experienced at.
Dipping into that? You have a recommendation for the FCC?
No.
And I'll take a hack at the second part of the question. When you look at it in price per bid, I don't know the specifics of it, but I think when you look at it in terms of the technology and what it's able to deliver, macro provides the best bang for the buck. It will give you the lowest price per bit because it covers more people and has more capacity. As you drop down into the other solutions, this is just pulling stuff. It's the DAS would have the second lowest cost per bit because it has the ability to use a single infrastructure to deliver multiple carrier signals into a particular space. And then the small cell would have the highest, I guess, in that general direction because it's covering that particular traffic area. Now, looking at it in terms of price per bid is kind of misleading because it's the goal that you're trying to accomplish is to get that traffic, to define that user experience, as Joe talked about it. So I don't know how you calculate that in terms of general terms or absolute terms, but it just seems to kind of go in that direction. And I'm open to correction
No,
there.
I'd agree. I mean, that's from the carrier perspective. That's it. I don't know if the question was from the user perspective, the customer perspective.
I think it would be from the carrier's perspective, yes.
Okay.
Okay, and I think Jeffrey
The only thing I'd add in
Steinberg.
terms of kind of reordering the cost you said,
Here.
macros are the most efficient. And I say what's in the middle is actually outdoor small cells, and then you come into the more the indoor installations. Yeah,
right.
Yeah. Just to clarify, to the extent that question involved the FCC's rules, that we are working on an agreement that about further exclusions, and basically that's still under development. So I can't really say a whole lot about what's going to be in that right now. But we're certainly trying to make an effort consistent with our obligations under National Historic Preservation Act to streamline these processes to the extent we can and to the extent that makes sense, while also recognizing the effects that that these installations can have under certain circumstances.
Thank you, Jeff.
We have another question. This is from Mitzi Herrera, Montgomery County, Maryland. She's here live and in person today. She's one of our NEPA members. She directed the question to Troy. You stated data is the fourth utility and broadband availability is a key driver for tenants. But Broadband Communities magazine reports that only 17% of developers include fiber in their new buildings. And in Montgomery County, Maryland, business tenants report that building owners don't view access to broadband as a building management issue. What percentage of building owners and managers are embracing boosting in-building coverage on an enterprise basis, and what could be done to improve that percentage?
That's a loaded question. I mean, I'd say that there's, we're targeting, obviously, the ACE communities, the architects, the consultants, the engineers, to provide the consideration for fiber everywhere in the venue, right? Because we don't know what's going to be needed. And, when they're building new buildings, when we're talking about greenfield, let's think about that. And that seems to be an easy conversation because they're constructing it. I don't know what would be required from a mandate perspective, but certainly they're thinking, I don't want to, in 2 years, have to do a big cabling infrastructure upgrade to support something that one of my key tenants needs in this venue. The second part of the question, I don't know the percentage. I couldn't venture to guess. And I think the third part of it was about broadband access or to venues or
yes,
to municipalities?
Yes, the third part was what are your ideas to boost in-building coverage or building owners and managers embracing building that into their coverage, I guess. What do you think could be done to improve it?
That's a good question. I mean, it comes to we've talked about the economics of the different solutions that are available. And we're providing, from our perspective, we're providing a platform. And when the business case makes sense, folks like Crown Castle are providing the infrastructure to provide the solution. We're working on, as we talked about with Art and with Joe, these smaller, smarter signal sources maybe are becoming more cost effective. I mean, they talked about an initiative where they're trying to do multiple carriers on a single small cell, which isn't done today, and that's going to be a huge leap when you're making basically a small cell neutral host. So these are driving, I think, the economics down to make it more palatable to put into venues. Alan, probably. I thought you touched on something earlier in the beginning of your presentation about this. But anyway.
No, I agree. I think that the idea is that to incentivize that, to make good things happen, you've got to give them tools that will work for that. When we started out with the idea of structured cabling back in the late 90s, the idea was that there were all these different protocols that were operating. There was token ring, there was Ethernet, there was ATM, there were all these different things. And so we came up with a unified cabling design methodology that would enable you to run any of these these applications over a particular physical infrastructure. Well, those days are really kind of gone. So we only talk about deploying Ethernet today. And then we talk about these other applications, these other services that run above that. So you've got Ethernet transferring data, but now you've got Wi-Fi and you've got cellular and you've got security video and you've got building automation controls. These are all applications. So if you can give these building owners, these building designers, the ACE community that Troy was talking about, a tool that allows them to take advantage of a single infrastructure to accomplish more things to get that bang for the buck, I think those are the things that drive that conversation forward.
Yeah, I mean, I think all of us on the panel have an option to be able to do that. And clicking on a small cell to an access point, is a way to enable that.
Yep. And not having to run new infrastructure to get it done.
Right, exactly.
Yeah, Jody, what the real driver for these kind of changes is going to be pain on the part of building owners. So we're there's inbound calls probably to all of us about building owners where I have to do something because a great corporation just came in to lease my building. The leasing agent can't see 5 bars of Verizon or AT&T. Therefore, they won't open the conversation about doing a lease because they know that their enterprise will be dissatisfied if they move in. So sometimes it's going to be architects convincing building owners that this is a natural and required part of a new building. And sometimes it's going to be a retrofit that's more a reaction to customers not wanting to lease the property, especially when you start getting up into Class A space where it's just a required amenity now.
Thank you. You have another question?
Yes.
You go ahead.
Okay, this is from Solomon Sache. In the interest of time, we'll try to keep it short, maybe 1 or 2 answers. What is your experience incorporating indoor and outdoor E911 location solutions with your technologies? Please provide some stats if you have any.
Well, at least I think it's a much easier answer from a small cell perspective, right? Because, you need to, at least in the context of the small cell, what could be done, and by the way, it still actually requires some type of input into particular small cell stating the particular location. But now you could actually, at a minimum, do cell of access in the context of E911. So now you're at least able to identify what particular floor. I know that it tends to be a little bit more challenging in the context of DAS because, it's within a building or within a floor. So this is one thing that small cell kind of brings an advantage in because you could at least identify cell of access.
Yeah, I mean, we've had to make sectorization considerations for a building, to be able to provide that type of location general area to meet the requirements for E911. Especially when you're talking about multi-campus, multi-building campus kind of deployments, and it drives your sectorization, which again will give you some sort of localization for the users.
Okay, that sounds great. Well, I thank the panel for answering all these questions. and for our audience for fielding these questions as well. A round of applause for our panelists.
So we're going to take just like a 2-minute break so that we can swap out panelists and stuff. The next session is going to have 5 different topics within the session. So we'd like to have the speakers from the medical center, the public safety, and the subway topics come up. And then we'll take a quick break and swap out for the last 2 when they're done. So again, for anybody who may have just joined us, if you're here in the room and you have a question for any of the panelists, please raise your hand or get a note card from the back table and then raise your hand and we'll collect your questions from you. And if you're watching online, you can submit your question by sending an email to livequestions, livequestions, @fcc.gov. We'll try to get to as many questions as we can given, time constraints because we're packing it in today. We have a lot of information. So the next panel is deployment and uses of DAS and small cell technology. Like I said, we have 5 different uses that we're going to discuss today. Medical center, public safety, subway, campus, and summary of in-building. We have all the speakers up here at the same time. There is one speaker's not, Pinder on the agenda is not here yet, but Nate said he's going to fill in and cover everything for you. So the 2 moderators we have for this session are Dana Beta, who's Assistant Chief in the Competition and Infrastructure Policy Division in the Wireless Bureau here at the FCC, and Saurabh Chabra, again, will be taking the seat. He's an engineer in the same division in the Wireless Bureau here at the FCC.
All right. Well, it's great to see everyone. I've had an opportunity to work in wireless for over 10 years with Jeff Steinberg and a number of the individuals who have put on this panel, and I recognize a lot of you. It's great to see you come and join us today. I think we've got a very interesting group of speakers, and we're all excited to get started. Our first speakers are Julie Song, President for Advanced RF Technologies, and Arnold Kim, Chief Operating Officer for Advanced RF Technologies. They're going to be discussing the use of DAS and small cells in the medical environment. So we'll start with you.
Well, thank you very much to Donald Johnson and the FCC for inviting ADRF to this very special occasion to share with you and our industry. We are ADRF, a pure-play original equipment manufacturer of distributed antenna system, or DAS, and we're a founding member of an industry we proudly and passionately call in-building. Memorial Sloan Kettering Cancer Center, or MSK, really needs no introduction. It's world-renowned as the highest quality, most advanced, most comprehensive healthcare organization fighting cancer. The world's oldest and largest private cancer center, Memorial Sloan Kettering Cancer Center, has devoted more than 130 years to exceptional patient care, innovative research, outstanding educational programs, and according to U.S. News and World Report, Memorial Sloan Kettering has ranked as one of the top 2 hospitals for cancer care in the country for more than 25 years. In addition, the 2015 Best Doctors issue of New York Magazine recognizes more cancer physicians from MSK than any other hospital in the New York metropolitan area. Their newest outpatient location in West Harrison provides care closer to home for their patients and their caregivers living in Westchester who might otherwise have to travel to Manhattan for treatment. And as you can imagine, for folks dealing with chemotherapy and such, a little inconvenience can mean a lot. So patients are treated with MSK's multidisciplinary disease management teams, which combines the expertise of many doctors to ensure that patients who need several different therapies receive comprehensive cancer care. MSK's desire was to bring robust, mission-critical wireless coverage to enable their staff's productivity and patient-guest communication, which befits MSK's reputation as a premier cancer research and treatment organization in the world. How do you do that? The answer is DAS. The reason why DAS is so compelling is because anytime you ask the question, how do I best achieve robust mission-critical coverage in my venue, the answer is always DAS. And with the healthcare vertical, it takes all the compelling reasons for DAS and amplifies it, magnifies them even more so. And what do I mean by that? The wireless solution at MSK, West Harrison facility, had to provide both mission-critical communications for physicians and clinicians to ensure the highest quality of care, but it also had to provide robust coverage for its patients and guests for a treatment and guest experience. Regarding the former, each patient, when they actually go into the facility, are handed a pager that they wear at all times to track them, and that utilizes the paging 900 megahertz frequency band. Regarding the latter, our DAS solution had to accommodate all the U.S. carriers, given the inherent bring-your-own-device phenomenon that was alluded to earlier. So although Sprint didn't initially join the system because of sufficient macro coverage, they eventually will to utilize their extraordinary 194 megahertz holding in the BRS 2.5 gigahertz frequency band. AT&T, on the other hand, want to future-proof the capacity at the venue by requesting WCS 2.3 gigahertz support, even before they had any signal sources to go into the DAS. So in any of these cases, whether we're talking about paging or Sprint's 2.5 or AT&T's 2.3, the ultimate modularity of the DAS enabled MSK not only to support the desired frequency bands with no wasted investment at the current time, but also to maintain the future-proof possibility of adding frequency support at any point in the future. One of the most compelling aspects of the healthcare vertical, and certainly prevalent at MSK's West Harrison facility, is the dense building composition. We're talking about lead in the walls, we're talking about X-ray machines, CT scanners, patient beds, that severely attenuates wireless signals. And moreover, specific to this facility, there was a topology as well as a IDF closet, telecom closet space constraint that drove the decision from an RF design perspective to use outdoor high-power nodes inside the building. And that was a perfect fit for the venue. Furthermore, our DAS head end accommodates virtually any type of signal source, and we're talking about anything from a base station at 40 watts, a remote radio head, a small cell, a repeater. And what that does is, for some of these wireless service providers, it allowed them to initially feed the DAS with a repeater, knowing that they would eventually move to a small cell. Some of the carriers decide to inject a base station to begin with. But that ultimate flexibility in both the input type as well as the output power is a perfect example why DAS is the most ideal solution for healthcare facilities. Within our in-building industry that we're so proud of, we've recognized in the last few years the significant growth of what we call enterprise-owned DAS. That was also alluded to before. This is a deviation from the traditional model where carriers pay for DAS, and MSK is certainly a prime example of an enterprise customer really stepping up and investing in their own infrastructure. But it's incumbent upon us in the DAS industry to provide the easiest to use, the most intuitive, the most reliable technological solution so it's not intimidating to enterprise IT staff. And the staff that we worked with at MSK were top-notch, world-class IT staff, but it's not fair, it's not their responsibility to ask them to inculcate how to commission and optimize the DAS into what they do, which leads to my next point, which is, as I mentioned, ADRF is a founding member of the DAS in-building industry that we operate in. But 20 years ago, DAS was not nearly as commonplace as it is now, and the reason for this DAS and Small Cells Day. Yet it's still a relatively specialized niche within the overall telecom industry, and it requires a very deep and wide network of folks doing their own part within this ecosystem. What I mean by that is the carriers have their part. OEMs like ourselves have our part, but we also rely heavily on systems integrators, consultants, and in MSK Harrison's case, they had in-house union contractor. So it required a well-orchestrated professional deployment that leveraged all these different people working in a concerted fashion. And as you can see from the myriad steps that were involved, it started with a certain coverage scope and a certain design, and it morphed into lots of different things, and that's very typical for the DAS industry. But the need for professional coordination, especially as the enterprise-owned DAS phenomenon grows, will become even more critical. So we applaud the FCC for the tremendous progress in the 600 megahertz incentive auction, easily achieving the 126 maximum target. And we at ADRF, we stand ready to continue to support this exciting future with the most advanced technological solutions as represented by our DAS, especially for healthcare verticals, and MSK as a prime example of that, with the most important features such as modularity, flexibility, simplicity, and professional coordination. Thank you.
All right. Arnold, I had a quick question. Is the use of DAS at Sloan Kettering, is that unique, or are we starting to see DAS being used in other medical facilities similar to Sloan Kettering?
I think we showcased the DAS that we deployed at MSK West Harrison because it's such a great example, but it's certainly not unique. It's like I said, the healthcare vertical is prime for DAS. It has a BYOD component, so you would never know exactly which wireless service provider the guest, the patient, the clinician, the physician is going to bring with him or her.
Right.
And with the severe attenuation that is present in the building, it just sets up for a natural use case for DAS.
All right. Another question I have is, how does the DAS system interact with, say, the emergency room and first responders? Say, for example, there's calls coming in from first responders. Can the two interact?
It's a great question, and absolutely it can. And the beauty of DAS is if you have a proper architectural design for the DAS, and I don't want to get too far into the technical weeds, but with the modularity and the flexibility that DAS can provide, obviously we can cover all of the 4 major U.S. wireless carriers, and the U.S. has an extremely rich spectrum chart that all the carriers utilize in a different fashion. And so to be able to accommodate each of those spectrum slices, whether it's 700, 850, SMR 900, the list goes on, that's absolutely critical for DAS. But we also support Public Safety 700, Public Safety 800, UHF 450, VHF 174. And to be able to accommodate those frequency bands on the same technological solution for an enterprise customer is critical, because those are the frequency bands that the public safety community uses. That's different from what commercial carrier operators have utilized. And for an enterprise customer, they don't care.
Right.
They want to have robust coverage for both of those needs.
Sure.
And if it's on one common system, so much the better.
All right.
Okay, we have a question right here from the audience. With Could you please describe the various medical and telemedicine applications of this deployment?
Well, the beauty of the DAS is the applications, or the DAS is agnostic to the applications, meaning we're supporting as rich a transport medium as possible for the providers, the creators of that capacity on whatever frequency band is supported in that local market by the commercial carriers. And so as long as we're able to provide bandwidth and connectivity, then the applications community, they're infinitely more creative, and they can come up with whatever applications to enable productivity for the physicians, the clinicians, and just utilize that connectivity and bandwidth.
Okay. Thank you. Thank you. We'll go
Right.
to the next
Julie,
panel.
were you?
Oh, I think.
You good? Okay. Go ahead. You want to introduce the next panel?
Yeah, go ahead.
You good? Okay. Next up, we have Chief Alan Perdue. He's the Executive Director of Safe Building Coalition. And Mike Collado, Vice President of Marketing at Solid Americas. And they'll be on the public safety panel talking about DAS small cell solutions for legacy two-way public safety radios, new fire code ordinances for buildings, and interoperability.
Well, thank you, and good morning, everybody. Thanks for the great turnout this morning, and as well the folks that are following online. We're actually switching things up a little bit. My name is Mike Collado. I'm the Vice President of Marketing for Solid, where we keep people connected and safe through a portfolio of commercial cellular and public safety DAS, as well as optical transport for backhaul and front haul. It's easy, given our haircuts, how you would confuse Chief Perdue with myself. That we have a great segue. Some of the last couple questions really teed up the public safety talk very nicely. And the last question regarding how does DAS manifest in a hospital, and where does public safety fit in? And public safety in a hospital is pretty quintessential. So, not only are you supporting the commercial cellular, but you have the private two-way radios that are used by the staff on site within the hospital that are covered by a DAS system, as well as the first responders that are bringing patients in and out of the facility. These DAS systems, these in-building systems, are very important in a healthcare situation, and Solid certainly has its share of clients, including Kaiser Permanente and Parkland Hospital, among some others. Solid as well is providing the DAS for the MBTA that Joe Mullen will talk about here in just a couple minutes. We're also on various college campuses where, once again, you're sending your kids off to college. You're expecting to be able to reach your kids, but also that your children are going to be safe, to be able to be communicated, to call for help, to be able to receive information in the event of an emergency. College is not in addition to college campuses, stadiums. There'll be a presentation later today about Super Bowl facilities, and one of Solid's customers is the Daytona International Speedway. Later in the day, Alex Gamata, our friend from American Tower, that's a project that Solid's done. Again, you've got this influx of people that need to be able to communicate and call for help should they need to call for help, and respond to instructions regarding any emergency situation. That continues to translate into other industry verticals that Solid plays in, office buildings. The Ronald Reagan building is one of our buildings, and the middle prize, which was talked about in the earlier session, the middle prize being the enterprise, the smaller buildings that are between 100 and 500,000 square feet. Once again, I do want to thank the FCC for inviting Solid back. We were here 4 years ago where my colleague presented a very simple premise about public safety, that public safety is about the ability for the general public to be able to receive communications in the event of an emergency, to be able to call for help in the event of an emergency, and for the first responders, the fire and police and EMS, to be able to communicate inside of a building during an emergency. And really that became the foundation for the Safer Buildings Coalition, which Chief Perdue heads up. Essentially, it was a call to action for the industry, the wireless communications industry, as well as public safety and other stakeholders, to come together to solve for what is essentially a life safety system. You consider the fact that the majority of calls originate and terminate inside of a building. The fact that the majority of emergency cases occur inside of a building, there's a need to solve for that, and Solid's focused a lot of attention on that, and it's something that we can apply technology to solve. In fact, last year we published a ebook called The Imperative. The Imperative basically is a view that looks at how does the public and how does public safety interact in order to make buildings safer. I have a couple of slides here. I'd like to just briefly share a couple of revelations that we uncovered over the last 4 years of presenting at industry conferences such as this, and in the writing of the public safety imperative. And number one is, and I think I've already set that up, is that we need to keep in mind when it comes to public safety that there is the public in public safety. That's you and me. That's you and me to be able to, once again, to communicate and receive information. Wireless is essentially a life safety system, and we're carrying that on each of, through our smartphones. Secondly, I'd like to call attention to a paradigm shift. Often we think about solving for wireless communications with an outside-in approach. Given the fact that the majority of calls originate and terminate indoors, the fact that most of the emergency calls and incidents occur indoors, I think we recommend and observe that there's a need to change the paradigm from public safety not being a last mile problem, but a first mile solution. And in-building plays an important role in that. A third observation is, and this is truly the elephant in the room, and I think I was talking with Don Johnson before the panel about one of the biggest problems with public safety is that the people that need it most don't have the budget. And I know that in D.C. we're all full aware of the FirstNet initiative with $7 billion allocated to build a new public safety broadband network. And $7 billion sounds like a lot of money. But the fact is that commercial operators are spending $7 billion each year simply to maintain their network. So it's really not the carriers that are going to need to pay for this. It's the building owners. Building owners, from a leasing perspective, the ability to provide a safe building in order to attract tenants, it's paramount that we understand that the building owners are the ones that are going to fund these, and building and business models will similarly emerge. We touched earlier in the other session about convergence, and I think it's attractive and for us to think about converging public safety with commercial cellular from a business perspective. It's a neat way to layer on a solution to a commercial cellular DAS. However, the reason that I would argue that commercial cellular and public safety today should not be converged is technical. Public safety requires about a fourth of the infrastructure needed in order to provide the wireless coverage compared to LTE. In the future, with LTE and and the FirstNet initiative, which is an LTE public safety broadband network, convergence could become an attractive option. But generally today, you're going to do a separate layer for public safety. And lastly, and as a way to tee up Chief Perdue here, we would observe that codes are complicated. They're not uniform. We were speaking earlier this morning with some of the attendees here that you have two code-making bodies, and each AHJ, that is the authorities having jurisdiction, can cherry pick from a code and adopt whatever language that they want. That informs that it's impossible to have a repeatable process. If you're a real estate investment trust, a REIT, and you have a portfolio of buildings to solve for, it not having uniform codes whereby your neighboring jurisdiction has different code language makes it very difficult to create a repeatable process to deploy and solve and comply with those codes. So we would argue that some good work has been done. In Florida, Bill 535 was passed in March. That is a code that requires new and existing buildings to meet minimum requirements. However, I think a lot more work is yet to be done. I think that's an area where Chief Perdue and his organization have been focusing a lot of attention. Thank you.
Thank you, Mike. Again, it's an honor to be here and speak for the FCC and represent the Safer Buildings Coalition, which is a public-private not-for-profit partnership that's dedicated to education and advocacy as it relates to in-building. I'm going to throw two numbers out, 70% and 64%. 70% are the number of 911 calls that come from a cellular mobile device. 64% of that 70% come from indoors. So having the capability to call for help when an emergency occurs is critical for in-building. It's not a nice thing to have. It's a necessity. People expect that. There's a public expectation. So it's relevant to how we do business today. A question was asked earlier in the earlier panel about what are property owners doing? If property owners aren't taking care of this situation, they're not going to have tenants because tenants are expecting coverage in buildings. And we see that in some of the work we're doing with REITs and property owners and others. One of the things I want to talk about is three things we look at is, one, can you call for help when you have an emergency? Number two is, can we push information to you? Mike mentioned college campuses. One of the things I often talk about is an active shooter event at a college, a university. Part of their plan is we're going to notify the student populace that there's an incident taking place. How do they do that? Text message. What if you don't have coverage? The plan has zero value. So it's critical that we look at that. We talk about shopping centers and events that are taking place out there in our world today that we live in. This happens constantly across the U.S. and the world. So we've got to find a way to get coverage inside buildings. And the third piece is, when we respond, public safety. I spent 36 years active response in public safety and now do some administrative stuff, public safety. Can we communicate when we get there? I've been on the scene where I'm trying to talk to our personnel inside a building and I can't communicate. You know, I often say we can talk to people on the moon and watch them get there, and I can't talk to firefighters inside a building. I'm standing in the street. How do we overcome that? It's by industry working together with public safety and developing solutions, and DAS happens to be one of those solutions that's available. We have to find a way to make it cost effective that building owners can put this in their building, and it becomes part of the life safety ecosystem of that building. I say that because fire sprinklers are in the majority of the buildings you go in. Fire alarms are in the majority of the buildings you go in. So I want to do a quick history lesson. In 1878, fire sprinklers were invented. In 1896, the first fire sprinkler code was adopted developed and adopted here in the United States in some areas. Now, I translate that to in-building requirements, which are now in the code. In 2009, in-building became a requirement for public safety systems. So you have to put those in areas that are adopted, whether it's through the International Fire Code published by the International Code Council or NFPA 1221, which is published by the National Fire Protection Association. Those things are becoming more and more uniform. In the fire sprinkler industry, in the first 4 years that the sprinkler code was there, 200,000 sprinklers were installed. In 2002, 35 to 40 million fire sprinklers were installed. This is coming. Public safety is here, whether you want to be a part of it or not. Public safety is here. Public safety is going to stay. And it's imperative that we have the public to be able to communicate and public safety communicate during those emergencies. Thank you.
Yeah. My first question is, do you see any limitations in a DAS system responding to first responders? I'm thinking about like stairwells, garages. Are there any limitations that are of particular concern?
The code is very specific on the coverage requirements. 99% in stairwells, fire pump rooms, and areas where public safety are at. 95% coverage throughout the remainder of the building so that we have that capability. And those systems have to be tested on the initial installation and then annually thereafter and monitored through the fire alarm system to ensure capacity.
I would just add that's a key differentiator. Typically, in a commercial cellular DAS or in-building solution, you're not going to deploy in the stairwells, and those. But those are essentially really important areas where the fire service does their work.
Okay, we have a question from the audience. Question is from Ken, and this is for Chief Perdue. The NFPA requirements for coverage extensions are very voice-centric. What efforts are underway to extend NFPA code to include FirstNet's LTE data network? It is a future public safety mission critical voice platform.
Excellent question. One of the things, I just attended the code hearings in Kentucky week before last, and we've submitted a proposal that includes data, voice and data as part of that component. We have some education to do amongst ourselves, our peers that serve on the fire code hearing committees, both in the ICC and the NFPA process. But there's work to do, and we have to include that because it is part of the critical communication systems public safety utilizes.
Okay. Thank you, Chief. Next up.
All right. There is no more questions. We'll move to the next speakers. Our next speakers are Joe Mullen, Chief Technical Officer of Insight Wireless, and Gary Foster. Is Gary on the phone?
Gary is on the phone.
Gary is on the phone. All right.
Yes.
Gary is the Chief Information Officer for the Massachusetts Bay Transportation Authority. All right, Joe.
Hi, Joe Mullen, CTO of Insight Wireless. Just a quick rundown of who we are, and then I'll let Gary say a few words of introduction. Insight is a wireless infrastructure company. We have about 1,300 radio towers, about 20-plus DAS systems. We have facilities that are in, as Mike alluded to, multiple venues, convention centers, stadiums, hospitality, and transit being probably some of our key areas. So, Gary, would you like to say hello?
Sure. Hi, Joe. Hello, everybody. Sorry I can't be there in person today. My name's Gary Foster. I'm the Chief Information Officer here at the MBTA. MBTA is the regional transit authority for all of Greater Boston, stretching all the way out to Worcester and eventually to Springfield and down to at some point to New Bedford. So we cover most of eastern Massachusetts. We have an older transit system down here in the city. We'll talk about that in a minute. But I've been here for 8 years, and I've been working with Insight Wireless for the last 4.
Excellent. Thanks, Gary. Just to jumping back here on the slides, we are just to highlight some of Insight's projects. We actually have 3 transit systems. The LA Metro has just launched in our first phase of 5 stations. Verizon is up and running out there. We have T-Mobile and Sprint that are in the process of turning up. We continue to build. There's 20 stations total, and so we're applying what we've learned at MBTA out on the West Coast. We also have been awarded MARTA in Atlanta, and that's a very recent award. This year we will be doing a pilot system there to demonstrate proof of concept in the Atlanta market, and rolling out there as well. There's approximately 16 stations there. And in addition, any of the stations that above ground that have parking garages or need additional coverage will be included. And then, so jumping over MBTA, which is kind of the major reason of our topic here, and the chief here brought up a little bit of history. So just to so that we're included in the history lesson as well. The MBTA actually was America's oldest subway, or is America's oldest subway. It opened in 1897. And so apparently for most of the first 100 years, there were no issues with cell service in the subway. And so coming in towards the end of the 20th century, start of the 21st century, what happened was that certain carriers or a certain carrier started noticing that their customers wanted service underground, and approached the MBTA and started deploying some, I guess what we called them back then were mini BTSs, or mini base stations, in a few of the stations. And with that brought, for every base station, there was antenna, there was cabling to the antennas, there were telephone line connections for backhaul, there was power connections, and there were also probably a very large cast of characters of technicians and other support people, vendor personnel coming in and servicing this equipment. And that was all fine and well until additional carriers started coming and saying, we'd like to do the same thing. And the MBTA said, well, we think it's a good idea, but there's got to be a better way. We can't have all of these people from all of these carriers coming in just due to safety, security, logistics, all of these concerns, and just MBTA staff to support them. It was rapidly becoming unmanageable. So what happened was that the MBTA, being aware of the technologies available, and this was right around 2000, started with putting out an RFP, and they had a response. It was basically required fiber optic throughout the whole subway. It required, or at least the proposed solution was putting radiating cable throughout the entire subway. The winner brought it to the carriers, and the carriers said it was too expensive. They weren't going to pay for all that. That was the second attempt at that, and basically the same result, the same answer, the same result. And then the third time, for us at least, was the charm. That there was an RFP, and that this time there was actually a little bit different approach, or a little bit enhancement. MBTA at this point was deploying its own fiber DAS for its own transit radio system, as well as public safety, and was running fiber throughout the subway with its own personnel anyway. And so, in the idea of killing two birds with one stone, they said, hey, if we're pulling one fiber optic cable, why don't we pull two, and we'll reduce the cost of this deployment. That was one of the things that made life a little easier. And the other thing that Insight did, and it was that we looked at the subway and said, well, radiating cable is a wonderful thing, and we really like it, but you don't have to use it everywhere. There's some opportunities to use antennas in certain places, and we've really leveraged that to try to keep the cost more in line. So it turned out that was really a winning approach. The MBTA embraced it. We were pleased to go ahead. That year was 2005, and as part of our planning, we have done extensive testing. Actually, I guess I should probably move ahead here. So, yeah, this is the snapshot of MBTA. Gary had referred to the extent of the subway system. So here's a system map. The central portion of the subway system is all underground. So if you kind of look at the middle of where all those lines cross and go out about a third of the way on the lines there, that's underground area. And so, and talking about basically what was involved, and I'll just go back to that last one. What was involved in all this process? We had a few things that we did. We worked with a manufacturer to develop some special antennas that were particularly suited for the subway. And we had a additional deployment. Our initial deployment was cell PCS. Life was easy in those days when we had 850, 1900 to worry about. And so then we had to actually do the installation. And working in a subway is a little bit different than working in the rest of the world, as Gary can tell us. The trains run 7 days a week. They only shut down in Boston 4 to 5 hours a night. And by the time that we get track access, get the power shut off, that any work trains have to come through or other vehicles have to come through, get the flagmen in place. If we get 2 hours of night of work, we're doing pretty well. So that's really one of the challenges we had. The other challenge is it's a pretty extensive undertaking, and so in any of the situations, we look at this as not a 1-year project or a 1-year budget item for the carriers. It's really too much. It's a matter of there's a benefit in addition to the pacing of the work of spreading this out over a few years. I think we spread it out a little bit longer than we hoped in MBTA, but it did take us several phases. Now, one of the things that I'm just flagging here in the slide is that, as you can see here, that the ridership of the subway is approaching 250 million. It's on an upswing here. This is not the usual data curve we see, which is like a hockey stick of usage, but it's in the transit industry. This is good stuff. We've got a breakdown of the lines. The red line was one of the first lines we focused on due to the ridership. We have all coverage on all the lines now. And then, so just to summarize what was involved, we had 5 phases of construction from 2007 to 2015. And explaining some of that, it was that we started with the red line, orange line, green line, blue line. Those were the heavy rail and light rail lines. Then we added a silver line most recently, which is a bus rapid transit with a tunnel. And also, we've added the commuter rail and Amtrak in the Back Bay of Boston, which was a dead spot for the Acceler in the Northeast Regional. So that was something the carriers wanted to get taken care of. So these things came in a little bit over time, the bulk of it earlier, but it came together. It's come together probably in the last couple of years, where now we have in the lower right-hand corner here, we have all 4 major carriers in the market: AT&T, Verizon, Sprint, and T-Mobile. We also have Comcast on providing Wi-Fi service in the stations, and they seem very pleased with that as well as an additional form of communication there. So we've really covered, if you look at the commercial wireless and Wi-Fi, we've covered those bases. So overall, just to run through the numbers, it's 21.1 miles of tunnel, 40 underground stations, 170 remote equipment locations, 454 antennas, 642 remote amplifiers, and over 82,000 feet of radiating cable, and about 21 miles of fiber optic cable. It's a lot of radiating cable. Sometimes you just can't use antennas, and certain tunnels are too tight. But we did antennas wherever we could, and radiating cable and the rest of it. So, as an overview, one of the things that we offer is continuous coverage. This was a requirement from MBTA, and continuous coverage end-to-end in the stations and the tunnels. All right, so there are other systems, maybe even in this city, where phones work in the station but not in the tunnel. The real benefit that we see is that when people get into the train and settle down, they want to be able to use their phones, use their service. So people get uninterrupted calling, texting, videos, gaming from above ground, below ground, and back above ground. And as they say on the London Underground, it's good service on all lines, whether it's a train line or a phone line. So really, in conclusion here, it's all about the smartphone. I mean, anytime, if you look here on any train, I think there's one lady in all those pictures that's actually reading a book. Everybody else is glued to their phone once they get on the train, once they get settled. And there's public safety. We have the billboard that says, hey, if you see something, do something. So there's you can call the MBTA police, you can text, and then the police have also come up with an app, which you can address. And Gary, I've used up a lot of our time, but I'm sure that people will be flexible and maybe give you a chance to kind of give some thoughts and reactions to the DAS.
Yes.
Sure. Thanks, Joe, and excellent job. Yeah, what I'd probably like to add is that when this was put together, the real challenge was getting the carriers on board. Once we got the carriers on board, and the Comcast Wi-Fi was a little bit of an extra. Once we got all the major carriers on board, the customer, one of our key concerns here was how do we increase customer satisfaction? We can't replace these old tunnels. We can't. It takes 10 years to replace all the trains in the red line. What can we do for these customers to make their trip better? And anywhere in the 95% of our customers having some kind of cellular device and 70+% having smartphones, as you can see from the photos Joe showed, people have taken advantage of that. As soon as we got this continuous network with all the major carriers on it, there was an informal poll done by one of the newspapers in Boston about a year and a half ago, and they wanted to know what the top 10 things people liked about riding on the MBTA, and the fact that we had continuous cellular service from all these carriers, I think, came in third out of trains on time and public safety being the only things ahead of it. And so I think customer satisfaction is something that, I can mention that Joe hasn't really covered. It's really helped us. I can remember on the Red Line, there's one station where you have to go over Charles River, and you'd leave the tunnel and you'd re-enter on the other side. So everybody would grab their phone when they were coming out of Park Street Station. They'd make the call or the text message home saying, I'm running late, I'm ahead of schedule, I'm behind schedule. Because they had that 2-minute window while the train was above ground, and then it would go back under. That's what it was like in 2005. I've been riding the T my whole life, so I'm a Bostonian. So being able to fix that in all of our underground stations throughout the subway system in Boston has been incredible upgrade for our customers, whether they're texting or on YouTube or whatever it is they're doing. So I think that customer satisfaction is probably number one. I think a lot of people have talked about public safety. All I'd say is we have a system-wide radio across that's available in all of our tunnels. We've made sure that works well and doesn't conflict with the DAS network, and we're in good shape there. But we have employees who are in the tunnels, and we have contractors in the tunnels. You can be on the right of way without a radio, but if you're on the right of way, and I remember we had some damage in a tunnel a year and a half or two ago, and we were able to send people in there and immediately have photographs sent back to the control center of what the damage was. So the fact that we can take pictures and upload them, you can't do that with your radio. So the system-wide radio is our number one public safety device, but the cellular phone for non-drivers. If you're a vehicle operator, you do not have a cellular device on your person. But if you're a non-operator, a safety official, or someone or a transit policeman, and you do have a phone on you can use it for so many different things. We have increased public safety to a degree as well. The combination of our system-wide radio and the kind of cellular coverage we have has given us tremendous capability in all of our stations and tunnels, and of course our customers, as Joe mentioned, have access. If they see something going on a train, which happens, and then they're concerned, they can get a hold of the transit police in seconds. The transit police have a special dispatch to take those text messages and messages from the application we have. So we have increased public satisfaction and customer satisfaction as well as safety. And I think the other thing is that the DAS signal in our subways is probably better than it is on the streets of Boston. We probably have some of the best coverage in the tunnels we have in the entire city. So it's plenty of capacity for the number of people that go through those tunnels every day. We have a couple 100,000 riders a day on the Green Line. When they're in the tunnels, they all have great access. There's no real performance problems, which is pretty amazing. So all that being said, that's really critical. The other piece for us is our employees. We have 1,000 employees that have a cellular device, whether they have access to it. All of the companies in Boston, people are reading their emails, they're doing work. People are productive. People have the option to be productive on our vehicles on their ride home, on their ride in. It's a big upgrade from where we were 6 or 7 years ago. So I'll leave it at that, Joe, unless there's anything else you want me to cover. There's plenty of other things we could talk about. The fact we pulled this off in those ancient tunnels under Boylston Street and Tremont Street is pretty amazing. But that's pretty much all I'd like to add.
I think did you have time for questions still for us?
Yes.
Or? Yeah. Great.
So if I understand you, Joe and Gary, 100% of the subway system, both above ground and below ground, have adequate wireless service. Is that correct?
Gary?
That
100%.
is correct.
There are
some above ground. There are some above ground areas where we may not have perfect service, but we have service. Our entire subway system is covered with service. Our commuter rail system, which is kind of a separate conversation, is not part of this contract. Probably has some spots where we don't have the service we have, but we do offer cellular-based Wi-Fi on about 50% of our commuter rail vehicles. But all the subway system above or below ground has at least adequate service, especially from Verizon, who by far has the best coverage in the Boston area. The other carriers have caught up, but Verizon's still the leader. So if you've got a Verizon phone anywhere in our subway system, or an AT&T phone, or probably even a Sprint phone, you're in pretty good shape, above ground, below ground, anywhere.
Well, that's good enough for me. I'm moving to Boston.
Yeah, it's a great city.
Yes, it is. Yes, it is. Right. Good, that's good. All right, thank you.
You're welcome.
Thank you, Gary.
My pleasure.
Okay, next up we have two presenters who will be joining us via the teleconference. Let's make sure that they're on. Mark and Gary, can you hear us? Mark?
Yeah, this is Gary. I can hear you.
Okay. Who's that? Mark? Is that Mark or Gary?
Gary?
Hello, this is Mark. Can you hear me okay?
Yes, we can.
Great.
Well, thank you for confirming. So next up, we have Mark Zuber, Head of IT for Kirkwood Community College in Cedar Rapids, Iowa, and Gary Mayer, an integrator at All Systems Installers. And they're talking about, we're talking about the campus panel at Kirkwood Community College, Cedar Rapids, Iowa, a DAS solution in a community college environment with hotel management. Mark and Gary?
Great. So thanks very much. Yeah, my area, so I think I'll just jump right in here. I'll introduce myself a little bit, and then Gary will, and then what I'll do is I'll just give kind of some background info into the circumstances and opportunity that moved us to a small DAS solution, and then just the fairly simple requirements we established. And then Gary will step through with more of the technical information and the processes that led us through that successful DAS deployment. So I've actually been with Kirkwood for about 18 years, and I manage the telecommunications environment at the college. So structured cabling, PBX systems, the wide area provisioning are my areas of focus, and just recently the DAS. So, Gary?
I'm Gary Mayer, and I've been in the wireless industry for about 35, 40 years now. Started in the two-way business, went in the microwave for a while, point-to-point, and then worked for a manufacturer, ABC Telecommunications, for 20 years, and then moved over to AT&T for about 3 or 4, and now I'm at one of our installation partners here in the Twin Cities, doing the install aspects. So I've kind of had my share of all avenues or all areas of the business here in terms of, from service provider, manufacturer, as well as installer at this point in time. So that's my story.
Okay. So I'll jump right in here again. So not to insult anyone's geographical knowledge, but there's sometimes still confusion. I want to make sure we all know where Iowa is. It's not Iowa or Ohio. We're right in the middle ground there. At Iowa Corn, Iowa Hawkeyes, the first primary, all that stuff is right there. And we are one of 15 community colleges in Iowa. Our charter is a 7-county area in eastern Iowa. And with that next slide, you can see that we're really a hands-on institution. We've got a 417-foot wind turbine, an equestrian event center, and then now the hotel at Kirkwood Center. These are all labs for our students to learn their craft. And it's just kind of how we do things. But the wind turbine did not stimulate us to do DAS, neither did that equestrian event center fuel that desire for DAS. Rather, it was the prospect of hundreds of weekly guests to our hotel conference center that was really the impetus to do DAS and to seek a system that could also expand into main campus as well later. And the way that happened was Lee Belfield, a 30-year veteran in the hospitality industry and serving as a food service and hospitality instructor, just kind of leaned over to one of our instruction branch executives and suggested we build a hotel to serve primarily as a lab for our students to learn the business. Several marketing studies followed and the project moved forward. So in scope, it's a 4-story, 71-room luxury hotel with connected conference center. The conference center has a capacity for about 500. Today, the hotel's high service standards have earned AAA's 4-Diamond Award for lodging. It's the only 4-Diamond Award winner in Cedar Rapids, and it's also the only teaching hotel at a 2-year college in North America. So that backstory is important to the DAS project because that AAA 4-Diamond distinction was intentional. The project meant to pay attention to every detail in order to provide everything that a guest would expect from a hotel like that. So in turn, setting the standard for the guest and our 350 students learning how it should all work. That would include effective cell phone coverage in not only the guest rooms and hotel lobby, but also in the already existing and adjoining conference center, where there really wasn't adequate penetration. The conference facility was built first and had opened to the public 2 years earlier, but many of those attending those functions at the facility were going outside or, kind of leaning against the windows to access their carriers. So our requirements for the DAS were pretty basic. We wanted all carriers to participate. All areas of the hotel conference center would be served by the DAS, administration offices, basements, storage, kitchens, all functional areas, service areas. Guest cell phone experience was important, but we saw cell service for operations teams as part of that same customer service dynamic that is important for business operations, for delivering trucks, catering, and other vendors, and of course public safety concerns as well. So the system would have expansion capability via our single-mode fiber, so that we just had 1 or 2 other places around campus. We had pretty good coverage campus-wide, but there's just a couple other points, areas of the college where we didn't, so we wanted to be able to leverage this opportunity for that. And so, in addition, the current and predominant data rate amongst carriers would be fine. That is, we didn't see as necessary to achieve, that next competitively marketed rate, unless they were all at that rate. So finally, it would be funded as part of the building project. So did an RFP with all that in there. 3 responded. Floor plans were shared with all 3. All 3 met the requirements with their designs. However, there was just one that actually made the trip to do a proper survey, and it was discovered the top 2 floors did have adequate service. So for that vendor, I believe it brought it down to the cost enough to win the bid, and it jump-started a working relationship with Gary. And with that, I'll just hand it to you, Gary.
Okay. Having said all that, Mark asked me to participate in this and kind of just go through basically the overall steps that we had done to do, to work on this project, to win the project and move forward. So basically what I've kind of gone back here and I've taken, if you move to the next slide, kind of just the general procedures that, we go through when we formulate for DAS purposes. And, when we take a look at doing a DAS, some of the questions we typically kind of ask are, is this a single service, provider type DAS, or is it or is it a neutral host? What bands do each one of these service providers have? How is it going to be fed? Will the DAS be fed with either a repeater or will it be BTS or a combination thereof? And, and if it's a repeater type scenario, typically that ends up meaning it's going to be a whole fill type scenario for the service providers in terms of feeding that building. And if it's a BTS, a lot of times they want to, it's almost like capacity as well as coverage enhancement, so they want to dominate and make sure that whatever signals inside that building from a BTS perspective is addressed. And so they are, you're actually just on that DAS. When you're on that DAS, you're on that radio system that's feeding that DAS in that location. So once we get all that kind of decided, we then get floor plans. We do a site survey, we understand where everything's located, do signal measurements, and then we generate a design based on that. Once that's all designs all created, we go generate the quote in terms of installation services, commissioning, the product, all that, and then we come back and submit the bid to the project. And on the assumption that we won the project, we then in turn, once we get the award, get the equipment all on order, and then while that is all happening and we get all staged and ready to go, a couple of other things. If it's a repeater-fed system, one of the things that we need to work on and keep diligent on, because that takes a lot of the time in terms of getting these things on air, is the rebroadcast agreements with the various carriers. If it's a BTS-fed solution, in those we work to try to make sure that all the power, air conditioning, all the network is in place to allow the interface to happen between the BTS and the service provider's network. If you move to the next slide, at that point in time, we just basically, we can install it, we commission it, and then make sure that the DAS is running as it should be, and then we start plugging in the various service providers. And those service providers, depending on where they are with the rebroadcast agreements or on the contracts with the enterprise or end user, they get plugged in appropriately. Unfortunately, they never happen at the same time, so this ends up being sometimes a lengthy process. In this case, it was several months. I've worked on projects where it's been 1 to 2 years before all the various carriers are on board on a neutral host DAS, which can be somewhat frustrating for those people that want to use the facility, and use their phones within that facility. Lastly, we had done optimize the DAS, and then we generate an as-built documentation set for that. The next couple slides here are basically, these are cut and paste directly from the as-built documentation set. As you can see on the date here, this was dating back to September of 2010. So this DAS goes back almost 6 years now, and as a result, things like LT 700 and AWS were still just kind of in the works. And this DAS at that time was cutting edge and had all of 800 and 850 and 1900 PCS service on it, and moving forward. So, and part of the as-built documentation set, since this was for an enterprise customer, which was also relatively infrequent back then, most DASs were funded by the carriers. It was very rare that we had an enterprise funded project. And so I took some extra care here to make sure that the documents and things that I added to it kind of made it so it was user-friendly, since they were ultimately responsible for the DAS that they had purchased from us at that time. So basically what I did is I went through, and then at each location where I placed an antenna, I showed them kind of on a floor plan where the antenna would be located. And then I also gave them an idea on the slide thereafter, kind of what their coverage would look like. And so you got to get that way when they walked around with the phones, they got a general idea of whether or not their phones were actually performing as they should be. I gave them a signal indication, in terms of strength and whatever. And I did that on a per floor basis. So these, that happened to be the basement. Moving on to the next location, you'll see where the closet locations were, which is the first floor. You can see the closets. You'll be able to see where the antennas were, and then the slide after that would be then also the coverage predictions as such as well. And then finally, moving up to the last floor that we provided coverage, which was the second floor, again where the antennas were located, as well as There's a vertical riser where the cables that ran down from the rooftop where all the donor antennas were for this particular DAS, where they connected up and where they ran through, and then also the coverage on second floor. And then you've already kind of seen on the next slide thereafter that on floors 3 and 4, based on the site survey, we didn't need to have coverage since there was adequate coverage from the macro network on the outside. Also, as a part of this as-built, I also gave them a system interconnect diagram. This is where I took extra care and showed them that instead of just using block diagrams and lines and arrows, I actually went so far as to actually try to find physical picture representation, since they were the ultimate end users and had bought this system that they understood when there was an alarm or if there was something that had a failure in it. You could see the actual representation of the device where the product was what it looked like, and so that they knew kind of when somebody called and said we had an outage, they could then relay that directly. And when they called me up and said I had an alarm, I could say, well, take a look at the main hub or the expansion hub, and they would have physical kind of representation and where the antennas were connected and how they were physically connected to it. Moving on, then I also went so far even to show them what the donor antenna systems looked like, where, if you go on to slide 22, even the current, where the frequencies were, what bands, they even give them that kind of information. Again, just in case there's any sort of issues with the AT&Ts or the Sprints or the Verizons in market, if this is where everything was tuned and this is where everything was outlined. And again, if you go beyond that, you can see here's their repeater, here's what their antenna on the rooftop looked like and how it was all physically connected into their DAS. Did that for a dual band solution, so those service providers that had 850 and 1900, and then also when you had a 1900 only solution or an 800 only solution, that would be kind of what the boxes and the interconnect diagram for it would look like as well. And then finally, on the last page, I just kind of, here's the timeline of how long the project basically took. Basically, the RFP was kind of kicked off and sent out on the end of February, approximately after we were going through all the various bid quote processes and such. About 4 or 5 months later, the DAS was awarded and we had it installed, and then we spent another 2 or 3 months just waiting for the various service providers and all the rebroadcast agreements to get signed so that we could put them on air. And then finally, after about 8 months or so, the system was on air. Basically, that's it. So if anyone has any questions, feel free.
All right. Thank you, Gary and Mark. First question is, how have the students on the school campus benefited from the DAS system? To the extent that there is DAS in the classroom, has the DAS enhanced the classroom experience of the students and the teachers?
Oh, gosh, I don't know. That sounds like I'm not sure I could give much of a benefit. I think it's just because it just becomes an expectation for the access more than anything else.
Okay. Well, the question could easily be directed to the hotel management staff. How has it benefited them in their work, as well as interacting with their guests?
I don't know. I think for myself, it was more or less. I was more concerned in the beginning of all the complaints they could possibly get from their guests not having access. So really, just heading that off was my particular focus. So it's pretty transparent as they enter the hotel and the instructional spaces and the operational spaces. To always be connected.
All right. Okay, I have a follow-up question, Mark and Gary. Could the DAS be used to provide video and broadband in the residential campus? And also, as a follow-up to that, is there a potential to use the fiber that's already installed to eventually be used in other parts of the community college, perhaps in the outdoor environment?
I can answer the question about the fiber and the outdoor question. So the fiber that was used was already existing. Maybe I didn't point that out very well, but it was already in place. We did have to make some modifications to the terminations of that fiber to accommodate the low loss requirements of the system. But we don't really have any plans to satisfy any outdoor needs. They're really we do have pretty good coverage from all the carriers outdoors at this point.
Okay.
And then relative to the video and any sorts of things like that, I mean, at the age of this DAS, I'll be honest, it's a dated DAS. It's 5.5 going on 6 years of age here, and it was at the time that this DAS was a concept. It was provided service for cell phone usage basically. And data services that were contained within the 850 megahertz spectrum as well as 1900 PCS spectrum. Now, if you have video aspects that are associated with the use and you can channelize it and plug it in at those frequency bands, then yes, you can use this product or this solution to do that. The newer DASs that are coming out now in today's environment obviously have higher capabilities and more inherent design attributes associated with it that allow that to happen. But yeah, in theory, it's an open pipe at those frequencies. So if you can convert something and put it in those bands, you could reuse it for those aspects. But that wasn't the original design and intent for the product.
Okay, that sounds great. Well, thank you, Mark and Gary. And with that, we'll move on to our next presentation.
All right. Our final speaker is Nate Fuentes, Manager Business Development for CommScope, and he is going to be discussing DAS and small cell use inside buildings. Nate?
Thank you. On behalf of CommScope, I'd like to thank the FCC for inviting us to participate in the panel along with the rest of these industry leaders. CommScope is a global leader in wireless DAS and small cell deployments. We've sold more than $1 billion in coverage and capacity solutions over the last 5 years. And the acquisition of the Broadband Network Solutions group of TE Connectivity and Airvana have positioned us to continue to be that global leader. We have in excess of 400 patents that apply specifically to DAS and small cell indoor and outdoor coverage solutions. We are built on innovation and focused on developing solutions to meet the world's connectivity demands. As a global leader, we are in some of the world's most notable venues solving their connectivity challenges. We're in 24 of the 31 NFL stadiums, 96 other major sports venues, baseball and basketball arenas, 30 major airports, and 9 transit railway metro station lines. We hold the largest footprint of DAS solutions in North America, more than all other DAS manufacturers combined, and this number increases substantially as we extend our reach as a global leader. As you've heard from a lot of the panelists today, it's no surprise that the way people have used wireless has changed dramatically over the last 5 years. Legacy networks were suitably covered by what you've heard referred to as macro towers, where coverage was the primary objective. In those cases, you could have one macro tower serve miles of coverage or users. And over the last 10 years, there's been an explosion in the capabilities of the devices. The number of devices has grown exponentially, and everyone expects wireless coverage to be ubiquitous amongst all of their connected devices. They want reliable connections, and they want fast data speeds. In coverage-limited networks, the economics favored building a small number of macro sites, and that's what you see kind of here on the left-hand side of the slide. We're moving towards capacity-limited networks where technology requires a much larger number of lower-cost cell sites or small cells that you've heard discussed today. I saw a stat, I think a couple months ago, that today's users carry an average of 2.8 wireless connected devices on them each day, and that is what's causing us to shift from a coverage solution to capacity-based solutions, which significantly increases the amount of infrastructure required to support those devices. You've also heard that much of the communication that happens on the wireless networks is happening indoors. That's been a common theme amongst a bunch of the presentations that you've heard today. And that's because a significant majority of that wireless network is where the coverage suffers the most. You've heard some of the other panelists refer to wireless connectivity becoming a utility. And as such, it's replacing landlines and is becoming critical to business functions well beyond email that it was, 2 or 3 years ago. Many companies rely on one, if not more, corporate apps for increased productivity. So from a corporate perspective, wireless coverage is becoming a necessity. And the well-known explosion of social media is also, from a personal perspective, putting an increased demand on capacity. There's about 30 billion square meters of indoor enterprise space, yet only 2% of it is covered from the inside. And so we have to ask ourselves why. Until now, the expectation has been that the wireless service providers will be responsible for providing that coverage. In reality, that's never really been the case. As you've heard mentioned before, when you build a new building, you don't expect the water company to install all your plumbing. You don't expect the electric company to come in and install all your electric lines. Service providers are typically responsible for providing coverage outdoor, and they just happen to strategically place their macro sites to provide, some penetration to the indoor space. But much like payphones of the past, service providers would be responsible for providing access to their network, and you just happen to get lucky if that payphone was near your office or near your transit stop. And as the infrastructure for more cell sites increases, the industry is shifting away from that traditional model where the carriers are funding enterprise solutions and moving more towards a model where the enterprise users are expected to bear the cost. And it might, this model might seem new or unfair, but it's actually been the same model that the utility companies that we've talked about have been following for years. Carrier ROI models are getting tougher to meet, leaving the enterprise and end users responsible for the cost of connectivity. The industry is shifting to a utility model where solution providers are pressed to drive down the total cost of ownership for some of these solutions, and that's where CommScope and other OEMs come into play. We're being tasked with enabling the efficient use of carrier spectrum and other resources, so from an infrastructure perspective, cabling, fiber, copper, coax. We're being tasked with simplifying what it takes to design and deploy some of these solutions and reduce the deployment times to save costs. One thing that CommScope is doing is making our solutions much more familiar to those experienced with Wi-Fi, where you can reduce and eliminate, in some cases, the requirement for dedicated, skilled, knowledgeable resources. As you've heard earlier today, there's many challenges, and each challenge has a unique solution. Each solution depends on many factors, which you've heard: coverage, user counts, capacity demands, and a combination of which wireless service providers need to be supported. The solution for a high-capacity stadium is very different than that of a transit system, and the same goes for a college or corporate campus versus an office or residential high-rise. The DAS and small cell industry has evolved significantly, and CommScope has demonstrated its commitment to the industry through innovation, has demonstrated its strength in intellectual property through many industry firsts. Our solutions bring simplicity, flexibility, scalability to all the customers while ultimately driving down the total cost of ownership. CommScope has a broad product portfolio built to solve almost every challenge: large, small, indoor, outdoor, single or multi-service provider. Unlike distribution of unlicensed spectrums for Wi-Fi, there's not a one-size-fits-all solution to wireless connectivity challenges. CommScope has several different product lines within all types of power classes. High-powered amplifiers there on the left are typically more economical in outdoor or high-rise applications. You have mid-power products that are better suited for high-capacity venues like stadiums and airports. And then you have the lower power options there on the right-hand side of the slide that are becoming increasingly more popular and include our small cell offering to allow for more localized coverage and capacity and increased reuse of the licensed spectral resources. Those smaller cells introduced at the beginning of the presentation are a class of ideal products for office and residential enterprise end user environments where capacity and interference are large factors to overcome. CommScope solutions include many patented applications, including digital transport, which provides unsurpassed signal quality, system flexibility, and unrestricted capacity for service provider resources. It also provides cost savings from an operational and CapEx perspective. It allows the most efficient use of fiber and copper infrastructure resources. For example, some of our digital solutions are capable of multiplexing up to 40 strands of fiber down to a single strand. This opens the door for opportunity of expanded placement options for carrier radio resources. Our intelligent unified platform supports both high power and low power solutions in a single architecture. This solution is backed by 11 patented features and capabilities built directly into the product hardware, and is one of the most advanced and versatile solutions on the market today. The solution is ideal for single and multi-operator systems for large and small applications designed with growth and expansion in mind. The system supports optimal power output, automated head-end design, installation wizards to ease deployment, built-in test tools to eliminate the need for test equipment being brought to the site, and internal PIM testing that's built into the system and automatically tested to ensure high-quality performance once the system is in place. CommScope's always improving on the simplicity of our solutions. Our latest products reduce the need for specialized resources and tools by automating many of the standard system processes, which reduce mistakes and ultimately save time to deployment by up to 50%. Our enterprise solutions are even more versatile. It's more than just DAS. We are leveraging standard IT infrastructure for both wired and wireless networks to distribute licensed and unlicensed spectrum by providing a dedicated, transparent, IP-based 1 gigabyte pipe. The solutions are enterprise friendly, plug-and-play compatible, and key to this platform is the frequency agnostic support for anything between 380 megahertz and 2700 megahertz. It has software configurable frequencies that support any signal anywhere through digital simulcasted zones and automatic signal decoding and detection. This solution brings simplicity and flexibility for enterprise users and supports a wide range of technologies today and into the future, including public safety, LTE advanced, and many others to come. All of this intelligence was built into a platform that we wanted to be plug-and-play compatible that allows for a fast and non-disruptive installation compared with that of past systems based on coaxial cable installation. These solutions also support intelligent alarming, which gives visibility out to every single radiating antenna point for each individual frequency, providing complete system visibility. And finally, our industry award-winning CRAN small cell solution was recently announced at Mobile World Congress and is voted the best mobile technology breakthrough and one of the best outstanding overall mobile technology. It's the only small cell solution to implement what we have trademarked as smart reuse for cell virtualization. We're able to deliver up to 3 times the capacity of traditional small cells and provide unsurpassed signal quality. Our cell virtualization allows the platform to support multiple radio heads as a single super cell, and that reduces interference and adds to the capacity of carrier resources. It allows for a simple deployment. It offers 10 times the speeds for traditional data rates, and what we've done is we've actually moved all of the intelligence from being out at the radio to be back at the controller level, so we can have visibility to where the traffic is and which frequency packets it's using, and provide that additional capacity on the existing carrier resources without them having to implement additional radios. From another perspective, RF planning is greatly simplified because there's no need to worry about creating interference between those small cell radios. In fact, they do not interfere. They actually reinforce each other's signals. And that relates to a better user experience, better economics, and is the only small cell that is carrier independent, allow better use or an application for enterprise customers, allowing for lower cost deployments and carrier flexibility. As you can see from our broad product portfolio, CommScope is about more than just DAS. We're a total coverage and capacity solution provider. And as you've heard from many of the other panelists this morning, there's no one-size-fits-all solution. You should choose the right tool for the job, knowing that each job might require a different tool to be successful. And with that, I'd like to hand it back over to the moderators.
All right. Thank you, Nate. That concludes our presentations from this panel, and I would like to thank all of the panelists for their excellent presentations.
We've had a lot of information today, and we are running a little bit behind schedule. There's also been a slight change in the agenda for the afternoon. Our speaker, who was supposed to be coming to speak at 1 o'clock, was having some travel difficulties and won't be here till later in the day, so she will be speaking after the last session. However, Commissioner Clyburn will still be coming down and speaking at 1:20. So if you guys could take your lunch break and come back at 1:15. We do have a cafeteria here in the commission. You do have to be escorted by FCC staff, so myself and Irene and some of the guys up here that have been moderators will be in the back of the room there. If you want to just grab some food here in the building, you can do that. You can bring it back and eat it here in the room if you need to, because it's only a half an hour. There is also, if you go outside, there are food trucks right across the street normally, and if you turn left out of the building and walk up towards the corner, just before you hit the corner, there's a little deli. If you turn the corner, there's a Potbelly's if you go about halfway up that block. But please try to be back here by 1:15, and we'll restart with some remarks from Commissioner Clyburn.
dan dan dan, spandi bandi dan dan dun dan, spandi dan 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 dan, la da da dun dan dan dan, dun dun da de, le de da, ba du da de, ba le du da di da da dun do ba di di do 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 be di li do do da da bre do 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 be di 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 ba ba be bu di do da da ba ba di 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 pretty da be di 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 da da di 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 scare be do 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 da do do da di di ba be di di don't mean a thing if it ain't got the reggae swing. Shoobop, 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 shoobop. It don't mean a thing if it ain't got the reggae swing. Shoobop, 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 shoobop. Makes no difference whether it's sweet or hot. You gotta give that reggae rhythm everything you got. So it don't mean a thing if it ain't got the reggae swing. Shoobop, 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 shoobop. It don't mean a thing if it ain't got that reggae swing. Yeah. Shoobop, 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 shoobop. It don't mean a thing if it ain't got that reggae swing. Yeah. Shoobop, 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 shoobop. Makes no difference if it's sweet or hot, yo. You gotta give that reggae rhythm everything you got. So it don't mean a thing if it ain't got that reggae swing. Shoobop, 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 shoobop. That crazy sound, gotta have that rhythm, fascinating rhythm. The rhythm of the day, y'all, fascinating rhythm. Makes no difference whether it's sweet or hot. No, you gotta give that reggae beat everything you got. So it don't mean a thing if it ain't got the reggae swing. Shoobop, 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 shoobop. It don't mean a thing if it ain't got the reggae swing. Shoobop, 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 shoobop. It don't mean a thing if it ain't got the reggae swing. Shoobop, 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 shoobop. Makes no difference whether it's sweet or hot. You gotta give that reggae beat everything you got. So it don't mean a thing if it ain't got the reggae swing. Shoobop, 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 shoob, shooba dooba dooba dooba. Shoobop, webam. Splash, webam, down the day. Say, bump, bump, grip, bump, bass, reubam, we are bound. Say, bump, bump, webam. Splash, slam, 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 bam. Get it, boop, flim, bop, dooba dooba dooba, flam. Makes no difference whether it's sweet or hot, yo. You gotta give that reggae beat everything you got. So it don't mean a thing if it ain't got the reggae swing. Shoobop, 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 dooba. It don't mean a thing if it ain't got that reggae swing. Shoobop, 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 shoob, shooba dooba doob dooba. It don't mean a thing if it ain't got the reggae swing.
Everyone could please take their seat. We're running a few minutes late, so we'll try to get started again. As I said earlier, in case anybody's just tuning in, our lunchtime speaker was having some travel difficulties today, so she will be speaking at the end of the day after the last session. So we're going to now we're going to start off the afternoon. Before we start with our next session, we're going to start off the afternoon with some brief remarks from one of my favorite commissioners, Commissioner Clyburn.
Good afternoon. It's one of her favorite commissioners. She says that at least 4 other times during the course of But that's all right. We'll forgive you for that. Good afternoon, everyone. Oh, wait a minute. You had lunch. I didn't. So if anybody should be grumpy, it's me. Good afternoon, everyone. Fabulous. Spectrum. You know, I'm kind of, well, anyway, you know what I'm doing. Sometimes it seems as if this is all we ever talk about. How we need more of it. How we can never have enough of it. How precious and prized it is. How we must channel our inner kindergartner and learn how to share it. But I must confess that it's truly wonderful to see so many of you from across this country coming together today to discuss this very important issue. So yes, it is true. We do need more spectrum to keep up with the consumers' increasing reliance on mobile broadband services. According to the latest research that you know all too well, mobile data traffic has grown 4,000-fold over the last 10 years and almost 400 million-fold over the past 15 years. And all of you here this afternoon, you are here because you are aware of this key fact, that spectrum, while extremely important, is only a part of the equation. In order to deploy that spectrum, we need to build and site antenna towers, base stations, and other infrastructure, and we need to do so expeditiously. Distributed antenna systems and small cell deployments are comparatively cost-effective ways of addressing the ever-increasing demand for wireless broadband services, and wireless providers are rapidly increasing their use of DAS and small cell technologies to keep pace with that demand. The Commission weighed in notably, I believe, in October of 2014 when it put in place some very important measures to streamline the siting of small cells. And just last week, the agency launched a proceeding to seek comment on how to ensure that the critical wireline backhaul is available to support DAS and small cell deployment, including ways to have a regulatory backstop when competition is not sufficient to ensure that rates are just and reasonable. So I am excited, as you can tell, about this workshop, because you're examining how the use of DAS and small cells are positively impacting so many facets of our everyday lives. From hospitals to subway systems to college campuses and beyond, these technologies are enabling us to multiply wireless capacity within existing spectrum resources, all to the benefit of consumers. But in order to take advantage of these opportunities, everyone needs to be able to access broadband. And we know for far too many, the price of this access is out of reach. I have toured parts of this country, and you've been there too, where we've met lifeline consumers who are actually trolling for Wi-Fi. Now, just what is the definition of a Wi-Fi troll? It is a person or persons who hide in libraries overnight to finish their homework. They camp out in fast food restaurants and coffee shops just to get a signal. They hang out in hotel lobbies pretending to be guests in order to get that passcode. Or they sit on stoops in neighborhoods until the police are called and they get hauled away. That happens. That happens for too many. People are making tremendous sacrifices beyond most of our comprehensions simply to do their homework, simply to look for a job, simply to be connected. And we should never, ever lose sight of the need to ensure that not only that every single person has access, but that that access is affordable. This is why I am so supportive and passionate about the FCC's Lifeline program and similar public-private partnerships, because they are the key to ensuring that broadband and mobile broadband are truly the greatest equalizers of our time. I recently announced the launch of my Connecting Communities tour, where I seek to understand from the ground up just what is happening outside of the Beltway, and how the FCC can be a conduit for change where that change needs to occur. This is a listening tour, which seeks to hear a wide range of perspectives, including those many voices that too often go ignored. Last month, we attended the California Telehealth Network Summit, which seeks to bridge the technology gap when it comes to delivering key medical services. And soon we will be coming to a neighborhood near you to visit other healthcare facilities. We will continue to meet with tech startups and venture capitalists like the ones I saw in Chattanooga, Tennessee. And we will head over and speak with community organizations, schools and universities, from Yale up in New Haven to Jackson State University down in Jackson, Mississippi. And as I travel this country during this tour, I will explore ideas on how we collectively can use the tremendous benefits of DAS or DAS and small cell deployment to address the needs in urban areas with large low-income populations or concentrations, but there are areas that have too few options when it comes to advanced services. So I welcome your thoughts on how we can help drive down costs and make services more robust in these areas that critical services can be used the most to the most benefit of those in need. So my eyes and ears are wide open. And my mind is engaged and is racing. So please do not hesitate to contact with me with your ideas because, again, my mind is open and racing on how we can all seriously leverage our talents and resources because the capacity is in this room and beyond. So we could better connect communities and promote that one thing that I think is most essential, and that is universal opportunities for all Americans. Thank you very much and continue to enjoy your workshop.
Thank you, Commissioner. So now we're going to start the next panel. We've got two moderators for this panel. Is Mike Lynch here? Okay. So Mike Lynch is the president-elect at NEPA, and Chad Breckenridge is an associate chief of the Wireless Bureau here at the FCC. Is Robert Erickson here? Okay. We also have two panelists who are going to be joining us via teleconference as well. And again, I'd like to remind people, if you are in the room, just raise your hand or get a note card from the back if you'd like to ask a question of any of the panelists, and we'll collect the note cards from you. If you are watching this online, please send an email to livequestions@fcc.gov. Thank you.
Hey, thank you, Cecilia. And we will jump right in. I should say right at the outset that this is the setup I like, where the moderators in the room outnumber the panelists. So we got our eyes on you over there, Robert. Be careful.
I feel the lasers.
Right, exactly. But we do have two on the phone. Let me make sure you two are on the line. First, we have Miguel Gamino, who's for the city CIO and executive director of the Department of Technology in San Francisco. He's also a member of the FCC's Intergovernmental Advisory Committee. Miguel, are you on the line?
Yeah, I'm here.
Terrific. When we get to your presentation, just a little housekeeping, let us know when you want us to advance the slides, and we'll do that. And then we also have on the line, we have Omar Masri, who's a city planner for San Francisco. Omar, are you on the line?
Yes.
Terrific. Same for you with the presentation, if you would. And then here, bravely in person, we have Robert Erickson, who's the Vice President for Network Engineering and Implementation at Extenet. So welcome. And why don't we actually start, we'll stick with the order that we've got on our agenda here. And Miguel, why don't we start with you, if that's all right? So give us a minute to pop your presentation on. I'm sorry, I don't know if, Mike, if you got anything to say to begin here.
I think you're doing a great job.
Okay, terrific. Thanks. Miguel, we'll hand it over to you. Your presentation is up.
Great, thank you. So what I wanted to do today was kind of talk about San Francisco in general and how we're approaching connectivity as it relates to, I really believe it's a multimodal situation.
which echoes truthfully what Commissioner Clyburn was just talking about to some degree with regard to how Wi-Fi and small cell LTE kind of all fit into what's important to create a connected fabric for the community. So go to the next slide. First slide. So just to give people kind of context, San Francisco is a city and county, $9 billion budget, roughly 30,000 or so employees, and serving about 1.5 million daytime citizens and commuting workforce and visitors. Our centralized Department of Technology.
You're behind. Next slide. Could you advance the slides?
Well, hopefully you're on slide 2. So the Central Department of Technology is about $100 million and somewhere between 200 and 300 employees, depending on vacancy rates and whatnot. And so we serve the city and county's technology needs in terms of strategy and delivering operational services to city and county departments, and also to the public. And it's interesting that the public-facing service that is new, kind of a new era for a central Department of Technology, is in fact connectivity services, in our case in the form of public Wi-Fi, and beginning to engage with the private sector partners on LTE and those sorts of things. So go to the next slide, please.
On the when you can see the slides on the presentation on the web. So we've got it advanced here. You can go ahead.
So go to, I think you're on Who Are We slide. You can go to the next one. That should be connectivity phases.
Hey, Miguel, there's a 10-second delay on the web view of the slide, so we've got it advanced, but it'll take a second for you to get on the presentation.
The connectivity phases slide. This has been our approach to connectivity planning, and this is really to illustrate the fact that we've found that it is kind of a multi-layer approach to creating this connected fabric for the community. So we've been focused on planning our own fiber infrastructure and implementation of a Dig Once ordinance. I'm sure many in the room know what these are, but for clarification, we're building our own municipal network for our municipal use to city buildings, but we're building it in a way that sets it up for pragmatic use for future ideas around municipal fiber networks and broadband choices to homes and businesses. And our Dig Once ordinance is pretty straightforward, but I think the way we've implemented it has been really successful because we're focused on, by default, when a street is open, the excavator will put conduits in the way that our department has defined them, and then we can update that configuration definition going forward without having to touch the law or the legislation again. And so it's very responsive approach to a very core infrastructure priority. And then I'm going to talk a little more about edge Wi-Fi, which is the phase 2 of our planning. And then now we're talking a lot now in San Francisco about how to increase broadband choices at homes and businesses. And all of those things are wrapped around this digital inclusion conversation, again, that Commissioner Clyburn touched on, which is these people that are going to places that have free Wi-Fi as their place to connect and complete things, critical functions like homework and things like that. And so we want to make sure we're paying attention to that digital inclusion conversation as we build, the infrastructure and the technology layers of connectivity for San Francisco. Next slide. Our public Wi-Fi service currently serves Market Street and 33 Park. That has been kind of the initial prioritization that lets us, frankly, prove out why this is important to the citizens of San Francisco and responding to the prioritization from our mayor, Ed Lee, and some of the other elected officials that have to be a priority for our community. conversation kept coming up. I refer to it as the field of dreams question. People were asking us, are you building us a Wi-Fi to see if they will come? And maybe there was a little bit of that, and I applaud San Francisco, both the elected leadership and also the community at large, for supporting that idea. And what we've proven through data now, the data collection, these statistics that you're seeing on the screen here are just for the month of January. So in 1 month of January, we had over 9 million sessions. And maybe the most important kind of data points here are that the average duration of connection was almost 11 minutes. And during that month, we handled almost 30 terabytes of throughput. So for those people that are asking, does public connectivity, is there a need? Are we filling an existing need, or are we creating a solution to a problem that might not be there? I think we're finally answering that question with an underscored exclamation point statement, which is yes. Even in a proportionally small percentage of our geography in San Francisco, we're experiencing fantastic consumption numbers. So this proves a couple of things. I think it proves that there is a need for connectivity, and that things like LTE or existing networks by themselves are not satisfying the complete demand. And so I think it's underscoring our position that it's going to be a combination. It's going to be a multimodal approach to solving this connectivity question for people. That there is certainly a strong place for LTE and stronger LTE, but there's also a place for Wi-Fi. There's also going to be a place for fiber present in everybody's home. Next slide. So talking about how that commercial wireless or LTE service plays into the plans for San Francisco, I think, again, we've identified, we've kind of proven the point that wireless and wired access is important to creating a sufficient capacity and service choice, and really impacting that digital divide. So our plan has been focused on expanding the city's SF Wi-Fi service, but we, again, have seen all along that this would be a complementary service to the commercial wireless that's currently in San Francisco, and that we're continuing to figure out ways to support the growth and augmentation through things like DAS and small cell. And Omar's going to get into a lot more of those technical details in a minute. One really kind of salient point is that about a year and a half ago, the Wireless Broadband Alliance held their World Congress, or their Wi-Fi World Congress in San Francisco. And at that time, we had a fairly limited installation of Wi-Fi on Market Street. But to celebrate that wireless congress, we established an offloading agreement with a commercial carrier on Market Street. And we've allowed that to continue to allow us to kind of understand the consumption and the experience. And so we're finding significant data being offloaded onto our wireless network that I think has significantly increased the user experience, at least on Market Street in San Francisco. And then Super Bowl 50, which I know is something that the group wants to talk about or learn from. For us, Super Bowl 50, it was clearly a forcing function. It was something that created a target for us to respond to satisfy the anticipated significantly growing or dense demands for connectivity, particularly on the foot of Market Street at Embarcadero. Those of you that don't know, we closed off several blocks of Market Street for a little over a week, I think about 10 days in total, to be an open to the public, free access Super Bowl City event. And during that event, I think we had about 1 million people throughout that duration on just a handful of blocks on Market Street, with lots of rich media entertainment, broadcast booths, obviously lots of social media, rich media types of activities and interactions by design from these booths that were set up and these participants in that area. So not only was it a high density situation, it was also a very rich media situation. And lots of private partners were building up their LTE networks to satisfy that. but we also had to build up our Wi-Fi service. Again, just acknowledging the fact that one wasn't going to satisfy all the consumer's needs by itself. And so what we experienced there was the opportunity to significantly build density and capacity to our network, and we saw fantastic results and consumption and generally positive user experiences because of that. And our mayor had declared that among several things that this Super Bowl would be the most technologically advanced and the most connected, and I think we accomplished that objective. Next slide. So I've talked a little bit about several of these points already, but generally speaking, there's absolutely a driver to allow small cell deployments where we can accommodate additional capacities, both for visitors in tourist centers, but also for our own population that moves around the city. And as I kind of illustrated earlier, the city has about 850,000 or so citizens, but that population nearly doubles for daytime workforce that moves into the city. So being able to handle that kind of those peaks and valleys is really important when you're designing a network for a city like ours. And so, the other thing that has become a very a bright spot in this conversation is that many households are depending on mobile only. And that might be because of limited resources. It might just be because that's the way the generation is moving. But it doesn't change the fact that we're seeing a significant increase in mobile-only consumption of connectivity over the last couple of years, and fully expect that by every forecast or futurist is predicting that will increase exponentially going forward. And for low-income households, dependency on LTE is even greater, with 29% of households' income of less than $25,000 being mobile only. And this might again come down to if they've got limited choices, they're gonna choose the choice that gives them the most flexibility within their lifestyle and their resource availability. So because of all of this, I think it's very clear that there needs to be a very tight relationship between commercial wireless or LTE coverage through technologies like DAS and small cell to bring that connectivity and those density needs to where people are consuming it, and then also having Wi-Fi access as an alternative in many of these areas, and in some areas being maybe even the primary choice for connection in San Francisco. So, next slide. So we have established agreements with carriers to use key assets. I think, part of our approach is that the role of government is to be very mindful of our rights-of-way and how we leverage them to kind of generate the best outcomes for our citizens. We're the stewards of those rights-of-way, and they can't be replicated, right? You can't just build another Market Street if you get it wrong the first time. And so we're paying close attention to how we leverage those assets and make sure that they're used as and productively as possible. So we own a bunch of street poles through our Public Utilities Commission and also through our transit agency, and are making sure that those assets, those mounting assets, are leveraged as well as possible. Verizon and Extenet have installed about 320 small cells in the Northeast and Soma areas of San Francisco, and I'm sure my co-panelists here from Extenet and Omar will speak to a lot of that detail. And the PUC and MTA have established master license agreements with several other carriers, AT&T, T-Mobile, and Mobility, which is working for Sprint, to begin installing many more small cells soon. So this is just, again, our consistent with our general theme that all of these systems are going to be complementary to creating a truly hyper-connected and mobile supportive community. Next. And so with that, I'm going to turn it over to Omar, who can get into a lot more of the technical details of the DAS deployments and the small cell deployments and what we've been seeing and experiencing from the city's perspective on these fronts.
Thank you. So in San Francisco, our key challenges are making the design and siting works, especially given the large number of small-scale historic buildings and historic districts. For a city planner, design encompasses both form and function, whether it's avoiding noisy cooling fans on poles outside a bedroom window, large equipment areas and generators detracting from an iconic view, or avoiding cable trays running over apartment windows. Now in San Francisco, there are over 750 primarily rooftop-mounted micro or macro sites serving the Tier 1 PCS carriers, and we're approaching up 750 small cells or ODAS on wood and steel poles or other street furniture. Next. However, in places like the downtown, wireless carriers have a challenge with many rooftop sites being too high up on the roof to serve high-speed data at storefront level. And you can't just slap antennas and cable trays in the storefronts of historic buildings. So this means you have to pursue street furniture, such as bus shelters and city-owned light and transit poles. So for background, we had folks propose large integrated light poles, but they appeared so wide that they would impair sidewalks and look out of place. We also had AT&T propose bulky dorm-sized fridges on poles in historic residential areas. Next, please. We also, for example, had a challenge with a new light pole being proposed by Crown Castle with what appeared to be a well-designed small cell, but the actual installation didn't turn out as promised. Next slide. So it seemed like a refreshing, positive path forward. Verizon and Extenet came forward with this much smaller, more appropriate design, though we did reject the offset antenna arm design on the right-hand side of the screen. Next slide. However, one of the challenges we faced as we moved forward was the design didn't include known required elements like more electronic gear, which raised a concern about compatibility, especially in our core historic districts. Next. So we requested a mock-up on a city pole in one of our corporation yards, which was important to flesh out design, but also because we had to work across city agencies, especially because some of these poles hold up heavy electric wires for buses and light rail. So where you drill entry points for cabling entering the pole is important as it relates to the core function of that pole, holding up those electric wires. Next. At the same time, we had to work through designs and licensing on city-owned light poles. We also had challenges with bulky and noisy cabinets a few feet away from bedroom windows in those areas where we only have utility-owned wooden poles. However, I would note, for example, if you look at the right, the Extenet design was much smaller and noiseless compared to, say, the Crown proposal on the left-hand side of the screen. Next. So after mock-ups and redesigns, we came to a proposal that gained support from the Historic Preservation Commission, a number of neighborhood groups, and elected officials. One idea we worked on was placing road and traffic signage in front of the computers, the two boxes midway down the pole. This required buy-in of Public Works and had to occur all while we're sort of rushing toward getting these sites and approvals up before the Super Bowl, especially for areas near Super Bowl City. We also engaged in extensive outreach with neighborhood groups and worked to provide substantial information to the public. An example of our outreach can be found, as well as the lease agreement, can be found at www.sf-planning.org/wireless. And at this point, we're currently working with Verizon at looking at replacing some of the concrete poles with ones designed of concrete, but with attachment points for similar size small cells. T-Mobile has a similar design they're moving forward, working with Extenet for fiber for backhaul. AT&T has indicated they're willing to emulate the design, and we're still going through initial discussions with Mobility over their design and multiple redesigns in that respect. So that concludes for myself. Thank you.
Thanks very much to both of you, Miguel and Omar. I'm going to turn it now over to Robert to go ahead for the Extenet presentation.
All right, thank you.
So they throw up the slides. Apologize, we're waiting for the slides to pop up. There we go. So I obviously worked closely with Omar through this entire deployment. So I'm going to kind of go quickly through slides, and I don't do well with PowerPoint presentations anyways. You know, I like the dialogue a little bit better. And so Omar's already covered a lot of what I was going to cover, but I wanted to kind of speak from the deployment perspective and, you know, the challenges that we faced on our side and kind of the successes that we had leading up to the Super Bowl.
And so a lot of my slides are going to be more surrounding how did we get this deployed. And as Commissioner Cleburne alluded to earlier, we tried to approach this with utilizing existing infrastructure to both bring the cost down on the deployment, but also to speed up the time to market, right, and try and make it in time to support the Super Bowl. So in order to do that, we had to kind of leverage what was existing in the city of San Francisco. So I'll start through the slides here. And again, these are just some interesting stats about the city of San Francisco, which, again, I think Miguel kind of covered in better detail than this slide does anyways. So I think I'll skip to the next one. I apologize. So as Omar had already kind of spoken to, we deployed this small cell network really on 4 different pole types. This was the PUC's light infrastructure, MTA poles, or the Metro Transit Authority's poles. We had in the state of California, we have what they call the Joint Pole Association. I know other states have started to kind of do some of this joint pole stuff, but these are really your traditional wooden poles in the public right-of-way, your kind of traditional utility poles. And then we also had another pole type, which was really the exact same steel pole that the PUC owned. Almost physically, they're the exact same thing, but it was actually owned by PG&E or the local utility company. So we were dealing with really 4 different entities to get all of these, all pole types covered in this deployment, which of course required working out agreements with these entities. So we had to have a separate agreement with MTA, a separate agreement with PUC, a separate agreement with JPA, and a separate agreement with PG&E to be able to access all these different pole types. We actually initiated this project, or kind of was conceptualized all the way back in 2013, and we really got the network deployed to the point where it would support the Super Bowl in January of this year. So it took that much time really to just get all of those permissions, if you will, in place to be able to deploy it. Because, again, you not only have the poles that we had to get the access to, but all of this RF infrastructure, of course, goes back onto a fiber network and gets called back. So that fiber network had to be in place as well. So I'll speak to a little bit about how we did that in future slides. This slide is really just to kind of give you a real kind of bird's eye view of exactly what we did deploy in San Francisco. There was really 2 deployments. There was what we called our NOMA, or North of Market deployment, which was a traditional kind of full turnkey deployment where Extenet owns and operates the network and just leases the space to the carriers. We did approximately 300 sites, or we're in the midst of completing 300 sites in North of Market. In the South of Market, our carrier decided that they would like to do the pole attachment piece, or the RF deployment piece of the deployment, and we just supplied the fiber in South of Market. So in South of Market, we, as you can see on the screen, we did 143 individual circuits, which equated to about 40.6 miles of fiber. And in North of Market, that was 300 different antenna locations, and that equated to about 65 miles of fiber. So I'll go to the next slide here. Maybe? I don't know. There we go. Well, we'll jump to this one. So my slides are a little bit out of order, but we'll catch up as we go. I think that was the. Apologize. Give us 1 second here.
Let me try another one. We have an
All right. No problem. Yeah, that's good. I could start from there. So if you think about a traditional, especially outdoor DAS deployment, you're going to start with a design phase where you're going through and doing not only the RF design, but you're doing a fiber design. And once you kind of get the basics of that, or what we refer to as a design lock, so your customer's happy with what you're going to deploy. Then we move into a permitting phase, or what we refer to at Extenet as our external relations. That then, depending on the jurisdiction, can either be a fairly quick thing or a fairly lengthy thing, especially in a city like San Francisco, where we have very opinionated citizens. There's a lot to consider. So the permitting process in San Francisco is a rather lengthy one. And I don't think that and I don't want to sit here, and especially with Miguel and Omar on the phone, right? I certainly do not want to beat up the city of San Francisco. They work very, very hard at trying to comply with or cater to the constituency, but at the same time be realistic with the carriers. And I think guys like Omar were very helpful in coming up with the design that we came up with by really pushing us to think outside the envelope a little bit more. Oftentimes Omar would come to me with, "Hey, these guys don't want to see this on this pole. This particular group in Nob Hill does not want to see this. How do we integrate it into the existing design?" And initially, probably our first thought was there isn't a way. We've already, the profile of this is already too small. We don't have any more room to put this. And after a lot of back and forth with OEMs and with even Omar and the city, we finally were able to come up with ways that the deployment was both aesthetically pleasing, people could accept it, but was functional for us. We could actually integrate all of the RF components and everything else that we needed to. And I think we came up with, by working with the city like that, not fighting the city like that, we were able to come up with a design that, quite frankly, as you roam around San Francisco today, it's very hard to even know that those facilities exist. I myself have gone to meet people at a particular node location and had trouble finding it, just because it does blend into the landscape so well. So I think we were successful in doing that. I think the only thing that we could have done better, both us and probably the city, is that process takes a lot of time. To put it into perspective, it took us anywhere between, say, 10 months to 18 months just to get the permissions in place to be able to do this deployment. It literally only takes 2 days physically to build that site. That's not including the fiber plant. The fiber plant's a whole other discussion we'll get into a little bit later. But physically building the pole itself, putting the radios up, throwing the antenna up, that only takes 2 days and 18 months to get permission to do it. So, we probably should learn from that and try to expedite the process in the future. And I think one thing we tried to do to help with that, as Omar alluded to earlier, is we tried to come up with just some standard templates that the city, when they know they see this one design, they don't have to kind of re-vet it out. They already know, okay, we've already gone through this. And these poles are the same, right? They all look the same. They have roughly the same kind of infrastructure on them currently today. Literally the only difference between an MTA pole and a PUC pole oftentimes will just simply be a support cable that goes over to the MTA pole. Other than that, they're the exact same physical pole. So by building these templates and allowing guys like Omar to come down and see a mock-up, touch it, feel it. I even remember Omar getting up in a bucket truck and going all the way up to the antenna and, checking it out from the bucket truck. We were able to come up with kind of a standard design. Now, I think when you deviate from that standard design, you then enter back into that 18-month-long process. But if you can stick within that, things move fairly quickly. Everybody's familiar with it. It wasn't just the planning department, of course, and DPW that we had to deal with in this case. We also had to deal with other city agencies because they're the pole owners. So we had to deal with the MTA and the PUC, and oftentimes we would have to bring all of these entities together: the city, MTA, or the planning department, DPW, the PUC and the MTA and Extenet all together in the same room to be able to go, okay, these are entities, these are city entities that aren't really used to working with each other at that level in the past. So this is all kind of new to them. And by having that kind of what I call the whole city relationship, I think is the only way that we were able to do that, to come together on the design of this network and have it work for both ends. So this is, and I won't spend a lot of time going into this, but this is just kind of the lower graphic, kind of takes you through the permitting process as it kind of currently stands, and how long it kind of gets, or how long it takes to get to integration. And on average, this is getting better, I must say, because again, we had to do a lot of mock-ups and things on the front end, but right now it takes roughly 15 months to get through that process. And again, 2 days to build the site. So I think that's the one area in San Francisco, and especially across all of the jurisdictions that I deal with, that I think all of us could do better at, is getting through the approval process to actually get these things deployed. This is just a quick slide on a lot of what's already been covered, but there's a picture of the guys actually building one of the nodes there. Again, we did 116 dark fiber locations, 300 turnkey locations. And I'll elaborate on this a little bit more in a few minutes, but this was a really unique deployment, not just through the work that we did with the city, but through how we leveraged other existing utility infrastructure, and mainly being the power conduit infrastructure and power, the actual power infrastructure. So this is probably the most unique aspect of this deployment, and really what allowed us to deploy as quickly as we did. And as Omar stated one time in an article, he said, without this type of access, this dog don't hunt, which basically was referring to you're never going to be able to, even I think with the most ambitious plans, I don't think you're going to be able to go into the city of San Francisco and open trench or dig up 100 miles of their streets. I mean, that would basically mean you're going to go in and dig up every single street in San Francisco. And that's just, obviously not going to happen. So the only way we could get the fiber deployed in a realistic time frame and realistic costs was to try to leverage the existing infrastructure. And that existing infrastructure really comes in a number of ways in a lot of cities. It's either power conduit infrastructure, which typically was not available to telecommunications type of infrastructure, or telecommunications type of companies. Then you have, your typical cable and telecommunications conduit that might be out there, but that's fairly limited, and it certainly doesn't go over to a pole. It might kind of satisfy your backbone needs, but doesn't satisfy your lateral needs. So we saw that utility infrastructure, that power utility infrastructure, as the the solution to being able to deploy all of this fiber. That if you can imagine, the utility infrastructure goes everywhere. If you think about that, that's everywhere where power goes, that conduit infrastructure goes. So really what it was a matter of was getting the permission to be able to pull fiber in that infrastructure, which fiber is non-conductive, right? It shouldn't affect that power infrastructure much. However, there's this old mentality in utility companies that says, well, power and telecommunications have to be separate. They can't be in the same conduit. But that was because you were putting copper, wire inside of a power conduit. So we were able to finally convince, the NEC, we were able to convince PG&E that it was okay and safe to put this fiber inside of that existing conduit infrastructure. And so it literally took probably 2 years to get that agreement in place to be able to access that infrastructure. But now we can, and we can access that infrastructure kind of carte blanche. So in the case of San Francisco, we pull our fiber in a PG&E conduit, an existing conduit. So I didn't have to tear up any street in San Francisco. I didn't have to, in most cases, I don't even have to go down and bother DPW for a permit. I can access it via the permissions PG&E already has in place. So I was able to, or we were able to get the majority of our backbone build, which was 80 some odd miles of fiber, built in less than 10 months, which in most cases you wouldn't even be able to get the permits in 10 months to be able to do that. So it greatly increased the speed to market. And then if you look at the costs to deploy in a traditional manner or in an open trench, which is the only thing that San Francisco allows. They don't allow for boring. They don't allow for micro trench. If you're going to build fiber infrastructure in San Francisco, it has to be through open trench. That's around $400 a foot plus restoration of the road. So it's extremely expensive in San Francisco. To pull in and to include the lease, the recurring lease that we're paying in the PG&E infrastructure, it's about $90 a foot. So way faster, way cheaper to go in that existing infrastructure. So that sounds like a good news story. I think it is in San Francisco. The only problem with that is now, as we try to take that model to another city, there's that same opposition to it. There's kind of this old mentality that we can't play together, that the power and telecommunications can't play together in the sandbox when we can. And so now the challenge is trying to get other jurisdictions and other utilities to open up to this idea, because it was it really was what allowed us to be successful in San Francisco. So the other thing that was really unique about this, and I probably better speed up because it looks like I'm running out of time, but the other thing that was really unique about this deployment was that we got power for the radios from two very unique sources. We either got it directly from the PUC and literally tapped into their existing power infrastructure that supports their lights. Or in the case of a PG&E site, or where we couldn't get power from the PUC, we worked with, and this is an area where Omar pushed me to go work with, the PG&E to come up with a small metering solution. PG&E will not allow you to get power on these poles without a meter. They won't allow a meterless installation. So the existing meters that they have right now is a very large meter pan, a big glass globe. I'm sure everyone in the room is familiar with these meters. You have them on your homes. That obviously was not going to work aesthetically with the city. So we had to come up with a solution that would fit up inside of that shroud up where the antenna is at. There's this new technology that allows for wireless meter, but also allows for the utility with those wireless meters to create an RF mesh network. So it's this is all new, but it benefits the utility and the end user greatly. And we were able to get that meter up inside of the shroud and allow for the electrical service really transparently. You can't tell whether a site is being serviced by a PG&E meter or by a YTAP. Anyways, that was just a new technology that we were able to integrate into these sites. This is just a diagram of exactly how it's wired inside of the pole. And there's other slides, but I don't know if I'm out of time.
Well, maybe the opportunity to ask a couple of questions. Mike, I don't know if you've got any that you want to
Just a quick question, if you don't mind, Jeff. Thanks. You mentioned PG&E, and I'm dying to ask how you convinced them or how you incentivized them.
Yeah, no, that is a great question. And luckily they had attempted this once before with another company. So we were not really the pioneers of this. They had kind of gone through something similar, maybe not the exact same agreement, but had gone through some of that work. I think the way that we really got their attention, though, is that we went to the NEC first and got their backing so that the NEC could come to PG&E and say, hey, this is okay. And it really took not just convincing the business development people who want to do this deal. That was probably easy. But really, where you get to where you see the slowdown, you see the opposition to this, it tends to be in the operations departments of these utilities. The operations guys come out and go, no, you're not sticking another wire inside of my conduit. And no, I don't want that in my way when I'm out there working on a site. And we really had to go to those guys and lobby with those guys and say, hey, this is safe. This is good. It's good for you. It's good for your longevity. It's good for your unions. So
I'm assuming they got the work, so to speak.
Yes. Well, in fact, it's already a requirement. This wasn't something that we had to guarantee the unions a certain amount of work. It was already guaranteed. Nobody works inside of those manholes if it isn't a QEW or a QEP. So, quite frankly, they've probably benefited more than anybody from this. They've seen, we've put a lot of people to work in San Francisco just through this initiative.
Very good. Thanks.
So I've got a question for all three of you, I guess. I wonder if the regulatory environment changed over the course of the 3 or 4 years that you were rolling this out. I know from our FCC perspective it did, but probably towards the end of the run where you were doing things. And I don't know if when the FCC implemented rules implementing Section 6409, which was designed to speed up local deployments, if that had any kind of effect on your work.
I'll say it I'll turn it over to Omar too, because I know he probably wants to comment on this, but I don't know that it really did during the deployment. I think though now it does. Now it does start to affect us. There was already kind of a plan in motion, if you will, and that just kind of that played itself out, and now is kind of the next round, and now is when I think those changes are certainly a topic of debate and help and challenge us at the same time. But I don't know, Omar, did you want to comment on that?
Yeah, on 6409, one of the interesting exclusions is that it doesn't affect the city as a property owner if the cell site's on city property. So one of the things that actually made us more comfortable with deployment on steel city-owned poles is the fact that we own them. So when neighbors raise questions about, how they look 5 years from now, we could say, well, we have a master license agreement, we can act as property owner, so 6409 doesn't apply. Now, the way the FCC wrote the rules for 6409, when it comes to, say, wooden poles owned by PG&E, when a carrier's putting up what looks like a small cell, we, in some respects, because of 6409, don't know what we're ultimately approving, because the carrier could come back and add 10 feet of height to it, 6-foot horizontal arms, large, bulky, noisy cabinets right outside the bedroom window. And so 6409
becomes a real challenge in the sense that we don't know what we're actually approving if it's going to reflect what will be there in 5 years, especially when it comes to unscreened by nature of their location sites in the right-of-way. On the issue of like shot blocks and accelerating deployment, we had an instance where the wooden poles we proposed at XNet came in with the designs that were 12 to 20 feet taller, and we kept saying, we have a concern with this, we don't think it's appropriate, it looks out of place in Russian Hill or Telegraph Hill with iconic views. And so when they brought up shot blocks, at that point we started turning around and denying the sites because the shot blocks demand not an approval but a decision. And we felt that the designs would truly significantly detract from iconic and historic views. And after we turned around the first 14 decisions, XNA came back with a more viable design that we were able to immediately start approving. And then at that point we also learned that there was a slimmer meter available. So instead of a meter cabinet twice as wide as a pole, we get one as wide as a pole. And that's a lot better on, intimate residential streets because you're not having a large surface to attract graffiti and just looking out of place. So we had XNet go ahead and redesign the poles as well for that design improvement as well.
Thank you. I've got one more. We've got one more question that came in from the folks here, and then we'll wrap up after this one. I think this one is really focused to you, Omar and Miguel. And here it is. For other cities that have a major event or major deployment or major development, did this opportunity provide long-term benefits for the community, like economic development, service for the underserved, low-income residents, that kind of thing?
Yeah, this is Miguel. I mean, that was actually a very core focus for us with everything we did. We took, at least especially on the Wi-Fi front, we were really taking advantage of the event to offer a test bed for high-density designs. I was, pretty clear, and I said, I can't invite 1 million of my friends to come and test my network any other way, especially not for a week-long duration. And so it was a very unique opportunity to not just respond to the needs of the event, but actually primarily driven by using the event to test a long-term high-density solution, which is what we accomplished. And so all along, the goals were very clearly to build a network that would be permanent and of a permanent benefit to the public. I think the same is the case on LTE side from the private carriers. Is all of that stuff that got built up was in response to the event and their side, but it's still installed and active, and so the citizens that still come down to Market Street every day, or the visitors that come, or that comes into San Francisco, they are experiencing that improved network all day, every day going forward. And we've also learned a lot from that that's going to help us build a better network in other parts of the city based on what we learned from that high-density situation.
And I would add, on an individual scale, obviously this network's proprietary, it's only serving Verizon customers. XNet's fiber deployment will obviously serve T-Mobile and possibly other carriers, and it assists with connectivity for those network customers. On the larger scale, this did open up the conversation where now we see these other sort of smaller entrants, IoT carriers and others, saying, hey, can we work with the city on something that's a little more experimental or new, including a search engine which will remain unnamed, looking at using new spectrum deployments and wondering, can they work with the city in the right-of-way, and looking at examples and coming up to me saying, hey, Omar, I studied that flyer you created for the XNet Verizon deployment. We learned a lot of lessons, and we're actually designing our equipment based off some of the things we saw. So it's definitely opening up a larger conversation. And I'm getting calls from cities across the country saying, hey, my city council saw this design you guys worked on with XNet. We think we want to go down this route. How did you get to a design like this? We think if it could work in San Francisco, it'll work in this small town, for instance.
If I could add too, there is lasting benefit also from, of course, the city has a new revenue stream, right? So there's the lasting benefit from that. But the city also gets, in the agreement that we have, 4 strands of fiber to do what they wish. So that helps the Wi-Fi deployment. That helps bring broadband to communities that don't have it. So there will continue to be a lasting benefit, not just that your phone works better, right, at this point, but there's a lasting benefit to the city.
Terrific. Thank you. I'm sorry, I would have to cut this short. I think there are many other questions we could ask. We got to keep it moving along. So, Robert, thank you. Miguel and Omar, thank you both for dialing in.
Thank you.
Thank you.
Thanks.
I think next up we've got Ron Nirenberg, another city success story. He's going to talk a bit. He's a city councilman from San Antonio, Texas, also a member of the FCC's Intergovernmental Advisory Committee, and he's going to be talking about experience in San Antonio.
Great. Good afternoon. Is everybody still awake? Well, thank you for having me here today, just to give you a little insight about what's happening in San Antonio as it relates to small cell and DAS deployment. And I wanted to start by just setting the stage for who San Antonio is, what our opportunities, what our challenges for us. And for those of you who have never been to San Antonio or who haven't been in a while, it may surprise you to know that we are the 7th largest city in the United States by population, roughly about 1.5 million people so far. What's striking about San Antonio once you go there, though, is not just the amount of people, but it feels like it's a small town. And one of those reasons is because we're a very sprawled out city. We have a landmass of about 500 square miles in total city jurisdiction, and then we have many more miles with our extraterritorial jurisdiction that's under county control. With that, obviously, just like every other city, we have extraordinary challenges with regard to expanding our wireless and data infrastructure. Some of those challenges are the fact, again, that it's a very big space, but we also have some opportunities that we've identified and we have been making investments in. San Antonio is also recently, last year, named one of the latest in the wave of Google Fiber cities. We have a very exciting mix of broadband infrastructure that includes both private sector competition. We are home of Time Warner as well as other providers like Grande Communication, AT&T. There's a really good mix of competition in San Antonio with regard to private broadband capabilities. We also, since the late 90s, have been investing in our own data infrastructure. CPS, which is our city public service, our electrical utility, which is city-owned, has been laying fiber since the late 90s in hopes that we would someday be able to leverage it. We've already been using it for our emergency operations center, our communications with transportation management infrastructure, as well as our own city mainframe. So there's a lot of fiber assets already in the ground in the city of San Antonio itself. So let me go now to where this brings us today. There we go. So as policymakers, and I will talk as a city council member, the CIOs in the room will probably run circles around me in this conversation very quickly, but from a policy standpoint, this is very meaningful stuff for local government. Wireless carriers, obviously, we've seen need to increase data network coverage capacity. In San Antonio, we are experiencing a growth in our city that includes also economic development opportunity and a diversification of our economy. A lot of those economies and industries are built on our digital infrastructure, including what is now a hotspot on our map globally for information security, cybersecurity, and so forth. We're the home of the 24th Air Force Wing, which you know is an important asset within our Defense Department. Current network capacity is spotty for a number of reasons, including the fact that we just haven't had a whole lot of build-out in certain areas of town. Our former mayor, now Secretary of HUD, Mayor Castro, has started an initiative called Connect Home to fill in gaps nationwide in places where people do not have access to latest 21st century technology. That kind of We would like to think that the germs or the seeds of those conversations began with his perspective in San Antonio, and that's certainly something that we've experienced. But we also have areas of needed capacity because we also have strong urban density in certain parts of town. We recognize that small cells and DAS antennas are a faster and more flexible way to get coverage to customers. And also because that we have experienced, just like many cities nationwide, challenges with wireless tower infrastructure. That includes challenges at the zoning level with residential concerns. We have challenges with undeveloped area where there's simply no backhaul available. And then we also have a tremendous number of historic and environmental assets. For instance, essentially we're the highest density residential area in San Antonio on the northern end of town is also some of the most environmentally sensitive areas of town. So it's been difficult at times to allow for the deployment of wireless towers because of things like generators. We have essentially a moratorium on underground storage tanks for fuel, which presents a challenge, obviously, for generators and things of that nature. So our solution, again, like yours, integration of small cells, integration of macro and small cells into one network. And this includes the whole host of options that you see there. We require access to buildings, poles, rights-of-way. And it also creates an opportunity for us now that we understand both the needs and wants of both sides of this equation. From the city's perspective, we have lots to bring to the table for a good negotiation. Strictly, we control our own right-of-way. We also, as a city that owns its energy utility, which has the majority of pole infrastructure, we own our own traffic poles and light poles, the majority of them. The rest of about 80% of the poles in San Antonio are owned by the city itself. The other 20% are AT&T and a few others. We have fiber runs all along the right-of-way. We also have a permitting process for right-of-way that exists outside of the zoning rules. So there's a lot of opportunity now for us to control our own destiny and work together with our providers to speed deployment. On the other side of the dais, I guess, is the carrier itself, which we recognize have their own needs as well, including, most specifically, speed of deployment, eliminating red tape, making it easier for people, providers to navigate the administrative end of fiber and wireless deployment. I've listed out here a couple of the assets that we recognize the differences between DAS and small cell. I guess the main message for policymakers on both of these, though, is that the small cell infrastructure allows for very rapid and flexible deployment of infrastructure to fill in those gaps, to help us increase capacity in those isolated areas. And also that the carriers themselves can license the right-of-way, excuse me. I forgot what slide this is on here. So that brings us to where we are working towards now. And actually, my main message today is that San Antonio has been working, recognizing the strengths of our city, but also the needs of the providers to establish now a master license agreement that we are using with one provider, imminently with another, and we hope that will be replicated for all the other providers in the area. Our goals setting out were to create an agreement that would streamline the process for wireless providers. Again, it provided an opportunity for us to work openly, to lay all of our needs on the table, and understand their needs as well, the impacts on their business plans to our city operations. Ultimately, like with any political or business negotiation, it requires trust, and that's what we've established in San Antonio. Primarily, it means that an acknowledgement of the need to reduce red tape and to help speed deployment of the infrastructure. They also, our providers have also recognized that we need a predictability with our process, as well as a fair compensation for the use of our right-of-way. The providers in exchange are also very respectful to our historic and cultural assets, our environmental assets, as I've told you, and we establish a local regulatory framework that everyone can play along with. And then, of course, the business plan and network infrastructure requirements. So that brings us to our master license agreement. The terms of the agreement, I've just kind of laid out the major headings, what we include in the contract, as it were. The grant of license, which includes the license to use our city right-of-way for wireless installations. We also have defined scope of permitted uses, which specifies the area, specifies the height restrictions, small cell installations, and also includes diagrams of acceptable small cell configurations. We also include the rental fee, which has the annual rental per small cell, but also the sub-licensing requirements for the small cells themselves. So one ring to unite them all, essentially. Protection of city resources, this is where we spell out the interference issues with our city wireless infrastructure, our city wireless systems, emergency systems, and so forth, as well as our historic preservation and environmental guidelines. We have a contract term that is favorable. It's long-term with shorter renewal periods to help us to maintain some predictability, but also flexibility with new deployments. Let's see. We also have the approval process laid out, which again specifies the terms of engagement. And just a quick report on where we are with deployment in San Antonio. Prior to the master license agreement, we essentially had no activity in small cell deployment. But we expect now that with this new agreement and the conversations that we've had since then, barring a few pole attachment issues, we're expecting over the next 12 months about 200 to 300 small cells to be deployed over the next year. And then again, we have a second agreement with another provider coming on very soon. Overall, then, just to put a bow on it, the main message for San Antonio for policymakers who may or may not be familiar with the technology is that this is an important step for us. We know that we've heard a lot about things like the digital divide, equity with regard to access to wireless and broadband infrastructure. This is where small cell and DAS will prove beneficial to San Antonio, but I'm sure to other cities nationwide, is our ability to target need, to place infrastructure in a speedy way that will allow us to fill the gaps in access. In terms of making that happen, we've found that cooperation with our providers to make sure there's a fair agreement, a win-win, is essential. And that requires sharing of information, confidentiality, and so forth. And I guess that, as you all know, there's some legal challenges that are still out there that we're waiting for, but we feel like we're in good position at this point in San Antonio to continue to deploy infrastructure and again, capitalize on the assets that we already have. With that, that's my summary from San Antonio. Happy to answer any questions that you might have. No questions? Well, I hope you all visit, and we'll be happy to share the template of the agreement as well. Oh.
She had one question.
Yes, ma'am.
Just repeat it so that it's...
Well, we've had, so our former city attorney who is now, or one of our city attorneys who worked on the utilities, is now over at our public utility, our electrical utility, excuse me. He's also, I think, current president of TATOA, So he has had a very good relationship with our providers. So there has always been a constant conversation, a back and forth about what they need, what we need, and so forth, and the challenges. So in terms of where did the master agreement come from, I think it was, it was in play the whole time. I mean, in this conversation about what we need as a city to help speed infrastructure deployment, but what also the providers are looking for to make it a solid business proposition. All right, thank you.
Thank you, Ron. So we're going to take a quick 5-minute break and come back and start the next panel. We have a couple more things to get through today, and then Pinder is here. So right at the end of the last session, we are going to have her speech that was supposed to be at lunchtime. Thank you. If we could get seated, and we're about to start the next session, please. This is Boston. Okay. So the next session that we're about to begin is a case study for Boston, Massachusetts. We have two moderators for this session. You've seen them both before. Jody Miller, who is the president of NEPA, and Jeff Steinberg, who is deputy chief in the Competition and Infrastructure Policy Division in the Wireless Bureau here at the FCC. Again, if you have questions, anybody who may have just tuned in or new people in here, we have note cards and pens for people sitting here. Just raise your hand if you have a question written on the note card. We'll collect it from you. Those watching remotely can send an email to livequestions, livequestions, @fcc.gov. Thank you.
Thank you, Cecilia. So we've been to California, we've been to Texas, and now on to the East Coast. Boston, a city with some great history of its own and a good DAS story to tell. So I don't think we need to spend a lot of time on introductions. Mike Lynch has just moved down the table one spot. Was in moderator before in his role, I guess, as president-elect of NEPA, and now he's wearing his other hat as director of cable and web services and IT for the city of Boston. With him, we have two officials from American Tower. Alex Gamata is the vice president of real estate, and Liz Hill is the state and local representative for American Tower Corporation. And the three of them have made Jody's job and mine very easy by coordinating on a single presentation. So I will just hand it over to the three of them.
Great, and thank you, Jeff. And first off, I want to thank the FCC for setting up this workshop. I think those who've been part of this all day certainly recognize the stories, the case studies that have been presented. It's a great way showing policy folks, municipal folks, OEM vendors and carrier and third-party folks like ourselves can all get together and talk about successes and lessons learned. Also, being a Boston-based company, and I myself am based in Boston, it's nice being out in a national forum where the topic about Boston is not about Deflategate. And Mike and I actually joked earlier that maybe you guys are doing long-term planning on having him moderate the Super Bowl case study. There's always this year. I think the Patriots look even better. So American Tower, for those of you who don't know us, we're a publicly traded wireless infrastructure company. We're a global company. We're in about 13 different countries, approaching 140,000 towers globally. In the United States, we have 40,000 towers. We market 15,000 rooftops, and we have over 300 DAS networks. And I should point out that in addition to being one of the pioneers of third-party wireless infrastructure in the U.S., we've been around since 1995. We're also one of the pioneers of venue-based DAS, where we've been in the business since about 2003, and as I mentioned, just over 300 venues. So when we talked about this session, Mike, Liz, and myself, And we wanted to focus on Boston, and knowing sort of the other case studies that presented themselves, what we wanted to do was maybe take a step back. Oh. Not 2 steps forward, but okay. So what we wanted to first do was talk about how wireless carriers or other wireless providers, our customers, how they approach their networks and how we try to support them. I mentioned sort of the array of assets that we have at our disposal, and I did that sort of purposefully because I know while today is about DAS and small cells, we also just want to point out that they augment what is out there already today, as well as could be in the future. Because I think, as many of the other case study folks have talked about, a lot of this is about time and money and predictability. So if you look at the way a wireless provider views their network, you can see here that we have large rings around, whether it's towers or rooftops, and I'll call those macro cells, or new towers. We talk about indoor DAS, and we'll talk about some examples of that. And then we talk about outdoor small cell, or DAS. And I think it's in that context that when we look at a city like Boston, that we can show what American Tower over the years has been able to do. So I'm going to go first. I have a few slides to walk through. Mike then is going to follow me by talking about what it means from a city perspective of working with a company like American Tower or our competition. And then Liz will go last to talk about lessons learned from the last 15, 20 years worth of siting infrastructure overall. So I guess if you go from looking at the architecture, and certainly we've heard about a lot of great small cell stories earlier today, but you might want to think about why is it that they're not everywhere? And this is a venue diagram that has been out in the industry for some time, and it really talks about the fact that small cells or DAS or really any of these solutions are driven by the economics, the time frames. Because if I'm a wireless provider, I want to get my signal out to my end customers as fast and as cost effectively as possible. So here's some 3 key factors. First off is the area, and thank you, is the area an area of high customer data usage? Are there a lot of minutes of use? Because again, and I think for folks involved maybe with rural broadband, you confront this issue a lot more than some of these other major markets that we're talking about. Is there the demand, the customer usage for your investment in the infrastructure? Next, are there traditional siting possibilities? Meaning, if you're in an area where you have towers or rooftops or other assets that are more traditional in its deployment, are they available? And last but not least is, do you have suitable assets available? Because I think that one of the things that kept on resonating, in particular with the San Francisco presentation, was that they felt they had suitable assets that were available. So you take all 3 of those things, and right in the middle is what we think is the sweet spot for small cells or outdoor DAS. So having said that, American Tower, as I mentioned, has been in the business for quite some time. Boston's our backyard. What are some examples of solutions that we've provided for our customers? And again, if you step back to that first slide, and there's the macro cell coverage, there's indoor coverage, and then there's small or outdoor DAS coverage. So on top, I don't know how well you can see those. Those are 2 macro cell rooftop locations that we have in the city. You might even recognize the upper left building, a very iconic building. And then on the right, you can see a traditional sled mount on a rooftop that actually is pointed towards Boston. And that's something that we continue to see carriers request. those kind of solutions, and those are kinds of solutions that we seek to provide. The bottom left is an indoor DAS. Some of you who've been to Boston, you might be familiar with the Copley Mall. Very highly trafficked, right in the center of Boston. And if you've been there, you know how busy it gets, really almost any time of day while they're open. So we have a DAS network there. And you know, the reason for that was because from the carrier perspective, it was the most cost-effective and time-effective way to provide the network solution that they were looking for. If you've been to the Copley Mall, you also probably recognize that where you are right there in the middle is very difficult to get penetration from the outside. Any sort of signal, as well as from a carrier perspective, and I don't want to necessarily speak for them, this was a case where they're looking to have a signal source on the inside of the building that can more effectively satisfy their customers indoors, as well as have a least impact for the outdoor coverage, a macro offload, if you will. And then the bottom right, what we have is we have an example, and I believe the folks in San Francisco brought it up. We view Wi-Fi as a small cell solution. In this case, not sure how well you can see it. You can see we're using existing infrastructure. The far right photo uses a street light right there next to Fenway Park. The left photo there is using existing traffic signal. So very targeted. If you know Fenway Park and Lansdowne Street there, you know how busy that gets. And so we're very close to the end customers of our customers in both cases, and we believe the impact in this kind of deployment is very minimal. Let's do a deeper dive about the Boston Wi-Fi network. So this is a shared high-capacity network, and we specifically targeted areas like Copley Square, Kenmore Square, Downtown Crossing, Fenway Park, and Newbury Street. It also covers the Boston Marathon finish line. And so from an American Tower perspective, this is a way of trying to get closer to our customers and users, and we did it using existing facilities wherever possible, and we did it using a process and a policy that was pre-existing. And I think Mike might be able to speak to that. So really to wrap it up, and what the header on this slide says is key network success drivers. First, it's about flexibility. You have to have coverage capacity where the wireless providers want it. And that's really important because I think that we sometimes hear from municipalities or property owners where they want coverage or capacity here from all of the four carriers. Well, if the four carriers don't want to be there, it's very hard to bring them there. But there are ways of being creative about it and trying to make cost-effective solutions. You need to think about the economic and being viable, the economics being viable. You need to think about the full range of solutions as you think about that, whether it's a tower, a rooftop, whether it's DAS, whether it's small cells, whether it's Wi-Fi, whether it's a hybrid of all of those above. And last but not least, you need to think about best-in-class service, because you can just imagine that if it takes millions of dollars in some cases to deploy these types of solutions, the time and effort that you have, and then if the service is not best in class, it really destroys, I think, the reason for having gone through all of that to begin with. So last, from an American Tower perspective, what we saw as a key network success driver is going down to the last bar there, the network deployment timeframes. It's the predictability and the peace of mind. So it's working with municipalities or property owners that understand that when we try to provide a solution to the wireless providers, they're oftentimes running multiple solutions in parallel, looking for the one that's going to be fastest, the one that's most cost effective. And then I'll finish on what we think is sometimes under considered a perspective, and that's just peace of mind. Understanding that the investment that's made is in the municipality or on a property in a neighborhood, making sure that you work closely with the neighborhood and the asset owner and the municipality so that, again, on the long-term basis, you haven't created unnecessary friction for what otherwise should be a very big positive in that locale. So we're going to wait for questions until all three of us are done. So with that, I'll hand it over to Mike.
Thanks, Alex. Appreciate it. One of Alex's slides kind of used a little Venn diagram there and showed a sweet spot, a tiny bit where they end up in the right-of-way and they're looking for locations. And I think we've found in Boston that I don't know, for wireless facility deployment, it's 80-20, it's 90-10, and we're that 10%. It's the challenge, it's cleaning up and getting down into the nitty-gritty, and it's complicated. Alex has worked with us on site-by-site locations. Oh, sorry, my apologies. Alex has worked with us on site-by-site locations. So haven't Crown Castle, I think Peter Heimdall's in the room, as well as Extranet, who you heard from on the prior panel. The challenge is that each situation is unique, and we work very closely with them to solve their problem. We're fortunate. We have a little power behind us. Our Mayor, Marty Walsh, sees this as a quality of life issue for residents in our city, students in our city, visitors, and businesses. We augment what is happening with these wireless facility deployments with our own Boston wicked-free Wi-Fi. Started a few years ago, and I think we're up to 300 APs, and we hope to double that over the next couple of years. We've put it into every one of our local neighborhood business districts, and we hope to put it into our public housing developments next. It's kind of a digital equity thing for us. We're sort of looking at noticing that most of the wireless facility deployments tend to be in high traffic areas. So those are the downtown areas, the financial district, the tourist locations, the sports venues, et cetera. We have to make sure that our neighborhoods aren't left behind. I don't think we had a chance to talk about that during the San Francisco presentation, but I know they looked at the same thing when they did their recent deployment with Extranet and Verizon. As we work with American Tower, Crown, Extranet, I hear soon it will be Mobility too, I guess. I'm having a little trouble saying their name because they keep using different names, but we'll get it done. And more recently, we signed a carrier agreement with Verizon. And Alex is very interested in that one. He's already been to our website, I'm sure. We changed a few things in the last year, and we changed it because the city really felt things needed to be changed. Again, we had the political will within our city to make some changes and make some improvements. And I just want to touch on a few of these little items and show you how a local government like San Francisco, how Boston has been responding and trying to make an efficient process out of something that is inefficient, not through apathy, but just because it's so complicated, and almost every one of these things becomes what I like to refer to as a one-off. Each one is so unique, it becomes a problem as it goes through those steps. So we signed a number of agreements with Verizon Wireless just this month, actually, including a memorandum of understanding for an all-fiber deployment within the city over the next 7 years, a cooperation agreement for future expansion for broadband and wireless services, and a city commitment to review and adjust any permit or inspection or review processes with an eye towards streamlining. There are other things in it. There's no new fee commitment. There's a designation of a clerk of works to review and inspection staff to larger deployments. We tried to consolidate all of the reviews. Remember, I was talking about the one-offs. We're trying to build them into sort of a geographic bundle. So like a fiber zone or a wireless network zone could come in and be addressed all together before our Public Improvement Commission. We simplified the fee process. We developed a cooperative planning agreement on winter moratorium. For you on the West Coast, you may not know what that is, but we get a lot of ice and snow in the winter, so we don't do much digging. It has to be very special, very unique, and very much needed. We've also tried a It's a new experience, and it was interesting pulling this together over the last couple of months. But in Boston, there's a unique quirk about our streetlights, and it is that they really do not have room for any facilities, including a single cable. So every neutral host who comes in or carrier who comes in ends up essentially replacing that streetlight with a model that fits. And we found that we had, I think, 14 different models of streetlights. I never noticed. And we've been able to get prior approval on 12 of those, at least within the Verizon agreement, and I suspect that Alex will be talking to me after this workshop. But the other two we weren't able to do it for, and that's because they're still gas lamps, so we tend to leave those alone. But moving forward, we're hoping that we will continue to sort of work with the neutral hosts as well as the carriers in streamlining this and remembering that our goal, at least as a city here, is, yes, it's a little fair compensation for the right-of-way, but mostly it is to address that quality of life issue of our citizens. And I would put it on the same tier, also to make sure that some of our neighborhoods are not left behind. That's a critical issue for us, and thankfully we have strong backing in City Hall for that. So I'll leave it to you. Thanks.
Thank you. I'm Liz Hill. I'm the Director of State and Local Government Affairs for American Tower. And I'm a little too close. I actually did not handle the permitting on the Boston project. And Don, when I talked to Don about what to talk about today, I've been in the industry with American Tower for 18 years, and I've been handling wireless siting, infrastructure siting that entire time. And Don asked me to come and give a bit of a historical perspective so that perhaps we can learn from that history as we move forward in the right-of-way siting. So I'm really here to talk about a path forward, learn from our past as we face our future. The current frenzy that we all see in the deployment of DAS and small cell is very reminiscent of tower siting in the late 90s. Any of you who were involved in those early stages of tower siting, this feels very familiar. One of the similarities is that the regulations have not kept up with the technology, and the regulations have not kept up with the deployment. We've heard from some cities that have kept up, that have done some groundbreaking work. That is definitely, I would say, the exception. I'm sure that the NATOA folks would agree. Most of their members still need some guidance and some help on how to get their regulations up to date. As a result, the frenzy in the 90s that we experienced resulted in moratoria. We got reactive ordinances, we got litigation, and we got hostility between local government and industry. It took us 15 years to work through that to a place of collaboration. We should do everything that we can as we're moving forward in right-of-way deployments to avoid that history and to not repeat it in the right-of-way. It's imperative as we go through that process, and several speakers have mentioned this, that industry and local government partner together towards that goal. First, I think that we both have to respect the role that the other plays. Industry, we have an obligation, as a couple of speakers have mentioned, an obligation to investors. These are financial decisions. These are our businesses. And at the end of the day, we can't spend every dime on every deployment. We have to make some financial choices. Also, the carriers have obligations to their customers. They have to provide service. Industry has to respect the role of local government. The local government could play a variety of roles in this context. In fact, as compared to tower siting, the variety of roles is much more complex. They could be stewards of the right-of-way and have a financial interest. They could be acting primarily or solely as a regulator in the context of aesthetics, traffic safety, worker safety for their workers, the workers who are climbing the traffic poles to fix the traffic signals, things like that. Economic development, or many others. So the local government wears a lot of hats in this context, which is not necessarily the same as what happened in tower siting. We have to respect that vital role that they will play in the deployment of small cells and DAS in the right-of-way. And both industry and local government need to understand the pressures that are on the other side as we come to the table, that maybe we need to listen more than speak as we begin these processes. Also, I think it's important that both sides come to the table with a centrist point of view, perhaps a pragmatic point of view. As we learned on the tower side, if the industry attempts to take advantage of any ambiguity in the regulations, we'll get a backlash. We know it will happen. It will simply be, what form does it take? On the other hand, the localities need to understand, and I think that we've heard repeatedly today that they do, they need to understand that a robust network is vital to their own citizenry, their own operations a lot of times, and the well-being of their communities. And they need to come to the table willing to work with us on how to get it done, on design guidelines that would allow us to deploy in a timely manner. This collaboration has already started. This event, I think, is an example of it. We should build on a lot of the work that's already been done. We're not starting from zero. The report and order contains a lot of helpful information. It's a great place to start. One of the complaints that I've heard from planners as we've talked about right-of-way deployment, they say that the report and order doesn't tell them how to actually get it done. It doesn't give them detail on the design guidelines, on what to look for, on what things to evaluate as they're looking at a specific application. We should also look to the success of the neutral host model on the tower side as we begin these discussions. The shared tower model in the U.S. has allowed for a robust and rapid wireless deployment while minimizing the economic and environmental cost. The U.S. economy, quite frankly, is reaping the benefits of that shared infrastructure model. Neutral host DAS and small cell can offer similar benefits. On the tower side, by crafting regulations that encouraged the shared use of infrastructure, we got a faster deployment with less impact. DAS and small cell regulations that follow the same path should result in some similar benefits. So one starting point for me is for us to come to some consensus around what small cell means to a locality, not to an RF engineer, but to a locality. There are a variety of existing definitions. I think we heard a few today. But at the end of the day, a local government official is going to be looking at a set of plans, and they need to know what process to apply to that application. It's crucial that the guidelines that we develop are clear so that bad actors on the industry side can't take advantage of ambiguity. It's also important that local governments encourage good actors and that those who do attempt to take advantage of ambiguity are thwarted. If those who, we're going to call them bad actors, are successful, then those companies that want to do it well will be under pressure to take advantage of those same ambiguities. They have a financial obligation to their investors. If their competitors are taking advantage of something and reaping financial benefit, then why shouldn't they, even though they may want to do it well? So the regulations should encourage good behavior on behalf of industry and discourage what the bad behavior you don't want. I believe that our various associations could play a role in brokering these sorts of compromises, similar to what we did on 6409. One deliverable would be perhaps a set of sample design guidelines. We've heard a lot of talk about some of the things that Omar developed in San Francisco. I heard San Antonio has some design guidelines. We're not creating the wheel. We have something to start with. Another option would be perhaps a draft ordinance. I'm actually thinking that a set of model guidelines or suggestions might be more flexible given the incredible variety of permutations in right-of-way deployment. It might be easier to have a set of design guidelines that might be helpful for both industry and for local government. At the end of the day, we've got the same goal, allowing the deployment of robust wireless service to all of our communities in a responsible, thoughtful, and expeditious manner. We cannot and will not agree on the details, and I think we have to accept that. But the fact that we don't agree on the details is not a reason to not come to the table. We need to come to the table and find the common ground. It's there. Let's learn from our history that we learned on the tower side and accept that finding that common ground sooner than later is in all of our best interests. Thank you.
All right. Thanks to all of you. Learned a lot. You want to lead off? Or?
Sure. I'll ask one follow-up question. We've had three great case studies so far today, but all from larger urban cities. So is there anything that we can take away that we can apply or figure out a way to work with our medium-sized regional towns and our small rural towns? And do we need to create some levels or some tiers in our models? Any ideas?
I think that's where, if you can come up with a set of guidelines that are flexible enough to help a city create design guidelines for them to actually implement, but that take into account how large is the city. To me, it's not even about the size of the city, because to your point, even Boston, within Boston, has a tremendous variety of roads and ways they're designed. It's more about what is there, how wide is the road, what's the speed limit on the road, is it a pedestrian road, is it a city that where it snows a lot, or is it a city planning for hurricanes? Those to me are the more relevant inputs into that process rather than necessarily the size of the city, because every city would have that kind of variety of right-of-way.
Great.
All right. I guess one thing maybe to develop a little more. I know, Alex, you spoke a bit about the particular parts of Boston where the DAS is there and focused on them for their areas of use. And Mike, you talked about not leaving the neighborhoods behind and moving into other areas. I wonder if you could elaborate a little bit more on, have you thought about the path going forward? Are there elements in your agreements that give guidance to, when and how, deployment may be appropriate in other areas?
Well, I'd be happy to start there, Chuck. Thanks. I know that in our different deployments in Boston, we have actually been able to successfully spread it out to a lot of the neighborhoods. So the focus has always been on a downtown sort of high traffic area, but it's almost like a linkage. Well, if you're going to be here, we encourage you to look at this. And it has worked. I could be wrong. I'm not sure if it's the neutral host company or if it's the carriers with whom they were contracting that ultimately made that decision, but I think the decision was made to grow out. We recently finished a mapping exercise on this at City Hall, and as you look at it, you realize we've deployed quite well out into the neighborhoods. And in addition, I mentioned our wicked-free Wi-Fi. If you can't go, we'll go. But you've got to help us somehow to do so. So we're not actually compelling people to build where they don't want to build, but we are saying that these are our citizens and they need to be addressed. I suppose, Jody, a little bit of this addresses, as you say, in a smaller town. You're always going to get it in the center of your town where the mass of the traffic is, but you have to make sure that you also think about the outlying areas that do have a business district to them or something like that need some support.
Well, I think just to add to what Mike said, and I think also answering both your questions, is that communities where maybe it's not a Boston or San Francisco or San Antonio that very much need this kind of infrastructure, want to support broadband development, all those things. I think there are examples that you can point to where you try to say to the municipality, well, what are your IT plans or your mobile plans for non-cellular? Is it public safety? Is it street parking? Is it other sort of things? And are there things that we could try to leverage? I think in San Francisco they talked about the electric company utility fiber. Is there infrastructure that a company like ours can leverage to try to provide a cost-effective solution to those wireless carriers? Because it goes back again, to that Venn diagram where it's cost and it's money. And I think Boston's done a really good job, encouraging us to make sure that we look at the broader city. But at the same time, there's a lot of market forces that I think have played out nicely. It's those other places I think that you're talking about. How can we work together? The public-private partnerships, they exist. It's a matter of showing best case examples and putting those models out there for it.
I remember, actually, as Alex was talking, I think it was Christmas Eve, he drew me out to Columbus Park in the north end of Boston. Very beautiful park, very historic. I'm not sure why we were there on Christmas Eve, but we were. And he said, well, what if we do something here? And I said, well, the neighbors are going to want something. What are you going to do for the neighbors? He says, well, we'll throw another SSID in there for them. And, if the Parks Department needs something, we could throw something in there and start to ask. It's like, how many SSIDs can you put in a single access point? But, again, there was a spirit of cooperation that was coming forward straight away.
Great. Any other questions out there? Do we have any email questions? No.
Okay, well, I think if we don't have questions further from, the audience here or on the web, we'll keep moving because we still have the lunchtime speaker to work in later, and we lose our closed captioning at 4:30, so we do want to end on time. So we'll keep things moving then. Thank you very much.
Thank you.
Thank you, Jeff. Thank you, Jody.
So if we could get the speakers and moderators for the last session, the Philadelphia session, to come to the front. And also to let you guys know, we've gotten a lot of questions today about the slide presentations. We are working to get them up on the event webpage. So if you go to www.fcc.gov/events and then look for today's presentation, they're listed by date, then hopefully by tomorrow we'll have the slides listed or posted up on that page. And again, for those that are watching remotely, you can submit questions for the panels by sending an email to livequestions@fcc.gov. If you're sitting here in the room, we do have note cards at the back of the room. So we do have, for this afternoon's session, so as I said, this is a case study of the papal visit to Philadelphia, Pennsylvania. We have two moderators for this session. I believe we have one person calling in. Is somebody on the phone for this panel? Is Richard on the phone? Okay, so the moderators for this session are Steve Traylor, who is the Executive Director at NEPA, and Dan Abeda. Dan is an Assistant Chief of the Competition and Infrastructure Policy Division in the Wireless Bureau here at the FCC.
All right. We're just about keep those eyes open. We're coming down to the last lap. Our final panel today involves the use of small cells to cover one of the most highly anticipated events in the U.S. last year, the papal visit to Philadelphia in September. Since I had the privilege of going to the papal mass here in Washington, and I was also in Mexico City when the Pope went to Mexico, and I saw looked like millions of smartphones all over the place. I'm really excited to find out just how you manage this project. So with that, we'll introduce our speakers.
But before we do that, I just want to echo what Chairman Wheeler said this morning about it's been 4 long years since we had one of these workshops, and it's been way too long, and shame on all of us for taking so long to do this again. So thanks again to all the folks at the Wireless Bureau for putting this on, and hopefully it won't be another 4 years before we do this again. I'd like to introduce our speakers onto this last panel today. Peter Heimdahl, who's the Director of Government Relations for Crown Castle, and Michael Kane, who's a Project Manager for Construction Implementation for Crown Castle. And on the phone we have Richard Montanez, who is the Traffic Engineering, or with the Traffic Engineering Division of the City of Philadelphia. And with that, we'll kick it off.
Thank you very much. It's really a privilege and an honor to be here today, so thank you for extending the invitation. I'm not sure I can top the wicked free Wi-Fi. I love that terminology. So anyways, just by brief way of background for Crown Castle, I think there were some other presenters earlier from Crown Castle, so I won't go into too much detail. But, of course, like some of our competitors that have spoken previously, Crown Castle is a shared wireless infrastructure provider. I'm going to focus on the small cell portion, obviously, because that's what this forum is about. But Crown Castle has deployed about 15,000 small cell facilities and growing nationwide. Roughly just under 900 of those, if you count the 37 along the Ben Franklin Parkway around the city of Philadelphia. So what I'm going to do, we can start on the first page of the slide here, the introduction. We'll back up a little bit. This might be kind of hard to see for the general audience. So just to kind of walk us through really what is I consider to be a great news story and the way that a deployment really should look like, and I wish they all look like this. Unfortunately, in my territory, they don't. We'll walk through, of course, the papal visit. The Pope is coming. I put an exclamation point on that. That kept me up at night quite a bit. So number 2, small cell architecture overview and benefits. I won't go into too much detail because I'm sure other panelists had spoken to that earlier. And then we'll walk through some of the planning stages and the project inception and how that progressed into the government relations activities. Then, of course, through to construction commencement and execution, and then the recap of the overall great experience and the customer satisfaction that evolved from that. Really the way I look at this project, it was really a perfect storm in the good sense of the term. It was really brought together by a common goal, not only from our carrier customers, but also from the city, the various city agencies that were involved, and as well as Crown Castle. So, even though it was fostered by the urgency of the Pope's visit, there was a lot of thought and input in a very short amount of time, to prepare us, for the strain on the existing networks and wireless capacity within the area for the immediate event, but also for the future as well. So anyways, we'll get into the story about how we really successfully stood up this network in 9 months. And I'm going to defer complete credit to the success of this project to the local team, including Mike Kane, who's sitting next to me, and his efforts and the team's efforts in collaborating with the City of Philadelphia staffers. So we'll go into the next slide, please. There we go. So the Pope's visit. So as I described earlier, we found ourselves suddenly with about 9 months to really make sure that we had a robust network to cover the Ben Franklin Parkway. We were anticipating about a million plus people. I think ultimately about 900,000 were there for the Pope when he arrived. So the first challenge was the infrastructure that was planned for the Parkway, and in initial discussions with the City of Philadelphia, they wanted to make sure that this was a shared solution that transcended across multiple carriers. And a couple different reasons for that. Number one, there's obviously some fairly large aesthetics concerns, and also, we're operating within a historical district. So, sort of the preservation aspect of the beauty of the Parkway was extremely important, and that point was driven home to us very early on in the project. So just by way of background, the entire Parkway, which is about a mile long, sits smack within the middle of entirely within a historic district. So next slide, please. So this is it's kind of hard to see up on the slide here. I love this photo, but you can kind of do sort of a Where's Waldo exercise and see how many people are actually holding up their phones, taking pictures. I'm assuming some of them are taking video as well. And on the near side of that the Pope's vehicle, I counted at least 5 cell phones that were being held up. If you look across the barricades, there's a lot of people holding up their cell phones like that. So kind of a great shot. Next slide, please. So this is a slide. I won't get into too much of the detail here. Why are small cells a good solution? And in this particular instance, I think it was largely self-explanatory, just given the historic nature of the Parkway and the aesthetic concerns surrounding enhancing that broadband experience. So, obviously these are smaller size, lower in power, and the nodes cover a much smaller area than a traditional cell site otherwise would. So using multiple nodes closer to the ground, we were able to accomplish more capacity to the same geographic area. basically translating to a better overall experience for wireless users in that area. So small cells, as we know, are visually appealing. Obviously, a tower is not going to fit into the Ben Franklin Parkway scenery. And through the process, we worked with the city to try to match the existing infrastructure on the parkway to the best we were able to, given the customer constraints that we were also dealing with. Obviously, small cells are extremely flexible. They can be upgraded readily. And again, the last point, shared infrastructure in a neutral host environment was extremely important to Crown Castle, but also to the city. So the next slide here, just a graphic depiction of, sort of what our deployment looked along the 1 mile long Ben Franklin Parkway. To the left-hand side of that picture, you've got the famous Rocky Balboa stairs. I think there's a statue of him right to the side of that as well, near the Museum of Art, down to the other end where you've got City Hall. Okay, next slide, please. Okay, sort of the project inception, and I'll walk through this because I'm watching the clock here as it's ticking down. So, a lot of planning obviously went into the network deployment. Again, designed to blend in with the existing street lights. And by the way, it's worth mentioning that I think this was probably the one and only time that Crown Castle had 3 carriers already on the network at the time that we turned it on. So that was a pretty fantastic accomplishment, and again goes towards the collaboration. So then we move into the regulatory government relations aspect of the project. Working with 6 separate departments within the city of Philadelphia. So again, emphasizing the collaborative efforts. State Historic Preservation Office process that we had to go through, and also the TCNS Section 106 process and notification of the tribes. There were 8 tribes that we had to notify, and I believe we ended up paying close to about $100,000 in tribal review fees for that. And the foundation for all of this cooperation, by the way, was Crown Castle's existing license agreement with the city of Philadelphia that was signed and entered into in 2007. So, as I described, we've got just under 900 nodes throughout the city. The city knows us well. They understand what it is that we do, and we were able to really build upon that relationship to get this project done. Next slide we can skip over. That's just an aerial depiction. And then going into the regulatory government relations process and kicking this off, I'll summarize this by saying that, getting through the process starting in December of 2014 and getting through all the entitlements by March 13th in roughly 3 months, I mean, that's just an incredible success story. And then I'll hand it off to Mike if we've got a little bit more time for some comments on the construction.
As
so
usual, government relations gives us very little time to build things.
That's right.
Right. So I'm going to put 2.5 miles in 10 seconds.
I knew I was going to get myself in trouble with our implementation team here somehow, some way. All right.
So now we're talking about the underground construction, and quickly, we did build 2.5 miles of underground new infrastructure on the Parkway. That consisted of our fiber optic cable and a new power plant to service our DAS small cells. We put in 3 2-inch conduits in a trench. Trench was 6 inches deep. 6 inches wide, 36 inches deep. And we also deployed 60 meet-me points, as I call them, or splicing locations. They're for the existing infrastructure that we placed on the poles, as well as future for any DAS facilities or any other connections that we need to do. Again, Peter mentioned this a couple times. We partner with the City of Philadelphia. They, in each department, gave us all the approvals to do this work and walked all these locations out with us. As I move to the next slide, which is actually a picture of the construction, you see the trench and some of the activity there on the Parkway itself, the pipe going in. I mentioned we put in 3 pipes. 2 of those were for Crown Castle. 1 we actually placed for the city as well. And then from a pole construction perspective, we actually put up 37 DAS locations on the Parkway area. Of all those, 13 of those were new net add poles into the Parkway, which were approved by the city as well as the Parks Commission. Of the poles, 24 of those had to actually be replaced. So we're replacing traffic poles and or luminaire poles that were on the Parkway already. Of the 37 sites, 24 of those poles, 3 carriers, as Peter mentioned, they were on 24 pole locations or sites. 2 carriers on 4 of those poles, and 1 carrier is on 9 of the poles. At the end of the day, one of the carriers actually was on all 37 poles. So, again, we partner with the City of Philadelphia to do that process. And then there's a slide up there is the pole construction itself. To the left is one of the traffic light poles that the city allowed us to deploy on. We actually replaced that pole with put a 10-foot foundation in and a new steel D pole, as we call it. And on the right is one of the decorative poles on the Parkway. This is actually a net add pole. They had similar poles on the Parkway that we matched with the Parks Commission and deployed here as well. Again, from a construction standpoint, I said it before, our success on the Parkway itself was all due to our partnership and our collaboration and the opportunity we had with the City of Philadelphia to sit with them on a monthly, weekly, and daily basis from the Highway Division, survey teams, design teams, the right-of-way department, and obviously the traffic and lighting department. So it was a great effort, and we really enjoyed it. Peter?
Yeah, I just wanted to finish up by taking the opportunity to thank. I know Mr. Montanez is on the line, but I didn't have a lot of interaction with him, as I said earlier. I'm going to give the local team for Crown the entire credit for that. But just the opportunity to work with the city of Philadelphia and the general attitude and atmosphere of receptiveness to our project. And again, understanding we're working towards a common goal. But even if we weren't working towards a common goal and we had 37 nodes that we needed to deploy, if they didn't have these extra considerations involved with the Pope's visit, I dare say that we probably could have gotten through this process even more quickly. And again, going back to the fact that we've got an existing asset in place in terms of a license agreement with the city. Was extremely important to that. So again, Mr. Montanez, thank you, and please extend my gratitude to Mr. Palmer as well, who was instrumental and is not on the panel. So thank you.
Okay, I will. All right. Do we know if he is on the phone? Yeah. I don't know if he's on the phone or not. Oh, is he on? Okay. All right. You're on. Mr. Montanez, you're on the call?
Yes, I am.
Yep. All right. Do you have a presentation?
I do not. I just found out about this meeting on Friday.
Okay.
They just asked me to sit here.
All right. Well, we may have some questions for you. All right. Well, having done a substantial amount of work in the Section 106 area, I would like to know how you managed to get this project through the SHPO's office so quickly. That's got to be a world record or a U.S. record anyway. Is there any story behind that?
Well, no, I don't think there's really any special story behind it other than, I think it was a very close collaborative effort with the city in terms of what they wanted to see on the Parkway. And I know we went through several iterations, and I kind of glossed over some of my slides just due to time, but, just sort of, if you look back at the chronology in that slide deck, there were a lot of salient discussions with the city in terms of what they wanted to see, whether ground equipment was appropriate, whether strictly pole mounted was appropriate, and again trying the best we could to blend in a 3 possibly 4-carrier, hopefully, infrastructure on the parkway within those constraints. And so, the State Historical Preservation Office for Pennsylvania was extremely cooperative in this regard as well. And just getting through the tribal process, we have a Crown Castle has a regulatory division that handles that. So I was not intimate with the details, but everything went as planned in terms of getting the information in the door to do all of the notifications and everything else that was required of that. And we had really, that I'm aware of, virtually no resistance whatsoever to our design for the entire 37-node project that we were talking about.
All right. This is for all of you. How did you work together on the traffic issues? I'm sure there were a number of significant traffic issues that you had to overcome.
I'm going to punt that one to Mike, because I think he's more intimate with the details here.
Again, just working with the City of Philadelphia, the right-of-way department. We have to permit all our activity. It wasn't a freebie. And through the permitting process, you need to communicate with the City of Philadelphia Traffic Department itself, the police. So they actually do come out and put a police officer with every crew and construction outfit on the street. So we dealt with it through the city. They actually closed the streets down. And if you're familiar with the Parkway, I believe it's 6 lanes, Mr. Montanez, maybe 8, where there's outer lanes.
6 lanes in each direction.
6. So there's outer lanes and inner lanes, and we had to schedule the work activity so that people coming in the morning into the city, we were not blocking those lanes. We could work on the outbound and vice versa. So again, the city streets department and the police department worked hand in hand with us on a daily basis.
Okay.
And this is a question for Mr. Montanez here on the phone. Why don't you tell us a little bit about the security concerns you had and the public safety issues you dealt with, and especially working with some of the federal and state agencies and getting this project through?
Security concerns in regards to the Pope, or security concerns in regards to the to this project?
I think to the project.
Well, I mean, the reason we were the fact that the Pope was coming and the Mass was going to happen in this area where we currently host special events in Philadelphia, we knew that we needed to at least make our system a little more robust for the area. And this gave us the opportunity to, one, literally probably eliminate a lot of our red tape that normally would happen because of the quickness that we had to get to the Pope. From a security point of view, one of our concerns here is there's always the cell phone coverage is terrible, or used to be terrible in that area. And once you had over 80,000 people in that area, trying to get a signal was horrible. Even our 911 phones sometimes give us problems there. That's why we looked at that project too, and kind of wanted it done before the Pope got there. I mean, our first, I think the Secret Service first number to Philadelphia was 6 million people are coming to the city.
I can add to that as well. There's one bullet point on the slide here that there's one of our customer carriers reported pretty interesting statistic here that over 12.6 terabytes of data usage on their network was transmitted during the papal visit, almost 7.5 times as much as they reported for 2015's biggest NFL game, just to put that in perspective. So didn't match I don't think that counted the Super Bowl necessarily, but that's a lot of traffic.
Significant. Another question you indicated, we all know that Parkway is historically significant, to say the least. How did you integrate your new towers and the small cells into that area without adversely affecting the historic character of the parkway.
Yeah, so I think I'll leave some of the details on the actual construction and what it looked like to Mike, but I think the initial discussions with the city were definitely surrounding the preservation and the integrity of that atmosphere and that aesthetic environment. So we were very sensitive to that going into the project.
Right.
But I know there were numerous field visits with the city out into the parkway, of course, and just trying to match the existing environment, in terms of the pole structure that was already there. And I think, Mike, you were probably on some of those visits, so you might be able to add a little bit of color.
Probably
to that.
about 337 of them. But yeah, and actually with Mr. Montanez and the other city officials, particularly the Park Commission folks, they had particular poles out on the parkway that were decorative and luminaire, and so we had to match those. So we did bring in a steel structured pole to meet our structural needs. At the same time, build a foundation to hold that pole and the antennas and the other equipment, as well as skirt those poles to match the existing look on the parkway. And I believe we did a pretty darn good job at doing that. We almost matched it exactly of what is on the parkway today, and painted them green just like they are. And then from an underground perspective, we were in the street itself, so you're not seeing us now. We actually went in a bike path and paved over that, and then since had painted that bike path green, which it was before. So pretty much invisible except for some flush mount vaults on the corners and the existing pole structure.
All right. And one last question. What advice would you offer to anyone proposing to increase wireless services in a historically significant high-density area for a major event similar to the papal visit?
Well, I think from a government relations and a regulatory standpoint, I think the relationship building with the jurisdictions and the relevant agencies that are involved in the approval process, of course, I mean that was critical for us. And again, going back on the 9+ years worth of good relationships that we've enjoyed with the city of Philadelphia, I really think that was a big part of the success story there. So my recommendation, at least, I'll let you speak from a construction implementation standpoint, but building that relationship is critical. It's easier for all involved. It doesn't always go that way, as I alluded to earlier. And again, I wish a lot more of the projects I was involved with went that way. But Mike, I'll turn it to you in terms of.
Sure. I would say be honest and open with your local municipality.
Right.
Befriend them and pray for divine intervention.
Well, apparently you got it. All right, so are there any other questions? Well, that was a fascinating story. Yep. Oh, yeah, yes.
So I've been sitting throughout the day and listening to the various presentations, and I have a question on, I believe like San Antonio Council's presentation was about their approach is more toward small cell reduction of DAS, and it seems like in Boston or Philly, people more the DAS application. Is it that the terms are starting to be used interchangeably, or because it seems like the DAS would be more efficient in terms that it could host multiple carriers, someone like Crown, to build an infrastructure. So what would be the case for using small cell?
In the parkway or in our project itself here, that wasn't the case, obviously. We had 3 carriers on there and could have probably did 4 if we had to. And that was just because of the technology. So the difference would be the technology that's deployed in that particular area. We might not have been able to do small cell on this particular project just because of the area itself and the historic nature. The equipment would have definitely been different. Very hard to stealth or disguise or put ground furniture in.
There seems to be more benefit than to go on the DAS side than small cell in general.
That depends on what you're looking for, what technology you're looking for in the carrier themselves.
Yeah, I think you're right. I think there's some general confusion now going forward as to the nomenclature. In my mind, from a strictly government relations sort of blinder standpoint. I use it sort of interchangeably, as it's a fiber-fed network system. So I think the perspective really depends on who you're asking, whether it's a carrier or the company that's providing the shared wireless infrastructure experience.
All right. Well, we want to thank you for sharing the success story with us.
Thank you.
All right.
It was a
Thank
pleasure.
you, Crown Castle.
Thank you.
So we're just going to take like a 2-second break. I don't want anybody to leave the room. We're going to let them go get Pinder settled, and then we will be right back. So 1 second. Don't leave. Okay, so in order not to lose too much time and run too late, we're going to go ahead and get started. So next we have Pinder Chauhan, and Pinder's going to give us a presentation on women in wireless engineering. We will be able to ask questions. If you have questions for her, if you want to just raise your hand, and what we're going to do, it might seem like we're wasting a little bit of time, but so all the questions are picked up, because if you yell from the audience, they're not picked up. She'll try to repeat the question and then answer it, okay?
Right. Well, good afternoon, everyone. Okay. First of all, thank you, FCC, for accommodating this as I end my 24-hour journey from Dallas to D.C. So hopefully the journey back will be shorter. So as I was introduced, my name is Pinder Chauhan. I'm with CommScope. You met my colleague Nate, who was part of the panel earlier. So CommScope is one of the lead providers of DAS systems for distributed coverage and capacity solutions. And in CommScope, I am responsible for running the tech support and training functions. Been in telecom for about 25 years now. So I wanted to share some background. It is in context, so I'm not just letting you know by myself for no reason. How did I start my journey in telecom? So me and my parents came to Canada about 30 years ago in pursuit of greener pasture and improving our life. So we land in Canada just in time for me to decide what I want to study. I had finished my high school. I had to make some choices in university. I had no clue what I want to do. So here we are in a new country. Well, what do you want to apply for? So I met with my counselor, and luckily my mom and my counselor were there to point computer science to me. And I said, what is that? They said, well, it's the new up-and-coming field, and it has a really good potential of earnings. I said, okay, that sounds good. We're new to the country. We need that. So I decided I will pursue my education in computer science. So at the end, as I was finishing my bachelor's, I really liked it. I said, what a neat idea. Look at all the applications that we can use computers in. And the more I knew, I was given a chance. The point is I was given a chance to learn computer science. And I decided at the end of my bachelor's that I want my career in computer science. So here I am, 25 years later, and I think that's the best decision I made. So I wanted to talk today a bit about women and women presence in the STEM engineering field. Oh, sorry. Okay, do we believe that women are underrepresented in STEM engineering? I truly believe so, but I'm so glad to see so many women participants in this room. That is not a typical environment for us as we go back to our normal day-to-day jobs. But if we look at today, women make 50% of the workforce. But less than 25 of those jobs are in STEM field. So yes, we are underrepresented, right? So what's the effect of that? I think there is, the biggest one is there is an untapped market. There's untapped skill set that we could bring to STEM jobs. As important as STEM is in today's industry, I think there is a lot women can bring to it in terms of collaboration, in terms of innovation, and also just bringing a different perspective to things, right? So 2 examples that come to mind is when we look at how the first generation of voice recognition software was made. Who made it? A bunch of men engineers. So when that came out, it will not recognize women voices. So as a result, it didn't work that well. It didn't serve the society as well as it could have. Another example, when the first version of airbags were built, it was a similar environment where they were built. The first generation didn't work very well for women and children, right? So these are just some real examples that tells us the effect of not having enough women presence in STEM jobs. And I think we can do better. So what are the factors? If we look at high schools, there is equal amount of boys and girls who choose science and math. But as we go into high schools, the ratio changes. We see more boys picking pre-calculus, physics, and science, whereas girls gravitate towards arts and other similar subjects. And this ratio further diverges as we go into universities and higher education. So if you look at today in STEM bachelors, how many women make the number of people who get bachelor's degrees in the STEM field? About 20%. And as we go into graduate studies and as we go into the workforce, the ratios get smaller and smaller, right? So why? Why is that case? If we compare STEM with other fields, like medical, nursing, education, that is not the case. Why is it different for STEM? Right? So looking at various studies that were done by AAU, W, and others, it shows that women gravitate towards a set of areas of school studying, either nursing or education or arts. And why is that? It says it's because there is a factor of perceived stereotyping, where the lack of equal number of representation leads to that. So they feel overwhelmed by the number of difference in the participations. So as a result, they gravitate towards fields which they are more comfortable in. That's one of the reasons. And the other one is also not as much of the populations are encouraging or sharing information in terms of what does a real engineering job look like, right? So that kind of feeds in the perceived stereotype. People are not taking chances. Women are not taking those chances, right? And what does that lead to? That leads to lower self-esteem and lower confidence. We make ourselves believe we cannot do this because we feel like we don't see as many of us out in the market. We feel like, okay, well, my rest of my sisters, my other coworkers are doing this. That may be the right fit for me. So that's a self-fulfilling prophecy. We don't go to those fields. There's not enough mentors for other women to come and help grow the population in the STEM field. So those are some of the key factors why I believe that we do not have enough representation from women in the STEM jobs or STEM classes in higher educations. On the next slide, we have some research that was done by universities and other companies when it comes to women and their participation in STEM-related areas. I'll let you read through that, but I wanted to add a couple more things to it. One was if you look at two comparable fields, I looked at bioscience and engineering. How has growth of women participation done in those two fields? In biosciences, about 40 years ago, the women participation rate was about 11%. It has grown up to 44%. Whereas if you look at engineering, we were below 5%, and it hasn't changed a lot, right? So We have made progress in some science fields, but there are others, physics, engineering, still we are very little minority. Right. Another stat, it was done by women's engineering study done by Women's Society. They followed 6,000 engineers from the time they finished their engineering degree to 10 or 15 years after the engineering degree was completed to see where they are today. It shows that 25% of women are no longer in the engineering field. Either they never entered it in spite of their education, or they dropped out. Whereas only 10% men show that. So the issue is not just entrance to the STEM jobs, it's retention. So we need to improve both. Okay, so what can we do? I believe if the society is to make a change in this area and really have higher participation from women in engineering fields and mathematics and science fields, we need to create a culture of encouragement. We need to create a culture where we encourage our daughters, our sisters, our friends and co-workers, such that we dispute the stereotyping of questioning women's abilities to have a career in a STEM role. It can be done. I don't think it's an abilities issue. I think it is an issue that is far more complex, including social factors and background, lack of mentors, and others. Either we have the abilities or they can be gained. So there was a study done in terms of women's performance in mathematics. About 30 years ago, we looked at what is the ratio between boys and girls of age 13 who score 700 or higher in SAT. The ratio was 13 to 1. Today the ratio is 3 to 1. So all that means is we needs awareness, needs focus, and it needs to be made a priority. Right. And the other part of that study shows that girls in that group, they self-assess themselves lower. What that means is if you were to take two students who scored the same on SAT, or take a group of women, girls and boys, the girls scored themselves lower than the boys did, even though their grades were the same. So that goes back into, not having that self-esteem, not having the confidence that we can be successful at high-tech and STEM jobs, right? That is something has to come from within, and the society has to support it, right? Sorry, I was looking at my time. So what should we do? I think the first step is we need to raise the awareness, and we need to break this down in terms of it's not a mystery anymore. Working an engineering job is not a mystery, such that we talk about it in schools, we talk about it in universities, and we clearly talk about in recruitment. What does an engineer's job look like on a day-to-day basis? I think that engages women, so other than it's out there, it's not me. No, it is you. We just need to open it up. We need to have dialogues around what are the different applications of these skills, right? And the discussions have to be around capabilities, desires, what do we want to do versus gender, because I think it doesn't matter, right? And I think the recruitment process has to improve where it is more inclusive, right? So that we are seeking out different types of candidates for these jobs. And also, my advice will be, if you are a woman in STEM field, be a mentor. Get a chance to go to school, your daughter's schools or son's school, and speak about your experiences, right? So I think having someone talk about their experiences makes it real. It is something that can be done, right? So those were just some of the things I think if we were to do as a society, we can change this, and we can make a better environment and have a more competitive environment for the STEM jobs, because I think it's better together than not. Right? So CommScope as a company is completely behind it. We believe this is something that needs a lot more attention, and because of that, we came up with a program called Women in Wireless. So what Women in Wireless is a program, originally, how did we come up to this need? I joined CommScope about 3.5 years ago. And in the first 1.5 years, when I ran the training department, I said, how come we have not seen a single woman attend our technical trainings? And it was clear also in the partners and our people we would hire to deploy DAS. So we go back and we say, well, why is that the case? Is it the fact maybe it's monetary, or is it awareness? It's probably both. So we want to raise the awareness of, yes, these trainings are available for any woman who would like to get into the DAS field and has the right background to come and take us up on it. There's a suite of training classes we will offer free of charge. Obviously, there is a limitation of how many seats we can offer per month, but it's a class that's held every month. And they go from DAS 101 to product overviews to all the way to hands-on installation and commissioning certifications. We started this program about 1.5 years ago. So as I said, for the first 1.5 years I was in CommScope, we had 0 representation from women. So I'm happy to report in the last 1.5 years, we have had 26 women who have gone through our trainings. Right? So at the end of the day, it's raising the awareness, it's creating the interest, and we're talking about it. And we will stay committed to this program. As CommScope bought TE's wireless division, we have expanded this curriculum. Now, we offer similar training classes on the TE products, and soon to be added some trainings on small cell as well. I just wanted to share some comments we received from women who have attended these trainings. While it is a training program where we specifically train one topic, but what I like to say is our approach is building the knowledge, right? Building the knowledge of high-tech, building the knowledge of wireless, building the knowledge of DAS environment. We want to promote knowledge, we want to promote awareness, we want to promote opportunities. And obviously, we want to provide certifications for women so that they are able to apply to those jobs. When they go to AT&T project, they say, are you certified to install DAS? Yes, I am. Right. Okay, and that's my last slide. It has information on, if anyone needs more, would like to get more information on this program, or know some women who would like to apply to this program, please reach out to us. And Nate has passed on some catalogs that this training program is built around. The last page of that catalog also has information on how you can reach us. So I really hope we hear more from women, because I think it's a well worth cause, and we completely support it. Okay.
Did anybody have any questions for Pinder about anything? Oh.
Hey, Pinder. My question is, you said that there's a great need for mentoring. There are a lot of organizations that are geared towards women in STEM in and around the D.C. area. I'm sure there are some outside of the area. What should they be doing to reach demographics that ordinarily wouldn't have access to their mentoring or different types of programming that they provide?
Yeah, we have the same one in Dallas. I think it's great that those kind of organizations give us a good place to network and to kind of share experiences. But I think we need to do more of is not just talking to women who are already professional and in the industry, but reaching out to inspire young and upcoming women from schools and the universities, right? And where they still have not, we still have hope. We still have a way to show them options, right? So, for example, I go to my sons and my daughter's school, and on every year basis, we talk about what I do and how did we come to the place we did. And we talk specifically about girls and math and sciences. So reaching out to the people who are in schools and who are still making choices, I think, is needed.
Hi, Vincent Herrera from Montgomery County, and we are actually working on a lot of programs supporting at the high school, junior, middle school level. I want to ask you, do you think that there's a lot of interest now in coding for girls? Do you think those programs are actually helping grow women in STEM programs, or are there other things as well that we should be looking to help grow those numbers?
I think every bit helps. I do see some coding classes being offered even at my daughter's preschool. I'm like, preschool? But that helps. But I think that is not enough, because in my mind that is very narrow. We are looking at one thing, right? And you get tied into I'm learning how to code. What I think we need wider awareness of STEM engineering, because engineering and computer science touches every part of your life, right? And people can bring contributions in a different way. It doesn't always have to be coding. So I think that's where it's needed, is encouragement, information sharing at a lot higher level versus, I'm not saying don't do that, I'm saying in addition to that.
Thank you, Pinder. I want to thank everybody for staying till the very end. We are going to have some comments wrapping up the session. So we're going to have Mike Lynch, who is the president-elect, or Jody Miller, who is the president of NEPA, and Jeff Steinberg, who's the deputy chief of the Competition and Infrastructure Policy Division here at the FCC.
Well, as you can see, I'm not Mike Lynch, but Mike had to leave to get to his flight. So on behalf of Mike Lynch, NEPA's president-elect, I'm Jody Miller again. We want to thank everyone involved in hosting and helping plan this workshop today. A special thanks to the commission, Chairman Wheeler, and our two commissioners, Clyburn and O'Reilly, who came down and gave comments today, and the Wireless Bureau, especially Jeff Steinberg, Chad Breckenridge, Don Johnson, Greg Vadas, Dana Beta, and Cecilia, for all of your help in coordinating and running a good workshop today. And thanks to our NEPA's member cities, Philadelphia, San Antonio, San Francisco, and Boston, for your participation and flying people out here and participating electronically and giving your case studies. And to our industry reps, including American Tower, Crown Castle, and Extenet. As we've said throughout the day, no one is more supportive of increased wireless infrastructure deployment than local governments. We really have found that the more we talk and listen to one another, the better the outcome for everyone. And so we do hope that today's workshop is not the end of the dialogue, but the continuation of going forward and continuing to work together.
Thank you, Jody. And I second everything that you've just said. I want to maybe I'll take just a minute or two to give you my takeaways from today. If I were to try to summarize what we've learned today in a few words, it's a great, big, wonderful world out there. There are so many things going on, so much that technology is bringing us to stay connected. We learned an awful lot about the technology this morning and its practical uses. We've learned, if we didn't know it, that these DAS and small cells are the key to making all these things happen. That's where the world is. Doesn't mean we're not going to continue to need the macro systems, but that's really where the world is going. We learned that there are solutions. There are solutions so that deployment, the development, and all the progress can happen in ways that work for everybody and serve all of the different interests at play here, local, individual, national. Also, my emphasis on that is solutions in the plural. It's not one solution. Different things work in different places, different circumstances, different cultures, different backgrounds. These solutions don't happen by themselves. They require work. They require people, consciously, focusing on them. But the one common theme is that it's people working together. And it's not a question of if, it is a question of when. Deployment will happen, and so let's serve everybody and make it happen in ways that serve the public by happening quickly and collegially rather than slowly and contentiously. And finally, I would say that, we have lots of reason for optimism based on everything we've heard. There are lots of cities and companies that are all getting together and making things happen well. And so, for those of us who may be farther behind on the curve, or even for those of us who are well ahead on the curve but could make things work better, let's learn from that. Again, speaking of things that don't happen without people getting together and working on it, an event like this doesn't come off without lots and lots of contributions. So I want to thank lots of people, and if I leave anybody out, I apologize. But first of all of the speakers today, the moderators, everyone was well prepared, informative. Just a fabulous program on everybody's part. Certainly want to thank NEPA and particularly Steve Traylor, who has been our contact through all of this. Steve is always great to work with. I think we're pulling together in the same directions with NEPA, and let's do this again and not have it be another 4 years. Many people at the Commission, individuals who I want to acknowledge, beginning with several people from my own staff in the Competition and Infrastructure Policy Division, some of whom have already been thanked, some of whom have a public role, some of whom more behind the scenes. But they've all put lots of work into this. Don Johnson, Greg Vaddis, Dana Beta, who led the team on this project, Myra De La O, Jim Swartz, Saurabh Chabra, that they've all worked hard on this. Irene Griffith and Sharif Shariar, who were in today, taking questions, keeping order, and so forth. Acknowledge the support of my front office and the Wireless Bureau, the chairman and the commissioners, including those who came down to speak today. They all support this, and as you heard directly from them, it is a high priority as part of the three-legged stool that we heard about. Cecilia Solhoff, always a great resource. At one level, I almost think she puts on events like this in her sleep, but I know that each individual one takes a huge amount of effort. In addition to her MC role that you've seen her today, she is a fabulous resource to us behind the scenes, and we really couldn't do this as well at all without her. Our audiovisual staff, Jeff Reardon, Steve Balderson, Richard Williams, that's how those of you in the room and on the web could hear us, could see us. Tiffany Peoples, Dan is reminding me, was in the room today as well. And finally, all of you in the audience. This would not be of any value if we were just talking to each other. The value of it is that you're here, you're engaging. We got lots of great questions, both from folks in the room, from those of you on the web. I think many of you are coming to our workshop tomorrow on the environmental and historic preservation process. Look forward to seeing you there. If you're not going to be here tomorrow, thank you for being here. Safe travels if you're heading home. And I think we'll wrap up.